Hello and good morning. Don't be scared. I'm not going to do the Nick yell at me thing. I have understanding for mornings. It's day... No. Good morning. Have a calm morning. Diminishing attendance rate at the morning are normal, but I want to tell you, I love you even more for being here with me. I give you some secret informations, more than what you've seen every other morning, just so you can brag with what you've learned and go on with that. Also, let me a bit closer. It's fine. All the camera people try to get this, so let me help you. Yeah, of course, last day of the summit, and thank you for being around. The clicker loves me as usual. Just go one further if you want. So the usual start of the day is telling you to pick up your swag. And in that regard, you have heard it 4 times, I think, if I counted right, 4 or 5. And I assume the overlap of the people being here on time and the people having picked up their stuff is almost 100%, so thank you. But the secret information is, why is there still some stuff left? And in regard to that, I was talking to people. Step 1, what I learned is, when the hell do I pick it up? In the breaks. So, 11, 1, and 4 o'clock, that's the time you pick it up. And if you have yours, tell this to others. Tell them for a prize. Say you want something out of the bag if you go for that. The next thing I found is, where the hell is Princess Amalia? So don't go to the palace. Later today, you'll go towards the great party. You will go by the palace. Don't ask her there. Princess Amalia is the room right on the outside. So you see the outside on the picture. You see the counters. You picked up your badge. And there to the right, there it is. There's the swag. So you can go for that. And the last thing is, some people said, you know, Christian, I failed to sign up correctly, so I'm not entitled to get one. My badge says not applicable or something. You're still welcome. Welcome all the weekend. And in the last break, at 4 o'clock, we totally welcome people that want swag but have failed to sign up. So there, that's your time. That's where you can help yourself. I mentioned the party later today, so we'll be in the Grote Kerk, which is totally bad, sorry, all Dutch people. But there's great, summit parties are always great. This will be great as well. But the question there is, I tried to predict, okay, if picking up a bag is so hard, it might be even harder to make a walk journey for 30 minutes. How do I not lose you? So step 1 obviously is, are you allowed to go there? Because this thing says attendees who are registered. I just said registering right for the swag is going to be right. So I checked my email. What did I get? This is like, if you look for closing party and you're not a total party hopper, you will not have many findings in your inbox. And you will find this, closing party attendance, yes, which is in your inbox and helps you there. But how to get there? It's a walk of about 30 minutes. It starts at 7 p.m. So more or less after the closing, if you slowly pack up and walk over, you'll be good and you have fun there. But we had a great yell. I don't know if Mikael is around. This week we had QR codes all the time, and somebody said, do you know about security? Because who's comfortable opening random QR codes? I hope not everyone, because we are geeky people. So the next level of non-trust would maybe type a link. You at least see the domain. You can make sure the A is not a Cyrillic A with a different domain that I faked or something. But really, I know you. There's something better for your phones. So, if you totally distrust, you need a map. And I'm seriously concerned about copyright infringement sometimes. So I thought, a screenshot of Google Maps or something, that's not going to do it. So I sat down, I draw you a map. To the top left is your pirate ship that you came with. It lies in a harbor. We're in the World Forum. We go from the World Forum around the dark forest of the Zorgwille Park. I don't know if that's how it's pronounced. Palace, don't ask Princess Amalia again, no. Pass by the Paris, and if you find a hexagonal tower that looks like a church, that's where you want to go for. So, I hope that helps, and that's the secret information that you get that are here early and on time. Thank you so much. And without further ado, I think it's time to get the people with actual content on stage. You will see me more than you want over the day, so thank you for that. Now it's time for Gordon Marcus and Yuning Liang to talk to you about the unstoppable force. I'm still waiting for the immovable object presentation and put them against each other, but yeah, have fun.
Thanks a lot, Christian, for the great introduction. I think that's a really tough act to follow, I must say. But everybody looks so amazingly energized today, right? It seems like everybody had 1 extra hour of sleep right now, right? Yeah. We should do that every day, right? We should always set our clock a bit fast and do that way. So today, I want to talk to you about RISC-V. And first, a show of hands. How many of you know what RISC-V is? I think that's 99% of the folks here. So I think we won't bother you with a lot of details today, but we'll go into some of the details and see what our partners are actually up to. Last year, at the Ubuntu Summit, we had a great presentation done by John Roncombe from Sci-Fi. They described basically where RISC-V is, how it came to be, and what is the ambition of the whole RISC-V community. But this year, we have a bit of a different presentation. It's not a person who is representing the RISC-V ecosystem from the IP side, but they're actually building devices. And I think that deep computing truly embodies what we came here to set out in the Ubuntu Summit, which is basically giving the stage to people who are willing to challenge the status quo and disrupt. Because as you can imagine, RISC-V is still an emerging ISA. It's a growing ecosystem, but building devices, consumer-grade devices on RISC-V is really not for the faint of heart. And it's truly an amazing endeavor that our partners are doing. Deep computing, they are the pioneers of creating RISC-V consumer devices. And why is this actually so important, right? Because it moves RISC-V from the domain of being run in specific workloads, in microcontrollers where we don't see them. And it brings us closer to the developers where we can touch it, use those devices in familiar form factors, build software on top of it, try to port our projects on top of it, fail porting the projects on top of it, then fixing those problems, contributing back to the open source community. And this is exactly what the RISC-V ecosystem needed. And that's why deep computing was recognized during the RISC-V Summit just a week ago as one of the key contributors in the whole ecosystem. So I would like you all to warmly welcome my friend and partner, Yuning Liang, the founder of Deep Computing.
Hi. Hi, everybody. Hi, Rabbit. Thank you, Gordon. So for those who don't know me, I just do a brief introduction. I'm Yuling, founder of Deep Computing, doing some crazy things. So what we do, actually, we make the premium RISC-V product and RISC-V only. So we do consumer electronics, and we do, just now Gordon says, we make laptops. So, and loads of other people here on our website, we make some RISC-V power toy cars and balloons. So, and today I'm going to talk about a little bit about RISC-V and what's it all about and how we look forward. So, and RISC-V, the prospects to me is pretty good. It's the big dream. The dream is very big. And you can see one day we reach 30% of the ISA market against the current x86 and ARM, and you won't find other exciting opportunities around it. So among all, you can see it's hard for any other company not talking about RISC-V and doing RISC-V secretly, right? You can see a lot of big players. So we are up against a lot of fun party and partners. So RISC-V journey, is it hard? It is very hard. You set it up in RISC-V International, originally from US, and then they move it to Switzerland 2010. And we look at back, x86 is going through a hard time as well on the PC and server side against anyone we all owe enough here to talk about SPARC, HP, Unix, and SGI. But they're really big. It becomes very big from 90s and 2000s, and now still very big. So same as ARM, I used to run Nokia's feature phones platform software. So we all using ARM. The time we use, and the last project I used 1 gigahertz ARMs. They're not calling Cortex yet at the moment. So, but I've since on Google, Apple take over the ARM and push to mobile, and then Qualcomm, MTK, and start become the dominator. So, what's RISC-V? What it's going to do? Works really on PC, on mobile, on some other consumer electronics, or now everybody talk about large language models on AI, how, and from when we can scale up. So from 2020s, so by that time, when I realized, and there's much of the end user product, so I decided to do laptops. So, and then when I started DeepComputing, this startup, well, I look at the fate of RISC-V and destiny. Is it going to be like Linux, right? It's the past, and what about present? What about futures? What it looks like? So, x86 is a very close ISA. It's from US, it's driven by US, it's dominated by US, right? It's a close owned by Intel, now AMD, and recently established advisory groups. So ARM actually is from Europe, right? It's driven by the global. So you can see there's no one dominate specifically from certain regions. It's a semi-close. ARM owns the ISA, doing the IP, give it to the chipset guy to manufacturing to make the SoC. It's semi-open, semi-close. And RISC-V is opened up by Berkeley, by David Patterson, good old friend we used to meet. And then to avoid geopolitics, it moved to Europe. And you will find out it's primarily driven by Asia, especially in the chipset side. The IP side, still very strong in the US. So it's very open. It's ISA is very open. People heard about the recent news about ARM telling Qualcomm off, you can't use it, the ISA anymore in 60 days or something. So, but RISC-V is truly open. And what's the problem of RISC-V? Actually, it's a community-driven. It's going to go through the pain slow, very slow, long road, exactly the same as Linux. Be one day it's going to come. So how do we make RISC-V a successful reality fast enough? Right. Here, I'm sure a lot of we are all software guys, including myself. So, and we often talk about chicken and egg. The software guy waiting for the hardware guy waiting for the software. We all body spinning around the cycle. So we need to break these deadlock cycles. So what I do as from when I formed the DeepComputing, so I need to, I don't care whether I sell or not. I had to make the products. So, and then I had to involve all the existing players to make the product. And no matter their chipset is designed for their product. So, first of all, so, and later on, after finding the problem, market let me, telling me what to do, what's wrong, then I will inspire more people to join the dance, join the RISC-V stage. So you can see, when I make the laptop product, I get the IP guy, talk to the IP guy, talk to the SoC guy, and trying to make it. And it's really hard job. And then by the time then after hardware come in, and then the OS, the Debian was the only one supporting RISC-V on the main branch. So, and then we get involved with application browser doesn't work, and all these things, you know, it's very hard. And partnering guys parties is very challenging because you will see people have different goals. It's a commercial company. Most of us is still startup. We're trying to survive. Different goals, misalignment, and the chipset technical things. It's not out for it. For example, whatever the SoC I use, they never think about making it as a laptop SoC. And by the time we decided to do it, put everybody together, it's very resource and constrained and intensive because never think about it. So I do a way that we bring together different partners and they solve for things once at a time. And we, different stage, different partners. And also we will spinning around the circle, involve different partners. For example, when I do the hardware, I mainly involve the IP guy, Sci-Fi, Imaginations, and then the SoC guy like Star5, And then I sorted out the whole logistic about making the hardware motherboards. And then by the time I got the hardware, I found hardware is just a bricks without software. So, and we solved out the Ubuntu committed to us saying that you're free to use it, and we give you support whatever we can. I feel grateful. And then by the time I make my own laptop a few times, I'm sick of it, and then I get, a framework to support and give us a very nice and good longevity chassis and vision. So after that, the software, you find that the OS is not good enough, and because it cannot be upgraded, and myself doing all the brickwork, repeating, merging the kernel with the OS distributed image. It's a lot of hard work because kernel is not done, a lot upstream. So then all around all these cycles and patterns is keep improving and improving, trying to help RISC-V scales. And then the first step is from 2024. We got Cindy and Gordon's help saying that we are free to use Ubuntu's image and to a no-go and to help to promote RISC-V since the RISC-V Summit in Europe. So, and now all of our product runs Ubuntu from 2304, 2404 to now 2410. So it's without Mark and Cindy Gordon support, it's not going to happen. So, but for a startup, making a laptop, and isn't it very sustainable? I'm tired. I make 2 generations of laptops. It's getting better, but because the scale of it, the volume is not big, isn't a good approach to doing it. So yesterday, I'm sure you listened to Frameworks lining talks. It's relining 5 minutes. And if I know framework during the COVID, then I would have done my own laptops. It's so hard, so hard. I'm a software guy. I know nothing about structuring, I know nothing mechanical, I know nothing about all these things. So I'm sure everybody knows about framework. Now, let's welcome founder and CEO of Framework to talk about what his vision of Framework, as well as the mission, what he's going to do in the 20 years as a slide mark, set it up for Ubuntu for the last 20 years. So, and let's welcome Linov.
Great to see everyone again. This one's going to be a little less rushed than yesterday's lightning talk. Thanks, Yuning. So I talked a bit yesterday about this idea of ecosystem-based hardware. And one of the core concepts behind this is this idea of network effects, that there's sort of a supply side and a demand side dynamic, that if you have enough people demanding a certain thing and enough people supplying a certain thing, that you get this really healthy, basically ecosystem effect where both sides boost the other side. But today, actually, I'll very transparently, we have a 6-digit number of framework laptops out in the world, which is, on the one hand, a pretty big number, but on the other hand, a pretty small number. And so as we think about network effects, there actually is a little bit of a forced bootstrapping phase that has to occur, where either the supply side has to basically force the existence of a new device, or the demand side has to become so large that the supply side has to respond to it. And so being able to partner with DeepComputing, with Yuning, and with the folks at Canonical to be able to do this sort of forced bootstrapping phase to bring RISC-V closer to consumer level maturity actually ends up being pretty important. Realistically, we do need to bootstrap the supply side of enabling the RISC-V ecosystem. And so basically, thinking back to this idea of enabling that type of functionality from a hardware perspective, about 2 years ago, we actually kind of preemptively released a bunch of documentation under open source licenses, a bunch of CAD under open licenses, just dropped it on a GitHub, basically as a fishing expedition to see who would bite. We knew we didn't quite have enough documentation there for anyone to like take it and just build something, or at least that's what we thought, because it turns out that the team at DeepComputing did go and just take it, and basically after a couple of months of our first email exchange, come back with like, hey, here's the schematic, we're ready to go. Why don't you guys review it and give us some feedback? And so actually we're very impressed by how quickly the team at DeepComputing was able to pull together that main board and really, again, kind of blast through that barrier to that forced bootstrapping of sort of the first consumer-ish ready version of a RISC-V electronics product. Obviously, this first go-around, we're very much developer-focused. We look around this room, and I imagine many of you are here today because you would like to be some of the earliest developers picking up that combination of a functioning main board in a pretty usable system and kind of help to drive forward that bootstrapping phase as well. But this is, again, going back to this idea of 20-year vision, this is obviously among the earliest steps to that 20-year vision of getting to RISC-V as that 30% market share ISA, potentially even more than that as we look at how those ecosystem network effects actually result in these beneficial outcomes for users, developers, hardware makers, SoC makers, IP makers. Theoretically, this should be a stronger and healthier ecosystem 20 years from now than what x86 or ARM was ever able to accomplish in the last few decades, just the way the dynamics work out, similarly to the way the dynamics in the Linux space work out. And so again, as hardware makers, we're really excited to be there right at the start to do our part to help enable that ecosystem. And I'll hand it back to Yuning. I think we're going to do some Q&A as well.
Thank you. So, thank you. And you can see why I decided to do framework, because the innovation framework come out. The motherboard can turn it to a desktop. So yesterday, enough to talk about the laptop. Now today we talk about how good is that? You turn the motherboard laptop into a desktop, connect to a monitor and keyboard, off you go. And when I do my own laptop, I often ask, people give me excuses not buying RISC-V, even though they're working on RISC-V because they still need Windows. Right? Now, they have no more excuse. A framework, you can swap to x86, you swap to ARM, you swap to RISC-V. So the whole thing is open and up. Thank you, Nina, for giving the 20 years vision about the whole ecosystem. And one day, if Nina, whatever they sell in 1/3 is in RISC-V, my mission is done today. So we found another problem. When we started doing Ubuntu, we had to massage the SoC provided kernels with the image given by Gordon's team. We had to massage very hard. We remember the first time we merged 2304 with a 5.1 kernel. It's enormous hard work. Trying to get things stable is really hard. So I found one problem is that OS not able to build official image. In the RISC-V Summit, I bang on the table telling all the RISC-V chipset, you guys had to do better. And now upstreaming activities is exactly the same as probably 10 years ago Qualcomm and MTK, right? So now the SoC guys are making the same mistake again, not focus on upstreaming because they're hardware guys, they barely survive to trying to mass produce the chip with a mass produce quality, right? So, and then Greg went back in Hong Kong, the Linux conference, and Greg and Ines give me a hint. Go and read back the 15 years ago's advice back to x86 and ARM. So we got to upstream. We tell the SoC people upstream. That's why I showed this in the RISC-V Summit and bang on all the RISC-V SoC, help them to do it. Then before they finish tipping out the chip, they had to submit the kernel code. It doesn't matter whether it works or not. If it doesn't work, later on, we improve it. And if it does work, then now of the charm, right? So that's the advice from the Linux Foundations. So for 2025, our goal is for deep computing products, including all the frameworks, the RISC-V motherboard, we had to upstream. And all the Ubuntu release will straight away built against the upstream kernels. So feel free to backport it. So, and we partner, you know, a great guy, Alex and Daniel, pushing me so hard and let me understand how upstream is important. And then we have in this kernel, all the big guys help us to make sure that we are much more efficient to upstream it. And then we work with all my chipset I'm going to use, and I will enforce them to upstream. If they don't, I do it. So, and how do I do it? We back to Cindy's team. Email is there. So he's going to help. So he's going to work on the AI PC, the first one to deliver 2604, right? So, and more or less, we get some good guys, cool guys, who is willing to help us to do the upstreaming. So, right, so you can see, I don't know why Google Slides still have buggy, but anyway. So you can see my roadmap. So next year, 2025, even more exciting. Here, you know, remember the lightning talk, people want to see it runs, right? It's painfully slow. It's not going to boot in 2 minutes. So you can look up our booth, it does boot, okay. But and next year, we're very excited, right? We have 64-core build machine coming in and much better quality than last year. And we have an 8-core. I just got the chip out of the factory. I forgot to bring it in here, otherwise we'll show you. And so I have 40 TOPS of AI. We're going to put on whichever product sales. And then I might do one last my own laptop. We partner with Alibaba with a very good chassis and with Apple's AS qualities. So at long last, I'm not going to do any more laptops. Right? It's not my thingy. Really can't do it. I leave it to enough. The logistic, the hardware, oh my God, stress me out. And we do a 12, 16 core. So we are for a 16-inch framework, but we see how good is the chip. I don't know. They haven't given me the test chip yet. So let's see. So, and let's work together with this roadmap, and hopefully Mark yesterday come up to us and tell Gordon, can we make it to 2604? We will try our hardest to get it into 2404, but I need enormous help from Canonical in terms of the certification, compatibility, a lot of other works. Thank you very much. Thank you. And today is pretty early. See how many minutes left? Yes, we're still on time. And to appreciate you guys here, we are up for some question. And Gordon, you're coming back out? So, and I got a lot of freebies for you guys to up and early. And we take some questions from you guys on RISC-V. And I'm sure I will give you some exciting freebies. Anyone?
Don't be shy.
Don't be shy.
We have someone over there.
Should we go from?
Hi there. So my question is, how does RISC-V stack up in power consumption versus essentially computing power compared to ARM, or how it will be how it will stack up when it's ready for consumer use?
Oh, that's a chicken and egg question, you know. And it's not going to be honest. Next year we're still trying to compete in certain segment. It's not going to be perfect. Well, now we in our top KPI in the whole chipset wise is for sorting out performance first before we talk about the PPA on the power consumption. So that's the first step, and then we will think about how do we solve the consumption. So last year focus more on performance.
Okay, thank you.
Thank you.
So you're talking about performance. So and I saw on that, that nice slide for the next year roadmap. Where's gaming on this list? Like, I want a game on a RISC-V system.
Whoa. We should talk about it. At least I will get.
I have a Framework 16. I'll put a board in if you let me game on it.
Okay. Okay, and there's not just framework 16, right? We have a game console coming.
Ooh.
Well, enough we can talk about it.
I think the question is, how old of a game do you want to play? I know
It certainly can run Doom. We know it can run Doom. That's
Yeah.
That's
Well, we
important.
can ask Mark, back in the old day Ubuntu, what games plays? Then we'll do it. We will do that first. And in fact, I might work with Brad Smith Wukong. Get onto our framework console. All right? Good luck to me. And I might have to convince NVIDIA again, give me a GPU that run on frameworks laptop with a RISC-V CPU. A lot of convincing to do, right, Mark? You know?
Okay.
Thank you.
One last very quick question. The rest just follow them to the booth. They're here all the time. At the risk of clearing the room, please don't. The others are good as well. So one last one.
Can you describe the turnaround from your design to getting a chip on your hand?
You mean the turnaround time?
Yeah. And the process?
My style is really like military style, you know, startup, dictatorship. My guys are killing me, and you're killing me. Always, I do a motherboard, 3 months to EVT, and then 6 months to DV to mass production. That's our game. If anything beyond that, and then it's my job not doing good enough. So for the chipset, it's harder. Chipset usually they need once a year. You can see all these chipsets, the 64 core, they did it once. Last year they do a refresh, do it again, fix all the problem. And for the 8 core, this first time they ever done, they took them 3 years. But the refresh one is very quick. And for the 4 core, it's the 8 core half them, so it's simpler, so it's quicker. But for the 12 core, it's another vendor that they completely new. So it takes probably chipset is at least minimum 18 months. So most of the chipset startup is just have a chance, have enough funding to do 2 chips. If they can't scale, then they die. So hopefully I answer all you guys' questions. And remember, 3 of you. So, and come around my booth and collect the freebies. Thank you. Thank you. Back to Christian.
Thank you.
Thank you, Gordon. Thank you, enough.
Thank you so much. It was awesome. Okay, we see we can scale impact by the number of people on stage, so maybe you should plan for 20 people talk. Okay, people in background, change over to then welcome Thomas, who is telling us about Umu, and me always being hungry, as you might see, was thinking of umami things, and searching Umu, Polynesian cooking culture, hope was rising, but it's about gaming, which was your desire, right? So you get exactly what you want. It's about gaming. Welcome Thomas, who has just told me that his whole group that is above him was essentially created last summit. So the summit creates new collaboration. I love that. With that, let's welcome Thomas.
Well, hi, everybody. Hey, there's a step there, by the way. There's another step. Well, I like to be up front so I can see these a little bit better, but obviously they had roadblocks in the way. Yeah, I am here again this year to talk about our new project, Umu. So last year, let me get into a little bit about myself first. My name's Tom Kreider. I'm a software maintenance engineer for Red Hat, and that's my day job. But today, I'm here as the creator of Proton GE, or now renamed GE Proton for quite a while, and the co-founder of a group called Open Wine Components. We have created a new tool in Linux gaming space called Umu. And I know the name sounds odd. I'll explain it later. It does make sense, I promise. So how it started. Last year, myself and others in the Linux gaming space were invited as a group to Ubuntu Summit. It was just a couple of us. It was myself, a couple of people from Heroic. It's a GUI launcher for games, as well as Lutris. We also had Eric, who was a member of Valve's company, who was with our group. And we started to talk about how Valve launches games using a pressure vessel. So if you aren't familiar, when Steam runs games on Linux, they use Proton. And Proton is the actual set of tools that runs inside a container which is launched by Pressure Vessel. So that's what I pretty much just talked about there. Valve describes Pressure Vessel basically as a bit like a simplified version of Flatpak for Steam games. It's used by Steam's container runtime, the Steam Linux runtime, compatibility tools to run games in individual game-specific containers. So basically, when you launch a game from Steam using Proton as a compatibility layer, it does this. First, it runs Pressure Vessel. Then after it runs Pressure Vessel, it runs a container, and inside that container is the Steam Linux runtime container image. That container image itself is built off of Debian, and inside the packages are mostly just Debian packages, but a couple of them have been modified by Valve for gaming on Steam. So that runtime is really important because it's also what Proton and all of Proton's components are built on. So when Proton is compiled, it's compiled within that container, within that runtime. So the reason for that is because obviously with everything containerized and being able to both build Proton as well as run games inside that container, you have a solid, steady target for getting things running consistently no matter what system they're on or what distro you're on because of, again, it's containerized. The reason for Pressure Vessel itself is because it allows certain things from the host to pass through, graphics driver differences, things like that, that may not necessarily be something you can use within the container by itself. This is pretty much what I just told you. Gives a little bit of a more detailed rundown of it. It has the Reaper, which runs the Steam launch command, and the Reaper itself is basically a process monitor, so that it can keep track of PIDs whenever it gets launched. And Steam Launch goes into the files for the Steam Linux runtime, and it runs this v2 entry point. The v2 entry point is what we originally target in UMU. And what happens with the v2 entry point is basically Steam feeds it a bunch of options and environment variables that Pressure Vessel needs in order to run properly. So at the bottom here, we see that the verb is one of the things that it feeds to Proton. It launches Proton itself, and then it launches your game, all within that container. And again, the v2 entry point is what we use to target to run Pressure Vessel. This is a little bit of a chart of how that looks, and you could make some differentiations. This is just a very rough chart, so people can get a general idea of what's going on with that whole situation. Obviously, you can see the main containerization happens with the Steam Linux runtime, Proton, and the game. Pressure Vessel is mostly just a big bash script, to put it easily. So yeah, the reason to use Pressure Vessel and the Steam Linux runtime. Again, I'm going to hammer down on this. By using this, again, you have a containerized environment. And by using that containerized environment with specifically the Steam Linux runtime, you're able to make games run consistently and have a consistent target no matter what system or OS it's on. I mean, we had, right before the summit, we actually had somebody in our Discord that messaged us that said they were able to use UMU to get OSU running on Ubuntu 14.04, which was really funny. Yeah, I saw that and I was like, okay, that's kind of crazy, but they did it. We didn't intend for it to go that far back, but you know. For comparison, if you don't understand why the container's important in terms of libraries, when you have different distributions, they're going to have different library versions. So, like, one system might have library SO version 4.5.6. Steam Linux runtime might have version 1.2.3. If Proton is built using Steam Linux runtime 1.2.3, and you run Proton outside of that container, it might have conflicts with version 4.5.6. So again, if you run it inside the container, you get the proper library that Proton needs, and you don't hit those conflicts. A more common library that I can probably use as an example, maybe for other games in the past, would be glibc. That's always been a fun one, especially with anybody that's familiar with easy anti-cheat. That was, glibc broke easy anti-cheat a couple of times. Okay, so we're going to go back to how UMU does allow Pressure Vessel to run outside of Steam. Again, we're targeting the V2 entry point. This entry point is basically a monolithic bash script, and you feed options to it. So what we're doing is we're basically, in that big chart that I showed you before, we're taking Steam and taking that out of the picture, and instead we're replacing it with UMU. And so what UMU does is it'll feed all of these options and environment variables to Pressure Vessel, which then, of course, launches the container, launches Proton, launches your game. And by doing that, we allow UMU as a tool to change those options and to, therefore prepare the prefix the same way that Steam would, or feed different environment variables to it in terms of like non-Steam games. Let's see what else we got on here. Yes, okay, so I've got a couple of points that I just boggled my mind for a minute. When I say launcher, a lot of people think like, oh, well, we already have a Heroic, or we already have a Lutris, or we already have a Bottles. UMU is not a front-end GUI tool. It's a CLI, client. It's a command line interface tool, a command tool. And the reason we went with a command tool is because we wanted it to be able to be used as a back end for these other tools so that we can unify everything. Before, they would use maybe like different versions of Wine or specific different builds of Wine in order to run their games, and they would build those versions of Wine natively on their system. And then, of course, you have different problems per different system because they're not running in a container. Now, with UMU, we've kind of resolved that because everything's running within Pressure Vessel. We've also made it work correctly within a snap. As well, it's a dev snap right now. We're working with quite a few people that are involved in the snap environment in order to get that correct. We've also got it working in a Flatpak, as well as within Heroic and Lutris inside the Flatpak. And we are working on getting that upstreamed, as well as we have the CLI tool itself set up, almost ready to be submitted for official Flatpak. And it also works inside of Valve's GameScope session. So if any of you have a Steam Deck or run Bazite or anything like that, you might be familiar with the GameScope session. The GameScope session is when you log into the Steam Deck and you see the nice Steam interface, and you can easily check, move everything over and check with your controller and select whatever you need. That is a GameScope session. It's a full user session running inside GameScope. And GameScope itself requires some specific window management in order to do things properly. In fact, they actually run two sessions that you have to bounce back and forth between for certain windows. So we've got all of that managed within the last year or so, and that is just the launcher side. So UMU is a couple of components, but the launcher part is what we're talking about right now. We'll get into the other parts in a bit here. So what sets UMU apart from just adding a non-Steam game to Steam and running it that way? Let's say you have, Red Dead Redemption 2. Let's say you have the non-Steam version on Epic, right? Red Dead Redemption 2 has patches inside of Wine, and inside of Proton's version of Wine, that only trigger with the Steam Game ID. So if you don't have that environment variable set with the Steam Game ID for Steam, those patches inside Wine are not going to trigger if you run it with Proton. So obviously, if you add the game as a non-Steam game and you don't have that environment variable set, it's not going to trigger those fixes and it may not work correctly. And because of that, some people don't know. A lot of people don't know that those environment variables exist. Most of us, if we're Linux gurus or tinkerers, we're going to figure some things out, but the general public, they're not going to know about that. So what we do in UMU is we have a set of Proton fixes. Proton fixes was originally part of just Proton GE and originally just for Steam games. And the way that works is it would see the Steam game ID that was assigned by Steam. It would then go through Proton, and we integrated it as an extension for Proton Fix. It's just a little Python script. And when it hits that, it searches for the ID, and then it says, okay, we found this ID, we found a fix for it. Let's go ahead and apply that fix. And so now we can apply that fix to other games. What we did is we decided, let's take that and extend it to UMU, and we're going to have to do that the same way that Steam does. We're going to take any non-Steam games that need fixes, we're going to build a database, and we're going to assign them IDs. So we've now, within the last year, got 1,000-something entries in our UMU database for non-Steam games that also apply fixes that usually would apply to Steam games or are fixes that are needed outside of Steam. Yeah. To give you an idea of what those fixes might be, it's something like if you've ever in the older times run Play on Linux and you went to go install a game, you might be familiar that they have install scripts that they had, which would create the wine prefix, and then it would do a couple of different things inside the wine prefix. Maybe run wine tricks, which did like DLL overrides, or registry edits, or specific tinkers that the game might need. Well, there are still games that still need that stuff. Lutris does the same thing with their install scripts, with a lot of games. So in order to keep that and do that with Steam games, we needed Proton fixes. So we did that. And the problem with the original approach, again, was that it was just Steam game IDs. And again, what I said is we extended it outside of Steam. We made our UMU database, and we started the UMU database and put it all on GitHub. The UMU database, the contents itself are just a comma-separated value sheet, a CSV sheet. We've got guidelines on our README for adding content or committing content for games that need fixes, and so that anybody can just read those guidelines and submit an entry to the CSV sheet. That's the easy part. What we also did is we set up a very basic MariaDB or MySQL database, import it, and what we do for that is we import the contents of the sheet into that database. We have a website, simple website front end. It's just written in PHP. It's meant as an example. And you go to the website, it has a search bar. You can search for the game, find the game ID, and then either set it as an environment variable, or these launchers like Lutris or Heroic or even Bottles further down the road can query the database. And how do they query the database if it's just a PHP website? Well, it's not just a PHP website. We also created API endpoints for that website to query the database. So they can say, okay, we don't know the ID, but we know the store, we know the title, we maybe have the code name that the store gives us. So like Epic Games, if you own a game and you launch it, within the process manager, you can see what the code name is. So Lutris will see what that code name is, feed that information into the endpoint, and then get back the ID. That'll feed it to Proton, and then, well, GE Proton or UMU Proton, and that'll trigger the fixes from GE Proton or UMU Proton. So we decided to move forward as a group here, and I can't see because of the timer here. So we decided to add entries to this database and Proton fixes so that across the board, any games would work with these fixes. There's not, hopefully, not going to be any more, well, this works on Lutris, but it doesn't work on Heroic, or this works in Bottles, but it doesn't work on native wine, or it works with wine staging and it's not working with standard wine. Hopefully, you're still, if you run them outside of this, you're still going to hit those differences, but if you're running something that has UMU as a back end, they're all going to be using the same back end, the same build of Proton, the same fixes, the same database, and the goal is to have everybody hitting the same target, or if they hit bugs within it, have the bugs be a little bit more on the same page. So that way, we're not shooting in the dark in terms of trying to fix it. Our database, again, it started at the beginning of last year, or this year, and it's grown to past 1,000 entries. Currently, that's what the database entry will look like from the CSV sheet. On top of that, we've created, again, the basic website that I told you guys about. We've got an example of what it would look like if you search those entries on the database. And obviously, you can see we did a search for Age of Wonders. You get the UMU ID, you get the GOG version or the Humble version. It shows you what Proton fixes are available if it has Proton fixes. One thing about the UMU ID that we did is if it is a non-Steam version that also exists on Steam, we assign it UMU dash and then the Steam ID. And that way it's able to parse the second part of the Steam ID in order to apply those Steam fixes, regardless of whether or not it has an UMU ID assigned. So it'll take that, add it, and set it up as the Steam game ID, and then it triggers all those patches that I told you about and why. Let's see what sheet we're on. Let's see. The website, of course, has all of our API endpoints. We can do, list all of our entries, list, check on based on store, check based on title, UMU ID, store code name, all the game values if you need the game values, get the title, UMU ID and store, get all the game values and entries based on UMU ID. Those are the entry points we've set up for right now. If people need more entry points, we can add those. We've also put all of the code for the website and the endpoints on GitHub as well. So for example, if people want to host their own copy of the database, or host their own copy of the website, or host their own endpoints, they have examples of how to do so. Or if they just want to host them directly by themselves in like a little tiny Linode or something like that, they could do that. The whole point of this is to be able to have a way for these different GUI launchers or different tools that exist outside of Steam to be able to pull that game ID and get those fixes, make it easy for them. So the entirety of the website, like I said, it's up there. That's the full website itself. You can go there, and well, that's the database, the GitHub database. We also set up a simple cron job on our database server to basically just import the CSV regularly. There's different ways to do that. That was just the easiest off the top of the head that we did. An example use case. So, good example of using UMU rather than adding a game directly to Steam as a non-Steam game is Star Citizen. Star Citizen, these are a couple of the tasks that are in the install script for Star Citizen in Lutras's install script. As you can see, it will install VC Run 2019. It'll install Arial font, try and set it to Win64 for the architecture, and it does that through Winetricks. And then, of course, you see we have an environment variable. This environment variable isn't needed now, but up until recently, it was still needed, and that was a workaround for the anti-cheat. So those things, and of course, we also have to disable PowerShell for the launcher itself because the launcher has some problems with PowerShell in Wine. Normally, if you were to just add it to Steam as a non-Steam game, Steam's not going to know about it. The user's not going to know you have to do those things. So how do you do it? Like if you add it and it doesn't run, you're kind of like, well, what do I do now? That's where UMU comes in, and the UMU database, and the UMU launcher, and the Proton fixes that we added, because it will do all of those things for you as soon as you hit the play button. And it'll walk through, this is pretty much what I just explained, it goes through all of the things that you need to do inside that script. And at the bottom is an example of using the CLI tool, the UMU CLI tool. Wine prefix sets up your prefix. Game ID, we use the Star Citizen ID. Proton path, you can use GE Proton or leave it blank for UMU Proton. It'll automatically download the latest version of UMU Proton if you leave it blank. Or you can put in a full path to whatever specific version of Proton you want. UMU run is the command name itself, and then the game executable. Of course, that's a little bit long because it's doing a bunch of environment variables, and we generally don't expect people to use a bunch of environment variables. We expect them to use the front-end GUI tools like your Lutris or like your Heroic or anything else that might use UMU as a backend. UMU will then create a prefix after you run that command, and it'll do, this is more along the lines of what a Proton fix looks like inside of UMU. It's Python code. It's very short, very simple. Basically, we have a folder with a list of different stores, and, well, a folder with stores that are all separate folders, and once it has the game ID, it parses through that list of stores to find what store, what game ID is associated with that store, and then it pulls a fix, something like this. And that is where we do the same thing that a Lutris script would do, or a Play on Linux script, or a Heroic script, things like that. Of course, tools such as Lutris and Heroic may not know the game ID, UMU ID, and again, that's what the API endpoints are for, and this is an example of how you could query one of the endpoints that I showed you before. And once we query it, we see it returned in JSON format, which is UMU ID and then UMU star citizen. Lastly, we explain we understand people may not want to use GE Proton, or they may not want to use the latest version of Proton. They may want like a more stable approach. And you can use normal Proton with this. You're not going to get the Proton fixes if you use the normal Proton, but you can use normal Proton with this perfectly fine. And then we also have what I've been referring to as UMU Proton. UMU Proton is simply a copy of the latest stable version of Proton with UMU compatibility added, and there's maybe like 2 or 3 other patches added for a couple of specific games. That's it. We try to keep it as plain, simple as can be, and as stable as the normal one. We don't want to touch too much on that because we know people like their stable versions. How do I use UMU? Well, like I said before, you could use the CLI tool if you want, if you really want to use it directly. But right now, Lutris has it built in. If you select a Proton version in Lutris, it will automatically use UMU as the backend. You can choose any Proton version, and Heroic has UMU built as an option. So you don't have to use it currently, but it's there. And again, if you select a Proton version in Heroic and then go to choose use UMU as a Proton runtime, it will select UMU as the backend. So there is also these are a couple of examples of things that use Proton as well. The Decky loader, if you are familiar with Junkbox, it's been in the news recently because of being listed on Steam, then listed off of Steam. But Junkbox also has a Decky loader plugin, that's what it originally was, and they use UMU as on the database side. So they're not using our launcher tool, but they are using our database in order to apply fixes. So that would be another thing if you just wanted something that was directly inside Steam, and you don't want to worry about going and downloading an extra tool like Lutris or Heroic. Junkbox, as far as I recall, they currently handle Epic games and GOG games, and they have plans for Amazon games too. So if your games fall in those categories, you can use Junkbox, and it will also be able to use that database. If you want to use a CLI tool, we have instructions right there. If you just go to our releases, it's right there in a README on how to use it. You can follow on GitHub for instructions for currently building the Snap or Flatpak. Again, we are working on getting those things to an upstreamed release so that you won't have to build them. Right now, like I said, they do work, but you'll have to build them if you want to use them. This is another example of CLI usage. You can use either use the API or the website, find the UMU ID, and optionally, if there's a store, search for the store, and then you set up your wine prefix, set your Proton path, set the game ID that you found, UMU run star citizen. And then optionally with the store specified, we have the store in there as well. TOML file configuration. So let's say maybe you're not using Heroic, or maybe you're not using Lutris. In that case, we have also made UMU able to read basic TOML configurations. And here we see an example where it gives you options to set the prefix, set the Proton version, game ID, executable, launch arguments, and a store if you want. And you can simply set up a whole bunch of TOML files if you really want to, or maybe decide to use that as the backend or like part of the configurations for a whole nother GUI application that you might be developing. And wine tricks. So you can also use wine tricks with UMU. We have Winetricks built into part of Proton fixes. It is kept updated regularly. We have made it so that if you pass any of the options from Winetricks to Umu, it will parse them correctly, use the runtime, and apply those Winetricks inside the runtime the same way that some of you may know what Proton Tricks does. It kind of does the same thing, but this actually runs it inside the container, as opposed to, well, Proton Tricks will use the prefix, but as far as I recall, it doesn't use it inside the container. Okay, so will you tell me why it's called Umu now? I kind of rushed through this, so I've got a little bit of time left. Will you tell me why it's called Umu now? An Umu is an above-ground oven of hot volcanic stones originating from Polynesian culture. After the stones are heated, the top layer is removed, and the food is placed on the top to heat or cook. So we took that concept, and we said, well, Valve's tool is called pressure vessel. And basically, if you were to take a pressure vessel, say like a pressure cooker, you would put it on a stovetop. So we are basically building our stovetop, which is our Umu. And once we clear the top layer of that stovetop and we put our pressure vessel on top of it, we are preparing pressure vessel. And that is where Umu comes from. That's the end. I am very, very early on time. I kind of planned this to be a little bit longer, but last year I kind of went over time. So if you are interested, stop by the OWC, the Linux gaming booth. Our group is OWC. We aren't a company or anything like that. We're not trying to sell anything. We're not trying to do anything, or we're not trying to give try any product or anything like that. We are just trying to unify a lot of the people in the Linux gaming space that have these tools to kind of do everything the same way, so we're not hitting a bunch of different weird, crazy bugs per this, per that, etc. You can find us on GitHub, Open Wine Components, and that's pretty much it. I guess we've got 20 minutes for questions if anybody has any questions. And again, I do apologize. I know I'm quite a bit early this time. I tried to not go over the time like I did before. Thank you very much. All right, go ahead.
So before my question, I just want to say thank you for the best written Snapcraft YAML and the best written Flatpak YAML I've ever seen.
Thank you. We put a lot of work into those. I appreciate that.
Have you had any interactions with Valve or Codeweavers related to Umu specifically? I'm wondering if they might be interested in starting to hop on board this and unify.
Well, I am friends with quite a lot of the people from there. We actually have a separate Discord that we all talk in, and I've been associates with them for the last 5 years or so, ever since I started GE Proton. They are not involved with this project, and obviously a lot of them are contracted by Valve these days, so it would make sense if it's a conflict of interest or something like that. I understand that. But again, our goal was basically just to allow non-Steam games to run the same way, because we all appreciate what Valve has done, and we really like the way that they made our games just work. So we want to extend that, we want to expand that, and I think they do hopefully appreciate this, even if they're not able to officially condone it. But I haven't heard anything against it yet. I haven't had anybody yell at me, thankfully. So for anybody watching or anybody watching from that Discord, hi, I'm sorry if I offended anyone. All right. Go ahead, Neil.
Yeah, so this is all great, and you talked a lot about using this to configure Proton wine environments. How well does this work when you're trying to say, if you're using just a regular wine staging or a wine environment? Because for example, Fedora, a lot of the stuff that typically ships in Proton is actually already shipped as part of wine staging, which is Fedora's default wine. So can UMU be used to work with the system-wide environment to be able to support Windows applications and games through that?
We are actually we are actually planning in the long term of supporting not only separate wine builds or wine staging builds within the container, but also native Linux applications as well. Because at the end of the day, it's a glorified, modified Debian container.
Right.
You can pretty much run whatever you want in it. The other thing, though, is with specific regards to wine or wine staging, I think we would need to build something like Proton, but for applications.
Okay.
A little bit separate away from that, because there are, again, a lot of components related to Proton. And if you're doing standard wine inside the container, even if you're running it in a container, you're probably going to go back to ending up building specific versions of wine that have certain patches, and we kind of want to avoid that.
Sure, right, yeah. The main thing I'm thinking of is like this stuff with UMU is actually really great because games are complicated and horrible and all this other stuff, but there's also productivity applications, there's also,
exactly.
Like I have to file taxes and I would like my tax software to work on Linux too, and it don't. So
right.
That's the sort of thing that like it'd be interesting to, if we could reuse this kind of architecture for that sort of thing.
Yes, I agree. I totally agree. We definitely want to get there. And the other thing is we don't want to step on the toes of existing stuff that already is out there. For example, your Flatpaks and your Snaps, who also try to get that done, but not specific to wine or Windows applications. So I think this could be a very good use case for Windows-specific applications that we want to get going within the same environment. I know CodeWeavers does have their software as well, Crossover, which it's amazing software. If people are not familiar with it, I recommend to check it out. CodeWeavers is fantastic, and their software is great as well. Mm-hmm. So yeah, I would say that's something to check out, but we do plan on also tackling that in the future.
Cool, thanks.
Sure. Anybody else?
So I have a question, because sure. UMU and Proton GE and Lutris Heroic are great projects, and how one does contribute to UMU without coding knowledge, for example, extending database, what else, basically?
Okay, well, the easiest way, if you have, for example, if you want to fix a game or you know a fix of a game, is to go to the GitHub, the UMU database. We have guidelines. Like, you don't have to have coding experience to add an entry to a CSV sheet. Like, it's just a straight-up comma-separated value, right? So let's say you have a game that needs a fix. You submit the CSV entry, and you can submit that, and then we have UMU database, and we have UMU Proton fixes. You can submit that, then go to the UMU Proton fixes, open up a ticket, and say, hey, I don't know how to code, but I know maybe it needs like a DXGI override or like a direct 8 input override for a DLL. You can say, I know it needs this DLL override. Can you guys add that? And we can totally do that. As soon as we see it, we'll pretty much just say, okay, sure, not a problem. Very, very easy to do that way.
Okay, great, thank you.
Sure. Well, anybody else? Any other questions? Gaming related? Probably Diablo 4 currently, yes. I've played a lot of Diablo, and my second favorite would probably be the entire Doom series. I'm a big Doom fan. So yeah, that's what I got. Anybody else? Last minutes? I know we got 15 minutes left. And sorry, I'm a little bit early here.
What about Universal Windows Platform?
I'm sorry? I didn't... Actually, Heroic is working on getting some games from the Windows Store working, which is kind of wild. They did a lightning talk on that yesterday, which is very, very cool. So hopefully, if that comes to fruition, we can migrate that in as part of UMU, if it works that way. We still have to look into it, but I thought that was very, very cool that they're getting that to work. I think they had the Windows Store version of Minecraft working, which was pretty awesome. Kinda. It launched, at least. All right. Well, if nobody has any other questions, I will go ahead and hand this back over to our guys here. And I appreciate everyone here that has attended. Anybody that's been watching, I appreciate you guys. And I hope you guys enjoy the rest of the summit.
Can you just wait for me until I'm back on the stage?
Sure.
Okay, back again. So yeah, you might say, how many introduction can Christian do to essentially close over 15 minutes? So long story short, this is what I came up in 5 minutes. It's about worth 2 minutes, and then we're going to be back on track in a bit to give everyone a chance. So when I heard distroless the first time, as a person working on distro for my job, I was like, no distroless, that means without me, that sucks. And so, is it really distroless? To be honest, if you look at philosophy, we have this famous example is to be without sin, the same as to be sinless. And if you read through many threads, way too many, you will find most people consider it the same. So majority wins in philosophy. That's the way it works. So damn it. If you look for the dictionary, both the suffix of less always turns into without or free of. And without is a preposition, which means in the absence of. So damn it, it's again without me. So it is a sin. It's a sin to be without me. That's not what I want. So to be fair, distroless is great marketing. It's a short word. It works. But to be fair, it does not follow the definition of philosophy or dictionary. To me, it's way more Dean, which might be overloaded if you studied in the States or something, because it's distro exactly as needed. Sadly, my words never win. With that, we have about 10 minutes to really get to the people who know this shit, which is Christopher, to give the people that are at booths and other places a chance to follow. We start right at 30, like 1:30, as we intended. So do Christopher a favor and stay, or at least come back. This is interesting, even if you're not into philosophy. Thank you, and see you in about 10 minutes-ish. Okay. Welcome back to most of you. Yeah, take your time to see it. It's fine. Maybe we need to yell a bit, even though it's not my style, to get the people back due to this 10 minutes break. I don't know. You know what? I'm going to break out and rush the people back in for Cristobal. You all have fun with DistroLess. This time without an existential crisis for myself, but with the details that Cristobal can provide to you. Awesome. So, without further ado, give him some time, and I kick in some people to attend further. Thank you so much for staying with us.
Good morning. My name is Chris. Don't try the whole thing. I'm very grateful for Christian's introduction because, in fact, I'm going to talk about something which seems like it's distroless, but it's not really about removing any distro, so I'll talk a bit more about that in a while. I am with Canonical. I've been doing cloud and edge computing for quite a while, and in that time, I started working with containers, and at Canonical, my team and I, we work on the processes and practices of building containers, a new generation of Ubuntu-based containers at Canonical that we call ROCs. And we support the tools that help us build those containers. Rawcraft, for which you will have a workshop just after this talk. And the other one is Chisel, which is the topic of this talk, right? So again, we are not gonna talk about creating distroless containers. It's more about how do you think about using that concept to create something which is still Ubuntu-like, but just a slice of it. That's what the tool Chisel is here for. Now, if you are new to the container space, I just want to give you a very brief introduction to what it is, and it's just yet another virtualization technology. Now, the point here is that you want to isolate your application in a software unit that contains all the dependencies for your process to run. And some of you might be thinking, oh, that's very much like a VM. Sure, the difference here is that with containers, we are not virtualizing the whole operating system. We are not using hypervisors. With these containers, we are basically making use of Linux namespaces and C groups to find this compartmentalized space where you can run your process. Now, containers have been around for quite a while, and with the popularization of the technologies and the tools around it, they have become quite accessible for people to build their own images and run their own containers. So the practice was so accessible that people were just, OK, I'm just going to start from a base. I'm going to add my application. I'm going to add some build tools to build my software, the dependencies, and then I'll just snapshot everything into an image, and that's it, right? The problem here is that that was the practice, and it still is in some cases. I'm not saying it was the best practice, because you would end up with very, very, very chunky images that would affect your network performance when you have to pull that image to deploy and to pull the forthcoming updates. And if that's not a problem for you, because you might say, I have a very fast network connection, I don't pay for network per the byte, you might also consider the attack surface, right? The more things you have in your container, when you have deployed it, the more things you will have for attackers to exploit, right? You might have stuff in your container, utilities that you have used during the build, stuff that was there from the base that you have used that you don't need for your application to run, but that others might exploit at runtime. So you want to avoid that. Now, with that came the concept of distroless. And not to kind of re-say what Christian said before, the concept itself is quite neat, right? And that's a practice that we want to follow, but we don't want to remove the distro from it. But the concept itself is saying that you want to pack just your application and its runtime dependencies. And runtime is the key here. You don't want the build time dependencies, right? If I'm going to run, I don't know, if I'm going to run some compiled application, I don't need the whole SDK inside it when I deploy it, right? I've built it, I have my executables, I have my binaries, I'll pack that, and only whatever other libraries and dependencies I might need at runtime, nothing else. So that's what we want to do here, and that will help us achieve this secure and minimalistic container image. The question is, why doesn't everybody do this? Why? If we are talking here about Chisel and distroless and secure container images, why is it that nobody or everybody is still kind of fighting between fully bloated chunky images versus distroless. So the thing is that doing very minimal and super secure distroless-like container images is kind of still a specialized practice. It is not as easy as just building something from a base and just adding all of your software components in your application. Sometimes it might require specialized tooling. You might need some deep distro knowledge. And in many cases, the mindset is that you would start from that base, do your usual process of getting to your application and dependencies packed in a certain stage in an image, and then you'd go top-down and trim it down to all the essentials. And that process is sometimes a bit error-prone, because what you are doing is that you are inflating a base to have all of your dependencies and application, and then you are going to cherry-pick the things that you need from there. You are going to say, I need my application and those dependencies because I know my domain. I'll need that. And the process of doing this is sometimes very manual. You are not using software like package managers that will help keep your provenance and tracing everything you are keeping in your last stage of the build. So it makes things a bit more complicated in the build process. It makes things also a bit less transparent at runtime. And there's a study here which was quite interesting where they took 6 popular vulnerability scanners, no names, and they scanned 20 of the most popular images in a public registry. Now, apart from misidentifications, false positives, and all that, one of the things that was a bit concerning and that I cared about the most is that at least one of those tools, again, no names, was unable to identify vulnerabilities in at least one container, had more than 16 plus of those unidentified, but all of them had some, right? So all containers had unidentified vulnerabilities up to 16 CVEs. Now, this is what we call false negatives. It's not being able to see things that are there, so it's blind spots. And one of the reasons for this is, in some cases, because those scanners rely on data that is inside the container itself, metadata, information that the package manager has put there for others to read. And if that's not there because of that cherry-picking process that you use to get into your final stage, then those scanners will just fail to identify things because they will use common identifiers to match a certain software component to a known vulnerability. So those false negatives and blind spots, they are usually the culprit behind either intentional or unintentional lack of transparency. And what I mean by this is that I did a very quick exercise here. So I took an image. This was some time ago. It was 2404 from Ubuntu. I think there were a couple of low CVEs there. And let's say that I'm not trying to do this on purpose. I could, or I could do this as a mistake of the cherry-picking process, but I am removing a file, a single file from that system. After doing so, 2 of my scanners came back with 0 CVEs. Same thing for Docker Hub when I uploaded my image. So this is just to say that even though it sounds a bit counterintuitive, scanners do rely on the information you put there. So you can intentionally trick them, or unintentionally, with this cherry-picking process of making a very small distroless image, you might forget to put the right information there. So this is the fallacy of complacent distroless containers, right? You see it working, you have built it, you achieved a very small, tiny image, your attack surface is reduced, and it works. So if it works, you don't fix it. And because you don't see the CVEs, they are not reported, you just assume everything is OK. So that's what we are trying to kind of work around here. So we are trying to make a kind of a shift on the practice here. Instead of going top-down, which is the typical distroless approach, we want to keep the distro. We want to start from the ground up, and we want to create a sliced version of Ubuntu, right? That's what Chisel is here for. This is a standalone tool that you can use anywhere. And what it does is that it goes into the Ubuntu archives, and on the left side, you have your typical list of dependencies. Let's say for an application, I have package A, B, and C. That's what I need for my application to run. But with Chisel, we have identified that, well, sometimes you don't need all of that. So what we can do is that we can, in advance, declare subsets of those packages that we call slices. And slices are declaratively defined in YAML files that we call slice definition files. And you will say, OK, slice A, B, C, they have different contents, because I know that from package A, I might just need certain libraries. From package B, I might just need that binary and some data file from there. So you actually know what your application needs, and you can leave out other things that you know are necessary at runtime. For example, man pages or some other binary that you don't need. It's a utility. You can still define dependencies as you do on any Debian package between slices. So on the right side, when you do something like Chisel cut, you are cutting those Debian packages from the Ubuntu archives. This specific example here is just showing you the notation that you would use. So it's the package name, in this case, libc6, underscore is the notation, and what comes after that is the slice name. And because we have dependencies between slices, Chisel will look into that, act as a sort of package manager, but just for slices, and give you, out of that, a brand new Chisel Ubuntu file system. So if you want a quick analogy, just look at Chisel as being something that installs Debian package slices. apt installs Debian packages, Chisel installs slices of that. So I have a very, very, very simple example here. It's just to illustrate that, let's say that you want to have users in your system, right? What you can do is that, well, you know that you might only need a couple of files from a package that delivers those files, which in this case is base password. It's a well-known package. But you only need a couple of files. That's etc group, etc password, all right? However, that Debian package has 17 files, 2 dependencies, and around 250 kilobytes in size. With Chisel, we can create this slice definitions file, and we define one slice. We call it data here. And you can virtually create any number of slices that you want. But here we call it data, and we are saying, actually, I want 2 paths from that Debian package. I only want etc password, etc group, right? That's what I need for my final file system. And here, just to illustrate what you can also do mutation scripts in Chisel. That is to sort of try to mimic the post-installation and maintainer scripts that you'd get from a Debian package. So the result, if you do this, is that you would end up with your container, your file system, your Chisel file system in the end, that still has user management capabilities, right? But it only has 2 files and 40 kilobytes inside, and no other dependencies whatsoever. So I have a quick demo here just to kind of show a bit how Chisel operates and how you can use it as a standalone tool. So you can run this anywhere. So it's not a container-specific tool. So here I'm just doing Chisel help, standalone. And let's say I want to cut a few slices from Node.js. I will Chisel find for a specific release, in this case 2404, Node. I can see that there are a couple of slices there. I want to get more information about these slices, so I want to see what they have. So I'll just do Chisel info for the same release. I'll paste those slices there. This will give me the slice definitions for those 2, so I can parse these with the YAML parser. And I can see that there's a beans slice with all the Node.js binaries in there, and there's a copyright slice that just has the copyright file. I don't need to specify that. It seems to be already a dependency of beans. So for my installation now, I will just say that I want to cut the Node package, and I just want the binaries in my final rootfs Chisel file system. So I'll put that there, and I will add another slice that I will explain later, but it's a dedicated slice for you to get something special that is now available in Chisel as well that we call the manifest, which is there in the last line, a manifest.wall. I'll show you that later. But you can see that Chisel didn't just take Node. It went through all the dependencies that slice needs, extracted those packages, and the slices that are needed to make those binaries work. So here I'm just going to make sure that I actually have Node.js in my rootfs chiseled Ubuntu, and I'm just going to do a hello world. Let's just assume that for the sake of this demo and this presentation, I want to run a hello world, okay? So it's there, seems to be working just fine. And now to that file that we saw earlier, the manifest.wall. This is a Z standard compressed file, which basically it's a manifest. If you ask for it, Chisel will create a file which has a format that we call JSON wall. It's just a file that has a sorted list of different JSON lines where it specifies at a file level all the paths from all the slices from all the packages that were installed in that chiseled file system. So this is quite useful because it will give you a nice entry point, and due to sorting, it's an optimized way for searching through the manifest that you can use to generate, for example, SBOMs and any other files that could be useful for scanning your chisel file system later on. So here I can see all the packages and versions that I have just installed. So let's copy this into a container image, right? I want to copy the rootfs with this Docker file into a Scratch base. So I'm just going to do it with Docker now very quickly. I'll create a node with a tag chiseled. I'm going to copy that rootfs there onto Scratch. And I'm going to do a comparison with all the node images that I have on my system. So the chiseled one is 100 megabytes decompressed, more or less. And in comparison with all the other ones, you can see the difference. Those are the official ones that you get from Docker Hub, both LTS, LTS Bullseye, and Alpine. And I'm just going to run it again, the same thing as I did on the previous example with Schut. You can see that I can get the Node.js working there the same way I would. Of course, this image is smaller. It might have less capabilities than the other ones, the counterparts I've compared to, but that's because my use case is the hello world, right? I just want to execute that. I don't need anything else, and that's why the point here is to slice the package down to the absolute essentials that I need for my application. A second example is, why do I need to chisel cut at all? Like, we have another tool that's what you will see in the workshop after this session, which is called Rawcraft. And here we work with declarative recipes, YAML files. I have two examples, one on the left, which is kind of a distroless rock. It starts from bare. There's no base there. It's similar to Scratch. Both YAML files are like that, but you can see, in this case, I'm doing Python 3.11. That's my application. But on the right side, I have a chiseled rock because I am installing just a core slice of Python 3.11. I know that I just want to run a hello world. I don't need all the other fancy modules that come with Python 3.11. I just want the core. And this slice is already defined. So I will build these two rocks with Rawcraft. Again, check our workshop after this for doing this yourself. And from the get-go, I have two rocks, one with 28 megabytes. The other one is less than half of that. And if I try to run them, you'll get the same Python interpreter, the same Python version. And for my use case, again, which is a hello world, you will get the same functionality, right? It's just a core functionality. So why would I want to have an image that, even though was started from scratch, distroless-like, it would have much more than what I need. So I just want to keep things to the essential for my application to run. So that's kind of the summary of what you just saw. Plus, on the left side, I've added another example to showcase what you would do the easy way today, which is not even start from scratch. Start from something like Ubuntu, a proper base, and then install Python in it. This would be a rock, right? And it's 42 megabytes. That's probably the most common type of images that you would find in places like Docker Hub. The middle part there is the example we had on the left in the previous demo. That is the bare base, so it's a sort of distroless-like rock with Python 3.11, 28 megabytes. We saw that. And then finally, the chisel rock, right, with just a core slice of Python. And again, 13 megabytes. And by comparing it with other counterparts, both distroless and non-distroless in public registries for Python, we saw a 61% plus CV reduction. And because it's so small, and we already do certain things in this YAML recipe, as you can see, we are running with a non-root user, we were able to achieve off-the-shelf compliance with certain standards like CIS and STIG. So that's pretty much it. I would like you to give it a try. And again, feel free to join us just after the break for the workshop. You'll have a chance to play a bit with Rawcraft and also slice a few packages and create a few chiseled rocks. You have the two projects there. They're both open source. And you can also contribute there, especially for chisel and chisel slices. We are creating a distro of slices that follows the Ubuntu archive. So for every package, we are creating more and more slices to slice down those packages. So you can help do that. We would welcome you there. And if you have questions, we also have a community space. You can find us on Matrix, or you can find me somewhere, or on LinkedIn as well. So feel free to ping me, all right? And thank you for joining me here. That's all. I think we have 4 minutes or so. So if you have questions, just feel free to. Otherwise, we can take some time back. All right, I think we're good. Well, thank you very much. Thanks.
Thanks, Christopher. And by the way, we can extend your video with the security scan of Pro, so next time. Okay, so here's the trick. Now is a break. We see you again at 11:30. But this really is your wake-up call. If you haven't picked up your stuff, now is the time. It's a good time. At the spot right at the entrance to the right in the Princess Amalia room. So have a go and see you again in about half an hour. Thanks. Hello, everyone, again. Wow, what I'm blinded. Okay, somebody stumbled onto the lever of the light, but that's fine. Hello, back again for the state of Ubuntu Desktop on ARM64. This morning, Yuning had the great example of RISC-V, and there he mentioned that there's a particular kind of developer who just does not accept to use the same thing as everybody else, and they're just breaking through barriers to enable other hardware. And Tobias, who is presenting to you in a bit, he's just this kind of person. He can just not accept that everything works. He uses, if it would work, I'm sure, he would change his hardware to something that fails and make it work again. And that enables him to be a great person for enabling Ubuntu Desktop on ARM64 and many other things. So I'm happy to introduce him, and let's see what new progress and challenges he has found over the last recent months. Thank you.
Hey. So you might remember me from last year where I talked about Ubuntu Asahi here. This time I want to expand the scope a bit and talk about the general state of Ubuntu Desktop on ARM64. So this will include Ubuntu Asahi, but also a few new things. If I asked here, who of you has used or seen Ubuntu Desktop running on an ARM machine, I'm pretty sure there's quite a few of you who have. And what you're likely thinking of is something like that. A small single board computer, maybe a Raspberry Pi. This has been around for, well, a while now. I was told we've been shipping desktop images for Raspberry Pis since Ubuntu 2010, Groovy Gorilla. The flavors had images even before that. It took a time for hardware to catch up with the requirements of our desktop. More lightweight desktops worked before that. This is not actually what I want to focus on today, even though it's still part of the ecosystem and profits from a lot of the things I'm talking about. So what I actually want to talk about is desktop hardware, proper desktop hardware, that has only become available in the last few years, right? This started with Chromebooks adopting ARM. There's a ton of cheap MediaTek Chromebooks out there today. And then in 2020, Apple started switching over to their own silicon chips. And those are probably the most widespread ARM devices, laptop devices we have today. And there's new exciting developments we're seeing. Windows on ARM is slowly catching up. There's new Qualcomm platforms for Windows on ARM that are widely available. If you look at the current Snapdragon X Elite release compared to the previous one, there's like a ton of manufacturers that build laptops with this chip. So what has changed in the last, let's say, 4 years since we have our Raspberry Pi images is you can actually buy an ARM64 computer or laptop. I would have put the System 76 one on the slide if I had known about it. But the slide was done before I learned about this. But very exciting as well. So let's look at the current state. We just released Ubuntu 24.10 Oracular Orioli 2 weeks ago. What a release. Tons of awesome improvements. GNOME 47 fixes fractional scaling. We have a bleeding-edge Linux kernel, which is always exciting for us running on the latest hardware, right? Permission prompting, apt UI improvements. But something we haven't been very loud about that also happened with 24.10 is, if you look at our cdimage.ubuntu.com website, there is an ARM64 desktop image that popped up. And this is something entirely new. We did have images for specific hardware before. This time we're trying something different. We're having a generic ARM64 installer. But what is generic? What is even supported here? So currently, this should work on any generic UEFI and ACPI machine. It will work in most virtual environments. I've talked to people who use Ubuntu on Macs in a virtual machine. If you previously had to install a server image and then install desktop packages, you don't need to do that anymore. You can use this. And then if you've been at the summit or listening to the talks last year, you might remember our Ubuntu concept for the X13S ThinkPad. So everything we learned also went into this image. So it also just works out of the box for this hardware platform. And this brings us closer to where we want to get in the future. I think one thing we need to improve on in the ARM ecosystem for laptops to work better is we need to reduce the entrance barrier, right? We need to make it easier for you to just install Ubuntu on your machine and run it. And something we have announced very recently, just after the Oracular release 2 weeks ago, is a new Ubuntu concept for 2410 targeting the Snapdragon X Elite platform. And this time, different than our previous Ubuntu concept, we are not targeting a single laptop. We are instead trying to target the entire Snapdragon X Elite fleet and try to get as much of this working as we can. This is currently working, but very bleeding edge, and mostly suitable for developers and enthusiasts, which is why we call it a developer preview. And the goal here is to bring the community together and give them something to get up quickly, to test quickly, and ship the latest features and shorten the feedback loop. Right. So one problem we have is things are getting committed into the kernel, but how do you test them and who tests them? So we hope that we can contribute by making this image readily available and get more people to actually test the latest changes, and then get the feedback we gather back to the developers, back on the mailing list, and getting involved in the development. It also allows us to experiment with our generic image and try new approaches to make this work better. And this whole thing is meant to be very community-centric. We want everyone to be able to contribute, and we want to reduce the barrier as much as we can. So one thing we did is we asked our community to help us figure out the device information on some of those devices. Because when we started, we were kindly provided a ThinkPad T14S Gen 6 by Lenovo, which I have. But that's only one platform, though. So I went out and asked the community to help me figure out how those other machines look like and what we need to get them running as well. And the responses we got were amazing. Like we now have, I think, 10 hardware devices checked in a bug tracker. We have people coming in telling us the info we need to make the installer just work out of the box. We also have people coming in telling us which patches we might need to cherry pick to get those working in our kernel tree that we use for this particular image. And the most exciting thing is we've seen upstream contributors come in and help others, like the people who actually contributed support for some of those laptops, come into a bug tracker and help users sort out their issues and then learn from what they see there, what is reported by the users. So in just under 2 weeks, we went from 1 supported laptop to 5 platforms, whereby supported more like working, right? What I'm talking about here is something that boots into your live environment. You have a working live environment, and then you can go through the installer, install an Ubuntu system, and it boots up and you can use it. There's still features missing, of course, like it's very bleeding edge. We don't have audio support on all of those machines. There's a few peripherals we need to sort out. But still, I think for just 2 weeks on bleeding edge hardware, this is amazing, and I want to thank the community very much for making this possible, because this is mostly the community's work. Now, another hardware platform I'm very excited about is Apple M1, M2. I am also a developer in the Ubuntu Asahi community. As I said before, last time I presented our current state. So here's a little update on what changed in this ecosystem. In terms of feature support, we do support everything M1 and M2 all the machines you could get. We do not support M3s at this point. A few features were added since I last spoke about this. The most exciting ones are speaker support. Thanks to the Asahi Linux team, we have excellent speaker support. I'd say it sounds just as good or better as it does on macOS, on those platforms. It uses pretty advanced post-processing and active speaker safety management to drive those speakers as good as we possibly can. We've added HDMI support, which is, I guess, quite exciting, something a lot of people have been asking about for external displays. And another more recent addition is a ton of improvements in the graphics space, thanks to the amazing work of, among others, Alyssa Rosenzweig and Asahi Lina. We've got Vulkan working. We've recently added OpenCL support through that, and our OpenGL support is also excellent. There's a few things that don't quite work yet, which I want everyone to be aware of. This is USB-C display support, the built-in microphone, Touch ID, and Thunderbolt are not yet there. But even then, I would say this is like the most feature-complete ARM platform you could buy today, which is very cool because it's entirely community-driven. So I want to quickly talk about the Ubuntu-specific improvements we did in the last year. One of the things we added is this beautiful first setup. After installing your initial installation, you're dropped into this menu that allows you to click through something that looks just like the Ubuntu installer, set up your time zone, language, user. So we've made the entire flow a lot nicer, I think, for the average user. Previously, you had to configure your system by hand on the terminal. I think the Asahi Fedora folks have had this for a little longer. But we really, so this is something coming from Ubuntu that we enabled in our images, and I think it's pretty cool. We also added support for Ubuntu 24.4.1, so there's images for those available on our installer. 24.10 updates work and are enabled. And one of the most exciting additions is GPU acceleration in snaps. Those are generally a little tricky to get right, because a lot of snaps tend to bundle Mesa, and we are on bleeding edge hardware. We need a patched version of Mesa itself. In 24.4, we solved this by having a Mesa content snap and a new GPU interface. And our Mesa content snap has a separate channel for our Asahi Mesa drivers that we pull in automatically on those machines. And for user, snaps will just work perfectly fine. And I think that's very exciting, even though it's by design very non-exciting. But that means stuff just works. If you want to try this, here's a QR code to our website with more info on Ubuntu Asahi. I will also show a link later again. Now I've talked mostly about positive things and improvements, but I want to be a little more self-critical, right? Let's talk about a few things that are not great yet, a few things that we need to improve on to make this as good as the Intel experience is today. And the first question I want to ask is this really generic? I said we want to build a generic installer image, but is it really? And the truth is, we try to make it as easy for you as we can, but we do need to employ a bunch of tweaks to make this work. And that's because on the hardware side, on the firmware side, the ecosystem is still very fragmented, right? And not just that, there's also problems upstreaming changes into the mainline kernel, and a few of hardware-specific tweaks we need to make for each of those platforms. One limitation worth noting here is, for example, that for the Snapdragon platforms, but also for Asahi, we don't have a proper solution for secure boot yet. We use device trees per machine device trees on each of those, and we don't have a way to sign them in grub. It works, so this is not as much a problem on the Asahi side, but certainly on the Snapdragon side, where the devices themselves don't give us a device tree from firmware, so we have to handle this as an operating system, which is not the way it is intended to be, but that's what we have today. So I think we are very early here in terms of the ecosystem, and I hope that standardization will solve some of this. Another one I want to talk about is we are hitting bugs, and I'm sure not all of those bugs, or many of those bugs, are not because of ARM or because of Asahi, but they are because we're doing things differently than they were done before. On the Apple machines, we're hitting bugs because we're using a non-standard page size in the kernel. There's also bugs coming from non-uniform CPU cores, and a lot of things that are about to become a thing, but we are at the forefront, so we're hitting them first. And I believe that there's also a bootstrapping problem here, where there's just less testers on those platforms, so you're more likely to be the person hitting the bug. So how do we solve this? I think there is not one real proper solution to this, other than making hardware more available, getting it into people's and developers' hands, and making sure everyone catches those early, right? So we basically need to get more eyes onto things. And that brings us to the next one. I think we have another bootstrapping problem. Can you guess what those apps have in common? They're not available on the Ubuntu store for ARM64. But in fact, Chrome is a bit special because it's not available for ARM64 at all, right? I guess the same goes for Steam. Some of them are just not available as snaps, even though you can download them for ARM64 from the vendor's website. Chrome is a huge blocker because it is what we would need to enable DRM video content. So if you're into watching Netflix, that is not something we can do today, or not easily do today. And I think many of those are actually a blocker for professional usage. So if you look at the bigger picture, people like to think the software situation on Linux is way better for alternative architectures, and that is right in a way. Specifically, if you look at binary packages from our archive, we can see, well, RISC-V. I included RISC-V here because it's an even newer platform, right? RISC-V, ARM64, x86 are very close in terms of support, very close to 100%. In snaps, the story looks entirely different. So this is, by the way, based on public data. Poppy did a Mastodon post last year where he looked at snap support through the public API. Numbers might be slightly off, but I think it's the best we got to work with. And what we're seeing here is, for us, as Ubuntu, it is easy to enable new platforms because we just flip a switch in Launchpad, right? We willingly gave that control to the publisher in snaps. Same is true for all other channels of where the publisher controls distribution, right? And they might not be as passionate about new hardware as we are. So what can we do to improve the situation? There's something we already do. We provide Launchpad builders to build your snaps in our build farms, and you can do this on ARM64 as well as you can do it on x86. I think there's room for us to improve and incentivize publishers to also include alternative architectures, and I think we might have to improve our documentation and our defaults to make sure this is what anyone does by default, right? So you should have to opt out to not have an ARM64 version of your software. There's also something positive to see here. As I said, RISC-V is even younger, and we see ARM64 is, I think, at 37% availability. So I'm pretty sure it was way worse like 2 or 3 years ago, and we see ARM64 ramping up, even though I wish it would go faster. And now let's look at something positive again, exciting new developments. We have Neil from Asahi here today to talk to give you all the details about this at our booth later. There are people out there who are pushing the boundaries of what we believe is viable and possible today. And just, I think a week ago, or maybe 2, Asahi announced AAA gaming on their ARM64 platform. And I think this is very exciting. And what they're doing is they're emulating x86 on ARM in a VM, because they're also emulating 4K pages on a 16K page native kernel. And they're also emulating Windows compatibility, because they're running Steam and Proton. And this all works, right? And this is performant, and this is usable. And what we see here is that we are one big community, and we are pushing boundaries in those community projects. But I'm pretty certain that all of what we learn there will come back into the ecosystem. And it's something we can utilize to make everyone's experience better. So I'm pretty sure that what Asahi has been doing here is going to be leading for other distributions. And we will see a lot more of this in the future. So a quick outlook. A very similar stack. So the emulator they used to run x86 on ARM is called FAX. FAX is on GitHub. They built a PPA for Ubuntu, so Ubuntu is a target platform for them. And I actually gave it a try on my Snapdragon X Elite platform. And it turns out it just works. I can run Portal, I can run Steam on a new Qualcomm laptop. And I think this is exciting. This is the way forward. This might even solve a bootstrapping problem to a certain degree. I've heard people didn't bring their laptops because, I know, their note-taking app didn't work. So maybe we might have a solution at hand here. And I think we should try to get this into Ubuntu, try to make it accessible, and find ways to integrate it in a way that stuff just works for our users. And this brings me to the end. I put a few links on here, both for the Apple Silicon side, our Ubuntu Asahi website, Asahi Linux, IRC channels we are on, as well as information on our Linux and Snapdragon projects. Please visit those. And I want to ask you, if you are interested in this topic at all, please visit us at our booth later after the lunch break, because the next 2 talks are very exciting as well. And please get involved in our projects. We are community projects. We are always looking for contributors. And if this sounds interesting to you, and if you're into ARM64, I think we'd be happy to work with you. Thanks. I think we do have a bit of time for questions, if anyone has any.
This was really interesting, and I have a technical question, and just basically know nothing about it, so tell me anything you can. What do you see the end game for the page size? Do you think that's going to converge on something, settle on a pair, or there's going to be some phenomenal solution that makes it irrelevant?
I think the end game would be for the kernel to be able to handle this per process, or more transparently. That is not something that is possible today. On the Apple platform, we are using a 16K page size because that is what the hardware is built to do, right? That's what the IOMMU operates on. So you don't want to run everything in 4K. So that's not something Linux can easily do today. So I think this is really on the kernel to grow support for being more fluent when it comes to page sizes. But I think we will see more diversity there. I think the newest Raspberry Pi by default also ships with a 16K page size, and we do have servers on 64K pages. Again, I think we're very early in this space, and we need to wait for solutions to develop and applications to become aware as well.
Thanks.
So my question is, what exactly prevents laptops that have ACPI support to boot using built-in ACPI in software rather than per device DTB?
Okay. That very much depends on which laptop we're talking about. In the Qualcomm case, the way they are using ACPI is very much not compatible with the Linux implementation. So Upstream decided to go for DTBs instead. There's nothing on a sane platform preventing you from doing that. It's just like we don't have hardware that properly works like that.
So another quick question. How do you feel to have a virtual character as your colleague?
Can you repeat that, please?
How do you feel when you have a virtual character as a Helena as your colleague?
How do I feel?
How do you feel?
I think that's exciting. I think her streams are impressive. Every time I watch them, I learn something. And I'm humbled to have such smart people working in this space with me.
Okay, thank you.
Thank you, everybody, and thank you, Tobias.
Thanks.
There's an additional request for Tobias out of the live stream comments. They picked up that you seem to have a cold, and let's give him an extra applause for staying straight and doing it still.
Thanks.
Which means there are people that are watching you from the back all the time, so you need to realize that. The next group we're bringing up talks about T2 Linux, and it's a whole group, like all these enablement folks. Tobias on ARM, this is now, again, yet another Mac thing. I wanted to check something quick, because I've read through the description of the session that's about to come. Who of you owns or has a 2017, 2018 Intel-based Mac? 1. A few hiding, 2, 3, 4, 5. Great. Awesome. Now, we won't be for time. You're definitely part of the audience that I went for, which means I have about 50, 60 other people that want to be kernel developers for this team, because the list said you either have this old thing and you want to know how it works, or you want to help them being a kernel developer. So without further ado, and so you learn what you do next week with them, it's Mark, Aditya, and Woo Yun that will present you about T2 Linux and bringing Linux to Macs. Welcome them. Advancing your slides. Have fun.
Testing. Works. Good afternoon. Today we're talking about bringing Linux to modern Intel-based Macs with T2 chips.
Good afternoon. I'm Aditya, and at T2 Linux, I currently maintain Ubuntu, the kernel, as well as the ISOs.
I'm Mark. I manage T2 Linux community.
I'm Woo-hyun. I maintain Arch Linux, Endeavor OS, kernel support, and distribution support.
So, what exactly is the T2 security chip? T2 is a specialized security-focused system on chip for Intel Macs. Key functions are managing some USB devices, like keyboard, trackpad, touch bar, and the camera. Controls audio, such as speakers and the microphone. Manages NVMe SSD, houses secure enclave for encryption, and handles video encoding and decoding.
Yeah. Now Linux comes into the scene. Yeah. The main obstacle is that no T2 driver will exist in the mainline Linux kernel, which means no basic input device support like trackpad, keyboard, and touch bar necessary for ESC key for some Macs and function rows. And so but there was someone called Pawlowski who breaks through everything and first achieved NVMe SSD support, which it landed on Linux 5.4, and developed the critical Apple BCE driver with 3 components, which is not still on Linux mainline, is still out of 3, it's not even on staging, it's too experimental even right now. There are 3 components. First, BCE, which manages basic T2 communication, so we can talk to T2 chip and get the result back. And second, VHCI, which manages internal device support like keyboard, trackpad, touch bar, etc. And thirdly, audio support, so you can use your speaker, earphone jack, and mic.
Yes. So if we talk about the progress of our project, so thanks to all the community-led efforts, we established the T2 Linux project. And currently we have managed to make the internal hard drive, the SSD working. We have basic hybrid graphics support, and the keyboard and trackpad works perfectly now. And the Wi-Fi and the Bluetooth are also good. And we'd like to thank Asahi Linux as well for this, because they helped us to develop the drivers for them. And the FaceTime HD camera, which is basically the webcam on the MacBooks, and the touch bar also are like just awesome currently. But although some features above still may have some minor bugs, but overall the project is quite usable now.
So looking ahead, our key goals now are to implement T2 SCP support, so maybe we could get fingerprint reader working at some point, and fixing suspending and resuming, which was broken recently by macOS Sonoma update. And there is challenge to find more kernel developers and hardware experts to help us to reverse engineer upstream drivers and to write the Linux counterparts.
Current situation, we are now maintaining spin-off versions of major Linux distributions, including but not limited to Ubuntu, Linux Mint, Fedora, Arch Linux, Endeavor OS, and Nix OS. Also there is support for Cache OS, which is maintained by Cache OS team. There is also official upstream support in Blend OS too, but the Blend OS support is currently postponed because of my personal schedule, so keep in mind that.
So from the project, I would like to request help from all the kernel developers who are quite experienced in the Linux kernel across the globe, since we are facing shortage of them. And we also wish to raise awareness about our project to the general public, because not many people even today are not aware that this project even exists. And we'd also like to thank Canonical for providing the platform to us.
If you want to see a demo of running Ubuntu on T2-based Intel MacBook Pro, then you can check out in our Linux on Apple hardware booth. Thank you for listening. If you have any questions, we are happy to answer them.
Also, check out our website. You can scan our QR code. Any questions?
Not anyone? I suppose not. Thank you.
Thank you, party people. Thanks. All the clickers over there. So we suddenly gained some extra time. Gladly, the next session will need some setup time, but not 25 minutes. So I guess to give everybody a chance to attend that is now currently at booths and other places, we will continue at 12:30 sharp. This will be your countdown to get back to us. Unexpected break. I hope we can make something of it. We have plenty of questions this morning. Maybe this is your time to check out the booths and come back in time in 25 minutes for the next session, which is about Mir questions to solve around completing a desktop environment based on Mir and Wayland. So see you in a bit. Hello again. Thank you for being back or staying here. Both counts. Next time when you come back, just grab a few more people and bring them back as well, because usually halfway through the session, everybody realized, oh, right, I wanted to be there. So just drag someone on next time. That would help a lot. Now we see Miriway, the Worlds of Wayland as a title. After this morning session where Neil yelled that he wants gaming on RISC-V, I was assuming he ports Wayland to RISC-V to make gaming. Maybe it works already. Does it work already? Yeah, okay, so done. That's all good. So if gaming on that works, what else can we make working? And for that, we have Alan and Neil talking to you about Miriway. Welcome them.
Oh, it's dark out there.
Yeah, no, it's quite the audience.
Yeah. So let's check the audience. Because we don't want to make assumptions. Who knows what Wayland is around here? Hands up.
Awesome.
Brilliant.
Well, I saw some people waving their hands a little bit like that, so maybe
Okay.
some people are unsure.
Yeah, oh, should I explain it?
Let's go. Or not. Wow, the computer
it
finally
happened.
the computer finally does actually go to sleep. Today we learned.
Yes. So, Worlds of Wayland. So, well, let's start with who Neil is.
Yeah, sure. So I am a person who, I like to call myself a professional technologist and open source advocate. I do a bunch of stuff in lots of open source communities. A lot of people know me from the Fedora space, but I'm also involved in OpenSUSE, and I've done a little bit here and there in the Ubuntu space. I'm in CentOS, a bunch of other venues. And as part of the work I do in desktop Linux stuff, I am involved in KDE. I'm a member of KDE-V. I also am part of the Xorg board of directors as a member. And I also have a podcast where I talk about open source, enterprise, desktop Linux, the whole works. And for my day job, quote unquote, I am a consultant with my company, Velocity Limitless, where I do open source engineering consulting, architecture work, and that sort of thing for people out there across wanting to do fancy things with Linux.
Okay, I'm Alan Griffiths. My day job is team lead on the Mir team. The Mir team is many things to do with the management of Windows on various devices, from embedded devices to desktop computers to whatever the future brings. And I'm also a hobbyist software developer. And one day, a couple of years ago, I was thinking, well, why don't we have Mir on the desktop? So I sat down and did a little bit of hacking. This was in the Peak District in England. It was a nice sunny day, and my wife said it was far too warm to go walking. She was right, of course, but the result was Miriway. We get into Miriway, but with the teaser before, we took, say, Wayland. Wayland is a protocol. It's a way for applications and a compositor to discuss what ends up on the screen. Because it's a protocol, it's just like any language. You can have lots of people speaking their version. Neil speaks American English. I speak British English.
My English is better.
Well, but we can work together. So there's multiple server implementations of Wayland, Western, Mutter, Kwin, WL Roots, Smithy, Mir. There's a whole string of those. And on the client side, they're typically part of toolkits such as GTK, Qt, SDL, Electron, Flutter. But the point is that Wayland is replacing the language that was used before. It's replacing X, because the people maintaining X got fed up with it and decided to go away and do something different. And it's here, it's coming, and it affects things. In particular, it affects desktop environments. The desktop environments such as GNOME and KDE have done a lot of work in getting Wayland to work for them, for their compositors, for all the elements of their desktop, and they have switched, largely. But not every desktop has the resources to do that work. They've already got their regular maintenance and feature development. They don't necessarily want to develop their own Wayland compositor, and in any case, they're going to have to migrate their docks, bars, launchers, and so forth to Wayland. Mirway is intended to help a bit with that process because it's just an off-the-shelf Wayland compositor. It does traditional floating window management. It's configurable, so you can add your own collection of docks, launchers, and so forth. You can configure what the key bindings do. It's got support, because of Mir, for on-screen keyboards, remote desktops, hybrid graphics, all the things you want to run a desktop. It's based on Mir. There are other desktop environments or compositors based on Mir. Ubuntu Frame is Canonical's product based on it. Miracle WM has... Is Matt over there?
He was over there.
He was over there. He must have moved.
Oh, he's over there in the other corner.
He's on that corner now, right.
Yeah,
there's
so...
Lamiri, which also has a representative or two sneaking into the room. Yeah, over there. All based on Mir. So it's not just me that's using it. Mirway itself is only 1,300 lines of code. It's straightforward GPL3. It's not the canonical CLA because it's my side project. And it's got configuration options for all the stuff we talked about. It's available off the shelf, has a snap. It's available from source code. It's used, because I've been using it for most of the last couple of years as my daily driver desktop. The Mir team use it to demonstrate features of Mir. It gets a few drive-by contributions for things that upset people. And Neil will tell you, it's coming soon on Fedora.
Right, so I brought it into Fedora Linux. It's in Rawhide now to be aiming for Fedora 42. So let's talk about practically using Mirway. So demonstration slide, right? Well, you know, what if it was here the whole time?
That's it, live demos.
Yeah, that's the live demo part. But we already figured that part out. And that is, if I replug and unplug, you could see that we have a LXQt desktop environment with all the things. I can go ahead and pop up WayCheck. If you've heard of this, WayCheck is a little graphical application. If you've heard of, there might be a little tool called Wayland Info or all these other things. There's command line tools to be able to see how your compositor works. This is a fancy graphical way that lets you see it more visually and in a much more interesting way. So you can see we have all these fun Wayland protocols implemented from upstream, from the standard Wayland protocols, WL routes, and some of the, on the unknown category, you can see some of the ones that are special that no one knows about, including, well, that curious Mir shell thing. I don't know anything about that. We'll find out someday what that means. But hey, there you go. You see XGG cell, Vir portal, fractional scaling. You got all the good stuff here. And, you know, there's the windows floating around, doing the stuff. And yeah, this is running on here, LXQt 2.0. Running on there, and let's pop up a little terminal so that I can show that this is Fedora Linux 42 running LXQt 2.0 on a Wayland environment. And, you know, it just works. There's nothing really particularly special about it. You can see the panel down at the bottom. It's got the nice little Fedora logo. Some things don't work because this is actually an in-progress port by the LXQt project upstream to actually adapt their panel to Wayland. As Alan mentioned, right, the desktops have to port the components of their environment to run on these Wayland protocols to speak the correct language. And this is essentially in a preview state in the upstream, but I was able to put it together with Alan's help to make it a functioning, working environment that is actually running on this laptop with multi-display and apparently working power management to our nice surprise and things like that. So we'll just go back to, oh, I should just probably close these windows, yes, and go back to this, and Control-Shift-P. Oh, that is definitely not the button I wanted to press. Now you know that I don't actually know how my web browser works. Control-Alt-P. There we go. So how this early experiment that you can see here is actually essentially made up of 3 files. I set up the login manager to use Mirrorway. I set up the shell configuration, so it's just a simple INI style-ish file that declares what it terms shell components, like the panel, the background, and things like that. These are what, in the Wayland terms, if you've ever heard the word privileged client, that's what Mir calls shell components, and that we define these applications to run that way. And we have some key bindings to be able to do the basic stuff and things like that. You could tell I didn't memorize any of these key bindings because I hit the wrong ones, but that's okay, it's fine. And then you have the Mirrorway session, which was setting all these variables, because it turns out the LXQt panel and the LXQt session stuff, shall we say, is not quite adapted to run on Wayland fully just yet, so it needed a little bit of help. And so we did that, and then at the end you see it launches Mirrorway with all the Wayland extensions turned on, Wayland extensions being all the extra Wayland protocols that Mir has not yet fully turned on by default, since we're using some tech preview stuff and whatever. So the end result, as you saw earlier, because we were doing this the whole time, is this. We have an LXQt desktop running on Fedora with Mirrorway, and this is all packaged and available in Rawhide, and it will come soon in the near future that you too can play with this. Or maybe you could also do it right now, because I made a preview demo ISO available. You can scan this QR code and download it at your leisure. And it is, as I said earlier, built on LXQt 2.0 with Mirrorway 2409. It's ported to most of the stack. And LXQt is unusual among desktops, in which they have decided that they don't want to have an opinion about a compositor, and they want you to choose your own adventure on how to set up your Wayland environment. So we chose the adventure of Mirrorway, and it works out surprisingly well, as you can see, aside from me not knowing my own shortcuts. So the demo ISO is available eventually, like when Fedora 42 rolls around, or maybe I'll backport it to 41, who knows. You can just get it set up yourself and kind of hit the ground running on this. So, Alan, do you want to talk more about what Mirrorway is actually capable of doing?
So, I spoke a little bit about Mirrorway last year, and things have changed in the meantime. One of the big changes is that Mir has moved from version 2.14 to 2.18, and that's meant things like hybrid graphics being enabled, integration with login-D, notifying the shell built on top of Mir about screen dimming and off. There's a bunch of Wayland extensions that are useful on the desktop being added. Input method v1 is a bit strange because we already had v2 and v3 implemented, and then we came across some applications.
I don't want to talk about the input stuff.
You don't want to? OK, I won't talk about that. It's gained configuration options for input, and there's been quite a few fixes to the desktop experience. On the Mirrorway side, it's improved its handling of child processes so that shell components that fail can restart. That's something Matt did over there, because he had shell components that were crashing. I've added an option to specify a lock screen app so that, well, usually I just use Swaylock, and that will lock things when the login-D integration kicks off. There's support for docking and maximizing through dragging windows. That was something for Savick up there. And there's more coming.
Always more coming.
There's always more coming. Mir 2.19 is going to add to the locking options to detect when it's idle so that I can lock the screen when the thing powers down. And then Neil would have had to type his password in as well.
Yeah, that's what I kind of expected to have happen. But, you know, it was a nice surprise to see the locking actually work without me knowing it. So, hey, you guys did a good job.
We've also got Mir driving Atomic KMS, which is a bit more modern graphics stack. And there's some bug fixes. There's always bug fixes. Mirrorway stuff that's in the works now is some reworking of some example configs, because I've now learned a bit more about how to set up things like LXQt. There's better systemd integration, again, courtesy of Neil, and some support for side-by-side desktop configurations, so it's easy to install LXDE and something else, maybe Cosmic components.
Yeah. Like I expect to see that, multiple desktops might wind up sharing the same mirror-away binary, but we obviously want the configs to actually match the correct desktops. And that's sort of the point of this. Like you saw with the demo and the fact that this presentation's working, we're doing this with LXQt, but we know that people install more than one desktop environment on a single system. Victoria yesterday in her talk, she did that with showing off, Cosmic on 4 different compositors. And so like we want to make sure that the inverse is true. You're using one compositor for 4 separate desktops. That should all work correctly.
So, any questions?
Neil, so what's the next desktop you're going to package for Fedora that's based on Mir?
Oh, wow. All right. Hard hitter right there. Well, I mean, I could just do weird things with Cosmic. That would be fun. But in all seriousness, right? Like, so LXQt was the one that I kind of started with because it was the furthest along on having its shell component stack ready to go for this. I'd actually like to poke at doing this with XFCE as well. There's actually a fair number of just random weird little desktops that exist in Fedora. I think like the last time I did a check, it's like 30 different desktop environments that are packaged in Fedora, and only about 6 of them have a Wayland strategy. And I've been going out to reach out to these communities and talk to them about like where are they, how do they feel about their Wayland strategy, and promoting Mirrorway as a way to do it. I started talking to LXQt upstream as well as XFCE about it just last week.
I've got a little question coming from the Lumiri side of things. Assuming, because some of you may or may not remember Unity 8, the left-hand side launcher bar, the top notifications bar, whatever.
Oh yeah, that thing.
Yeah, that. Pretty thing, right?
Yeah, it looks beautiful.
It's just a random thought that popped up. Assuming we put those things into privileged clients, would it still be possible to have like the launcher pull out of the left-hand side and still provide some blurring on top of whatever is on the rest of the desktop shell?
So right now, no, but yes, technically. The reason I say that is that there is a proposal by the KDE, one of the KDE members, to add a protocol specifically for handling these kinds of effects in such a way that it can be handled reliably, safely, expressively. You can look up the protocol on the Wayland Protocols project called XTBlur, which is specifically what you're talking about. It's in the process of being slightly reworked. I can put you in touch with the person that's working on this protocol so we can make sure your part of this is kind of incorporated into this. But right now, I mean, if your shell components and if your shell component abuses layer shell the right way, you could technically do this. But the idea is to not do it that way and to do it in a way that's more declarative, for lack of a better phrasing.
Right, yeah. People who know me know that I like my blur, so
I mean, I like my blur too, so like I'm stoked about blur.
Yes, let's have a chat about blur later.
For sure.
Maybe just to quickly add on that, I don't know how many times Carl has bugged me about frosted glass effect and blurs on Cosmic, so we are also very much interested in XBlur, and this protocol will happen.
All right, so let's also talk Victoria. All right. Any other questions from people? I know someone in here wants to ask about Wayland Mirrorway stuff. No? No one? Oh. Come on, we don't bite.
There's one question coming.
No, I got him. He did it. I knew it. It was coming.
it's not so much a question, but a belated observation. I've already been using Mirrorway to create some custom desktop shells. This presentation with LexQt has just made me realize I can bridge the gap for Wayland support in Ubuntu Mate and use Mirrorway as the compositor, unlike the current suggested upstream implementation, which is using Wayfire. So I can't believe I hadn't put those two things together in my mind after using
we could do
Mirrorway
that
for a while. So I think
that's what it's there for.
Yeah. And we could do that with Fedora Mate as well. Like, it would be great to collaborate on that front.
The only complication I see, as you mentioned, shortcuts, is having a bridge between like the session that handles the shortcuts from Mate Session Manager through to the compositor.
So this particular Mirrorway setup is kind of demonstrated as a fully isolated direct compositor with its own configuration, running all the other components underneath it. But you could also flip it the other way around. You could take the code and then have it integrated and hook into, say, Mate Session, LexQt Session, whatever, and have it drive the configuration in runtime. I know this is something that I talked to Alan briefly about, as well as actually Matthew and with Miracle Window Manager, because the shell components we're using for Miracle have a similar philosophy of being able to drive the compositor's configuration in certain ways. And this is something that we are starting to think about how this would be done. And so if you have some ideas or feedback, it would be great to kind of sync up and make sure that we have a good plan for those things.
And a follow-on question is, on the roadmap, where does XGG portals support, and particularly screen capture, screencasting, fit in?
Okay, so the XGG portal support is something that the Mir team have on their roadmap. So we're expecting to have something in place over the next 6 months, at least a clear strategy of where we're going, if not a complete implementation of every portal everyone's heard of.
Fabulous. Thank you.
Okay. Any more questions? Observations?
Comments? Okay.
Okay then. So, please try Mirrorway. It's available as a snap.
Yeah, and you can get it in Fedora as an RPM, or try my ISO from earlier.
Yeah.
Thank you, Neil and Alan. So this is a time, very inspired, you enter the lunch break and have that break, relax it, fill your energy up, because the afternoon has the 4 most diverse set of presentations you could stick to each other. It's really from the social impact of the digital divide to the energy consumption concerns, which mostly will define how our future will evolve, to hardware acceleration, to toilets. How can you combine those 4 topics? It's really for us to learn about it after the lunch. So come back well fed and happy, and join us here. Thank you.
just to this feed, or is that to... Hello, hello.
Hello.
Lovely stuff. Can hear you now.
Yep, perfect. What about my audio? Is it good?
Yep, perfect.
Okay.
I've got your video feed just fine. I've got your slides on the left and the video on the right. We could send a camera feed now. I've got a layout that works if we want. Yeah. Yep, the room. Perfect. Oh, good. Nope, I think we're good. So that'll be on the screen, and yep, that's fine.
He can hear us. We can hear him.
Yep. Do you want to just do the sound check one more, or is that fine? If you could just unmute for 1 second and say hello.
Hello.
Yep, perfect. Okay, I think we're all set. Let's have you join back during the afternoon break, because you're right after that, right? Yep, you're right after the afternoon break, so we can get you set up then.
Okay, good.
Cool.
And whatever the screen share, the shared screen will be displayed as a presentation, right?
Say again, sorry?
Whatever the shared display, like may I share the screen, right?
Yep, just as we have it set up now.
Okay, cool.
Lovely stuff. I'll see you at the afternoon break.
Okay, see you. Bye-bye. Thank you so much. Bye-bye.
So during the actual program, he's going to be seeing himself, but at least he'll know that that's the stream. We'll put it on the screen and people will be able to see it here, and if there's no further interaction. If there has to be, I'll take the microphone from you, by the way. If there has to be interaction, we can.
So, can we skip the intermission?
Yeah, everything's back the way it should be again. Oh God, it did go out. Oh, I'm sorry about that.
So, as in, he'll be presenting first, right?
Yeah.
Yeah, and then where will you come?
Het is klaar. Komen we dan lunch. Valt op zich wel mee. Niet volle bak. Er is maar één kantje aangesloten. Eén, die staat, wat zal er staan, op 70%. Oh, de grote, sorry, die staat vol, dus de monitor die erboven staat. Ja, die staat nagenoeg vol open, ja. Ja, zeker. Oké. Nee, ik heb hem een beetje teruggehaald. Ja, oké. Tot zo, zie je zo. Hoi.
Welcome back. Again, the time for the lights to blind me. Just my destiny here. Hello, great that you're here. Great that more people enter because people from lunch are just slowly crawling over. We have heard this weekend quite a lot about AI, accelerated use here and there, but you know what? You need the hardware to crunch this. And if you're not willing to spend just one hardware manufacturer all your money, you might be interested in the talk that follows, which enables other manufacturers' hardware, quite interestingly, to get the stuff done that you want. Cordell is coming here and will talk to you about ROCm, which I hope will rock you, even though, just so you know, there's rock for boat, which means rock is forbidden, so you need to be careful. It's a sign over there. Have fun.
Thank you. Hello. Welcome to my presentation about ROCm for AMD GPUs on Ubuntu. So I guess in this talk, we'll start with a bit of an introduction, who I am and what is ROCm. Then we'll go into some getting started information for if you want to actually use ROCm. Then we'll talk a bit about the community packaging that has been going on, getting ROCm into the Debian and Ubuntu system repositories. And then I guess the last one we'll take a look at is compatibility. Will my hardware work for this? And that, I guess, has been a cause of a lot of confusion in the past. So I want to get that covered. So I'm Cordell Bluer. I guess this is a photo from a while back, 2019, I guess. This is back when actually I started on, decided I wanted to take a look at this ROCm stuff and try and get it into Debian at that point. I was doing my master's at the University of Calgary at that point, working on simulations, fluid simulations, physics simulations, rigid body simulations, that sort of stuff. And I wasn't really happy with the state of the GPU compute options out there. So one thing that happened next was that I started working on contributing to ROCm, and then started interacting with the Debian community and trying to provide information about how things work. I joined the Debian ROCm team, started working on the actual packages, and then eventually became a Debian maintainer. Maybe next year I'll be a Debian developer, fingers crossed. Now, what is ROCm? Well, it's sort of a collection of tools and libraries for general-purpose computing on AMD GPU hardware. General-purpose computing, as in you can calculate whatever you want, not just graphic stuff. Typically, you're still computing things that are very parallelized, or large data sets and that sort of thing. And I guess the big thing is that ROCm's open source, and it runs on all sorts of GPUs from AMD, and actually there's NVIDIA support too. But here we have some Instinct GPUs. It works on the Radeon stuff as well. So if we take a look at the actual components that are part of ROCm, this is, I guess, from the documentation for ROCm 6.2. We have, I guess, down at the base our runtimes and the compilers. There's a couple of different programming models that you can use. There's OpenCL, there's OpenMP with GPU offloading, and there's HIP. HIP is the I guess, language that most of the libraries that you see up there are implemented in, like all the math libraries, the communication library, the primitive libraries. And so that is the heterogeneous compute interface for portability. It's designed to make it really easy to port from CUDA. And that actually sort of naming extends up into the libraries. You can see in the math libraries that there's, 2 of everything, basically. Like there's a hip BLAS and there's a rock BLAS, hip solver, rock solver, so on and so forth. The sort of general rule there is that the rock libraries are the AMD GPU implementation, the stuff that is for AMD GPUs, whereas the HIP library is just a thin wrapper over either the ROCm backend or the CUDA backend. And they have a interface that makes it super easy to port from the CUDA equivalent of the library. This is all based off of, I guess, the compiler there, AMD Clang, which is just a fork of Clang, but most of the functionality there is upstreamed pretty quickly. So what does a HIP program look like? Well, it actually looks a lot like a CUDA program. We're going to be going through this stuff real fast, so I'm not going to spend a lot of time explaining exactly how things are here. If you want to come talk to me later or send me an email and ask me questions, that's great. But the idea here is basically that this is a program where you have some code that runs on the GPU that's marked with the global there. That's a function that runs on the GPU. And we have our data on the CPU defined up there in main. We copy it over to our GPU. We run our function on the GPU. This is running with 32 threads, and we've specified our n so that actually it's limited to it's not going to go off the end of the array. And this just squares the data that we've passed up, and then we copy it back and print it out. And actually, there's a HIP support on Compiler Explorer, so if you can, my slides are all full of links if you ever want to check them out. So you have your code. How do you go and build it? Well, there's the HIP-CC compiler. This is a thing here that is just a thin wrapper around Clang. It adds some useful flags. You just use it just like any other compiler. You pass the name of your source file, where you're sending it out. If you want to specify your architecture that you're compiling it for, the GPU architecture, you use this offload arch flag. There I've specified GFX 1100. That's the Navi 31 RDNA 3 cards. You don't have to do that. If you have a GPU in your system, it will auto-detect which one it is. But if you're compiling on a server that doesn't have a GPU or something like that, and you're copying things over, you'll maybe want to specify this. If you're not just compiling with your compiler, but you're compiling with your build system, CMake has lots of support for this. You can do it in 2 ways. There's the sort of older way where you sort of pretend that your code is C++. You link against the HIP device library, which adds various flags that is used for compiling HIP code. You specify your CXX compiler as HIP-CC, and here you can specify your GPU targets with the AMD GPU targets variable passed into CMake. Again, it will be auto-detected if you don't specify it. The newer way of doing this is with the CMake HIP language support. You'll need at least CMake 3.21.3 for this. And for that, on Ubuntu Noble at least, you would specify the HIP-CXX the HIP-CXX compiler as Clang 17. You need to make sure that you have HIP-CC installed, but you would be using Clang directly for this. And the way that you'd specify the GPU targets there is with the CMake HIP architectures flag, or it will be auto-detected. Okay, so this is, I guess, an example of what you can do on Ubuntu Noble. Llama CPP, I think, is a thing that lots of people want to run. So we'll just go through this quick demo. We install the packages that we need: hipcc, the blast libraries, hipblast and rockblast. This is going to go through pretty quick, so there's a link down at the bottom if you want to check that out, the instructions. You need to make sure that you have appropriate permissions. You need video and render group permissions, so you need to add yourself to those groups. You can check that you have the appropriate permissions by running rockaminfo and seeing that it prints output instead of an error message. That flew by the screen pretty quick, but it wasn't an error message, so this is good. We're grabbing a model. This is nice and quick because I already had it downloaded. And then we're cloning in the Llama CPP repository so that we have the code for this. Now, we'll go in there, we'll pick a version that I know works so that this will work for you if you run the same commands. There won't have been any changes to the build system. And then we'll apply exactly what I talked about there before with the building a HIP program with CMake. Now, I have actually also installed Ccache on here, so my build's going to go a lot faster than your build will go. But in any case, here we go, and it is built, and we can now go to run it. So the nice thing about this is that this is all you need to do on the stock install of Ubuntu 24.04 to get started with Llama CPP with your AMD GPU. Like, you just install a couple packages from the repository and a handful of build calls, and you're good. So, just a quick summary of what that actually did. It all fits on the slide. Now, there's, I guess, two sets of packages here for Ubuntu 24.04. There's the OS packages that came in from Debian. They're in the universe repository, and then there's AMD's packages, which they provide themselves. They build, and you install their repositories, and you get the binaries from them. So there's some differences between these, and which one you want sort of depends on who you are and what you care about. The nice thing about the OS packages, super easy. You don't need to install another repository. Debian's done a great job of expanding compatibility with older hardware. Because it uses native tooling as instead of CPAC, you get these nice source packages that gives you like apt-get source and build-up and such. There's offline HTML documentation through DocBase. Yeah, and actually, they're also built for ARM 64 and PowerPC 64. I don't know if they work. If anybody has this hardware with AMD GPUs, I would love to know. The tests are all packaged as well, so you can install the tests and try running them. Let me know if it works. On the other hand, if you use the AMD packages, you're going to get, well, newer package versions. You're going to get more packages. You're going to get support for newer hardware, just because you won't be tied down with whatever released with the operating system. They'll be updating those with every ROCm release. The other big thing is that they do way more testing. That includes performance testing, which is not a thing that we have the resources to do on the Debian side. We test for correctness on the Debian side, but even that is not as extensive as AMD's testing. So if you want officially supported by AMD, use AMD's packages. But if you want wider compatibility and you're just trying to get started with this stuff, the OS packages are great. So where were these packages available, or which packages were available in which releases? So there were a few packages that were available in Bookworm. We got a lot more in Ubuntu Noble. Pretty much all the math libraries except the newest ones and some of the lesser used ones are in Noble. And the nice thing is that these are all based on ROCm 5.7 or a couple 5.5s, one 5.4, but all of those have support for the RDNA 3 hardware. That's new enough that it has that. So if you have the latest consumer GPUs, these will work. What's new since then in Trixie, the big one is MI Open. That's big because it is a dependency of PyTorch. We've also added Hippify, RockGDB, sorry, not RockGDB, Rock Debug API, AMD SMI. So these libraries are and tools are. Hippify is a tool to convert CUDA code to HIP code. Rock Debug API is a library that's used by the debugger for getting debug information. So actually, you can build GDB with some, albeit limited, GPU debugging support already. If you just build the upstream GDB from source, and you can also build RockGDB, which has more extensive debugging facilities. AMD SMI, I guess, is system management tooling to allow you to see some information about your GPU and your EPYC CPUs. So I guess one of the great things that happened recently, just this past summer, was the Google Summer of Code. That was how MI Open got in. Shangten Huang, I believe, contributed the packages for, he did contribute the packages for MI Open and AMD SMI. That was a big push, and it was really great that he got that. The Jupyter Cache and MIST NB packages were for the offline docs to get some of those packaged in as well. And actually, it just happened that the three mentors for this were all down in Sunnyvale earlier this month, so we got a nice group photo at the Summer of Code Mentor Summit. Now, where are we going from here? I took a look at SPAC. They're an official way of installing the AMD packages, and they have a lot of them because this is a package manager from Lawrence Livermore National Labs, and they run a lot of stuff on the big AMD supercomputers. Frontier, they'll I guess have El Capitan soon. They have a lot of packages, and so I went through these to see which packages might be interesting. Right now, there's not a lot in Debian. It's sort of interesting that none of them are the same packages as in SPAC. So that actually means that there's a lot of opportunities. These are packages that are actually already in Debian or have a request for packaging, and could be enhanced with ROCm support. I've highlighted the ones in blue that I think either there's already somebody working on, or I want to work on them, or we're just about to work on them. As well, I put the next actual components of ROCm that I think make sense to package down at the bottom there. So, the topic of compatibility. So this is what you have in the upstream ROCm in terms of what will actually run. There's a link at the bottom there, the documentation for what that basically includes the same information, just in a rather different format. So the I guess important things here are if you have something that's older than Vega, it is the runtime support is not there. For everything else, you're going to have the HIP runtime is the language support's there, but your libraries might not be built for your GPU. And your libraries do need to be built for your GPU. So each of these numbers here, like GFX 900, is an instruction set architecture. And if that's the architecture of your GPU, then great. If that's not, if yours is not listed here in blue or at least or yellow, the libraries are not going to run. If it's GFX 900 or 906, those are no longer tested by AMD, but they're still enabled. My experience has been that they work well, but they're not tested. The ones in blue are the ones that actually are officially supported, so you can see there which ones are available. GFX 1102 is one that is enabled but not tested, not officially supported. Debian, by contrast, and Ubuntu Noble, by extension, has actually a lot more support. So the pre-Vega stuff is enabled. That's with big caveats. There's lots of bugs, but if you don't encounter bugs in your stuff, then good. I still would not recommend actually anything before Vega. But once you're into the Vega land, we are testing the GFX 900, GFX 906. I believe that GFX 902, 909, 90C will all work. I don't have my test machine set up for those yet. That's why they're highlighted there with caveats. Those are the caveats. RDNA 1 we've enabled, and actually all of those are enabled with fallbacks. Basically, that idea there is that we will load if your instruction set of your GPU is a superset of something that we already have, then we'll load that other code object that was built for that other GPU. And this actually works quite well. If it's in there in blue, it's because we've tested it and it works, at least with the libraries that are currently in Noble and Trixie. Now, this is not something that is going to go into upstream. AMD, they have their own other solution that they're working on, but it was not going to be there for Noble. And the result of this actually is basically that if you have a AMD GPU that is within, that is from Vega to, well, I guess our cutoff is at RDNA 3. It's not too new and it's not super old. Then actually, if it's a discrete GPU, it should work with all the packages that are in Noble and Trixie. The ones that are here that are labeled with caveats are mostly ones that are not tested. And if you have something that's really new, it's not enabled because the packages are a bit older. How do we ensure that this is the case? Well, we spent a lot of time over the past year building a big CI system. You can see that we're testing 15 different GPU architectures. This is the server rack in my basement. Each of those have about an average 3 GPUs in them. There's a couple of those that are empty, but I'm just working to fill them up. They'll be full soon. Every time that a package is uploaded, we actually run the tests of all of its reverse dependencies. We've packaged the tests of all the math libraries, so those are part of our auto package test suite. And the things in the background are all the machines that we've been getting for this. Lots of machines. You can actually see, what's inside one of those red boxes. It's a whole bunch of GPUs. And in fact, actually, there's a bunch of sort of weirder hardware, like mini PCs. There's a Steam Deck up there that we're also testing with. And you can sort of see what is on this CI system. This has required a lot of hardware to set up the CI system, and a lot of people have helped. Debian has contributed a fair number of funds, tens of thousands of dollars at this point. AMD has given tens of thousands of dollars of hardware. Also, we have partners with universities who are hosting some of this stuff, so it's not all in my basement, and hopefully most of that will be moved out soon. And as well, we have a lot of people who have donated. So that's everything. That was pretty quick. So if anybody has any questions, feel free to ask, either here or after the talk if you see me around.
How well does this work on like laptops?
I think it actually probably works pretty well. Some of the recent laptops are GFX. Actually, I have a couple of systems that I'm just about to set up that are for testing that exact thing. But GFX 1035 is a laptop architecture, and it worked great. One of the issues, if you have a discrete GPU, great. If you have an integrated GPU, there's some issues around the memory allocations. If you have the Linux 6.10 kernel or later, there's some code that will help it to dynamically change the amount that it can allocate. That should help. So I guess if you enable the hardware enablement stack and you're using Noble, that's a good idea. Or if you're using Debian Unstable, I think it'll work soon.
And the second question, if I run this on, say, a GPU that I'm also using to render my desktop, like, is it well separated as a sandbox so that I don't, can I hang my desktop?
Can you? Yes.
Is it common?
It's definitely possible, but I mean, I generally speaking work on a system that just has a single Radeon 7 in it that's used for both, and it works fine. Yes.
You had a slide with all the packages available on Noble, and there were half supported. Yes, this one, and the other one not supported on Noble. Do you plan to backport these?
I'm not sure. The first priority actually is probably Debian backports, but they're actually, one of the things that has been tricky is that this is all tied very closely to the compiler. So with Debian, the issue was we wanted to do bookworm backports because this is pretty limited. Really, everyone wants to have at least BLAS. But for that, we would need the Clang 17 compiler. And actually, with Ubuntu Noble, as we go forward, we're probably going to be moving to Clang 18, in the not too distant future. And then, we'd then be dependent on having that there. So I'd like to. I don't know if we have the resources for it, but I'd like to.
Yeah. So I think there's no Ubuntu LTS which has a working PyTorch, and that's a shame.
Yeah, that's literally what we're working on right now. We have all the dependencies that we absolutely need. We might need to make a few adjustments to PyTorch to make some dependencies optional. It uses a bit from Rock Tracer, and it uses HipBlast LT. But those are just for adding annotations to performance profiles and for specifically MI300 support. So, those things could be optional. And then if that's the case, this is everything that is needed for PyTorch. So right now, the Debian maintainer for PyTorch, Mo Zhao, has started taking a look at that. And then, well, I expect it will be soon.
Hi, can you talk a little bit about the relationship between ROCm and the kernel version you need to have it running, and any kernel modules you need to have loaded to have it running, and specifically if there's any relationship between like this version of ROCm only works with this version of some module?
So there is some ties on that in terms of what versions that you need of the kernel and the runtimes. I don't know exactly what they are. It's a fairly wide selection. I do know that if you try running this on, like if you try running Debian Unstable on Ubuntu 22.04 in a Docker, it won't work. But I use Docker all the time with like a fairly wide range of the user space libraries, and it works fairly well. So I don't know exactly. The range is fairly large.
And if anyone else has a question, I have only one last quick one. You mentioned Docker. So what's the experience of like passing enough of the device nodes into the container so it all works inside a container environment?
Oh, it works fine. I will include in that Llama CPP, I'll include a little thing for how to run it in a Docker container in the gist.
Thank you.
Okay, thank you for questions. There's more, so I would just suggest maybe you just join them in the hallway and along the way. Sorry, we're the first time exceeded all of the break in between. Thank you so much. So yeah, so with that, thank you. Wait, Cordell, this is for you. This is the stage. You had rock for boat, but you rocked well. Thank you. No, good. Thank you so much. And that means we need to rush into the next session, which is AK, who will revolutionize my personal life. Because train travel in Germany really is not what you want it to be. And if it's not what you want it to be, you at least want to have the toilets working. And I just found by talking with him, he's working with German trains. So I have hope my life will get significantly better by the work that he does. Welcome him, AK. Give him applause. We rush through the next thing. Thank you.
Awesome. Awesome. That's quite a huge audience. So let's get started. Yeah. So first of all, the title of today's presentation is Flow Nexus, Revolutionizing Train System Toilets. Basically, flushing with innovation, if you want to get the joke. Yeah, so let's get ahead with the presentation. And thank you so much for being here. This is my second Ubuntu Summit. Let's get rolling. Awesome. So before we dive in, a little bit about me. Who am I? I am Akarshan Kapoor. You can call me AK because that's apparently easier to pronounce. And my social profiles go by the name of Cappuccino. I might be one of the youngest people here as a speaker. I am basically doing my bachelor's. I'm a fourth-year undergraduate in the Department of Data Science, doing my bachelor's in data science at IIT Mandi in India. And recently, I have been here as a semester exchange student, working in Germany as a semester exchange student in computer science and working with open source and stuff. Apart from that, last year also, I was at the summit speaking, obviously, but to a smaller room per se. But here, in this particular summit, it's a very large room. That's fine. That's nice. I'm a bit nervous, but that's OK. Cool. So moving ahead, yeah, just to say about that, the last time the session was about snap packaging of scanner applications, which is meant to replace SANE, which is Scanner Access Now Easy. So that was a complete different domain. I was working with open printing with Till Campeter, so a huge shout out to him. He was one of my mentors for the Google Summer of Code program last year, so that's awesome. Cool. Yeah, so now moving on to the problem statement. Well, the very first day that I landed in Germany, I noticed that the trains are getting delayed. OK, that's fine. 1 hour delay is fine. 2 hours fine. The very first train was 3 hours delayed. Cool. So the problem statement is, as soon as a train arrives at a train depot, or basically a maintenance station, you have a variety of checks that are going on, a variety of different things that are going on for maintenances. Obviously, you'll need to somehow make this more digitized, because as far as I could notice, the people there are still stuck on basically stuck on analog sensors, and basically that sort of very limits the processing of the proactive issue detection. That's the most important part. But apart from that, I saw, like during my travels in Germany, during my travels working on my internship as well, I saw that people are still working on checklists. So they had to literally see, OK, this is the train valve that we have to go to, mark that. This is the train system. Here's the pressures going down, mark that. So obviously, there's a lot of human error here. So somehow, we need to digitize the system. Somehow, we need to work on a digitization system. And that's what calls for a smarter solution. We have to propose a new solution, per se, for a wireless monitoring of wastewater pumps.
Because one maintenance process is basically outflow of the wastewater fluid that is collected in the wastewater tanks. So that's what the proposal is about. But this can definitely be expanded onto a different, a lot of different parameters. So working with technology that can sort of digitize make it more wireless, make it more compatible with the new age that we have, that's what the smarter solution is about. Okay, let's now, since now we have an overview of the problem statement, let's get ahead and identify the solutions behind it. Obviously, the first task that we have to do is distribute this into two aspects. One is the hardware part, and the other one being the software part. Since this is more of a software conference, I'll not be diving that much into the hardware aspect, but the hardware is developed by Best Berliner Sensor Technik. It's basically a pump monitor that uses NFC technology, near-field communication, to connect to the hose on the wastewater tanks, and it sort of streamlines the task management with real-time fault detection. Apart from that, it is battery powered, so we obviously have EV booths set up that can actually go ahead and charge these. So we have them during the entire duration of the charging, or basically the outflow of the wastewater fluid. The next thing special about these is they can easily connect to a Wi-Fi system. So connecting to a Wi-Fi system is essential because we are thinking about digitalizing the entire network. Obviously, we'll have to work with embedded systems that can work with Wi-Fi. So connecting to a Wi-Fi system will not only seamlessly integrate with the entire IT system, but also sort of make it more efficient in terms of basically digitization. That's what I'm trying to say. So this was the hardware aspect. The hardware is developed by Best Berliner Sensor Technik, and the next part is the software. Okay, so before we dive into the software, let's take a step back and try to analyze, okay, what are we trying to do here? So obviously, we all know about Ubuntu. Ubuntu is an operating system. We all know different operating systems. But let's consider an operating system that's limited to a very constrained amount of memory or a constrained amount of RAM. How do we go about that? Well, obviously, we know about Ubuntu even being on Raspberry Pis, but here we are talking about more constrained systems that have even less memory, even less architecture. So that's where a real-time operating system comes in. That's called an RTOS. So that's Zephyr. As I like to say, Zephyr is basically a real-time operating system that is for the developers, by the developers, and is made by the community. So it's basically a flexible and powerful platform that allows building of embedded systems, connecting the embedded systems together. Obviously, talking about the details, the modular design, it is a small footprint kernel, and it does support a lot of architectures, including MIPS, RISC-V, Intel x86, ARM v6, v7, so it does support a lot of SoCs. That's nice. Getting into the more crispier details, it is along the more technical details here. It's a monolithic kernel architecture. It has its own bus implementation, so that's really cool. It's called ZBus for communication between the different IoT devices. And apart from that, it also has a device tree configuration that allows for better integration with the different hardware bindings that we have. So right now, as I mentioned on the previous slide related to the hardware, the chipset that we are using is the NRF 9160. That's the SoC chipset that we are using. It's manufactured by Nordic. So yeah, that was a brief introduction to Zephyr. And now let's actually dive into the software. I'm not sure whether you can see the image clearly, but I'll be able to explain it. No worries. So FlowNexus is basically a local system-based IoT software that allows you to basically connect to a cluster of IoT devices, have a backend related to it, and the backend information and then stored in a database. Obviously, if you have a database, you need a visualization system as well. So for the visualization system, we have a front-end setup. So since it's a localized, containerized setup, obviously, it does not have any external dependencies. It's within your system, and then it can operate fully within a local environment. Currently, it's being built for the pump monitor setup, that is for the wastewater fluid management, but in the future, it definitely has scope of expanding into different domains of measuring, connecting with different IoT technology. So to explain it per se, let's suppose we have a cluster of devices. The cluster of devices is basically the Zephyr clients that we like to call. These are then connected via a protocol. I'll be discussing the protocol later, to a server. The server is basically a bridging link between the backend, that is the database, and the clients. And then you have a Django server, which connects to the database. And obviously, the user can connect to it with, via the front end, access it via the front end. Cool. So the features, obviously no external dependencies since it's a localized containerized environment. You have no external dependencies like AWS, GCP, or MQTT brokers as well. I'll go into the details. The protocol is called LWM2M, lightweight machine to machine, and I'll explain why it is better as compared to MQTT. Obviously, it's LWM2M, as I explained. We have a database integration that allows you to generate an entire database schema that per se can fit to a lot of different devices, not only to the pump monitoring setup, but to everything else. Since I mentioned about 3 components being there, we had to make it secure. So there's a server component, there's a database component, there's a login component, basically the user experience component. So somehow we have to make it secure. So apparently you'll have to set up the security certificates, you'll have to set up the user management, authentication and encryption. So that's what is behind the security as well. The server capabilities, let me make this fun for you. In general, there's a perception that there's only a one-way link from IoT devices. Like you have an IoT device here and it links to the database, but this time we have like a bidirectional flow from the database to the IoT devices. Since we are talking about IoT devices, there might be a need to update the firmware. So you can't actually go to a particular device, okay, then tune in, connect to your laptop, and then say, okay, let's reboot the system and then connect to a new firmware. That's not possible. How about we make a bidirectional flow? I'll be talking about that later. So the protocol layer, that's the very important one. Obviously, MQTT is a publisher-subscriber-based model. It has a centralized broker system inside of it. So that's not very friendly with a couple of devices, a cluster of devices, because apparently if the broker fails down, it breaks down, then the system fails, basically. That's why we had to switch to a LWM2M client-server model, because that's how the machines stay connected with the machines. The laptops stay connected with the devices. And apart from that, it is built on top of UDP, the user datagram protocol, and it offers full device management. Fun fact, it's directly compatible with Zephyr as well, so it was much easier integrating with LWM2M. Okay, we talked about the protocol. Are we going to implement the protocol from scratch? Or obviously, otherwise, we'll have to look for an open source solution. Otherwise, this talk won't be happening. So obviously, for building this LWM2M protocol, we have to build the server. The server is basically based on Lation. Lation is basically the Open Mobile Alliance. It's basically a Java client implemented by the Open Mobile Alliance. It's developed by the Eclipse Foundation. It implements LWM2M, provides ZTLS support, and basically scales up to medium-sized businesses. So that's pretty cool. That about the server. The protocol is LWM2M. The server is based on Lation. Next, obviously the backend. The backend has 3 components: a REST API, a database management system, and a web interface. Web interface is basically for interacting. It gives you the front end of interacting and getting to know what is happening behind the scenes with your data, like what pressure is there, what humidity is there, what is the amount, which devices requires a reboot for a particular time interval. That's what happens on the web interface. I'll be showing a couple of pictures afterwards. The REST API is basically a communication link between the Lation server and the Jacko backend. So basically, Lation comes to know, okay, this particular device is online. I'll need to ping the Django API for a particular single resource or a composite resource. I'll talk about that as well. And then basically, there's a scheduling happening, and then you have a database management system which has a serializer and a deserializer. So a very basic setup of Django that allows you to communicate with the IoT cluster using an LWM2M Lation client implementation. Okay, so the database is apparently very important here because we wanted to expand on not only a particular set of pump monitoring devices, but apparently to any monitoring system. That's why we had to make it very flexible. So the database schema, I'm not sure if you guys can see this, but there's an endpoint, there's a resource type, event, resource. So apparently there are 8 different types of schema available. These schema allow you basically to schedule different types of operations. Let's suppose you want to basically dive into a firmware. So there's a firmware. If you want to dive into a firmware update, there's one. If you want to dive into a client, there's an endpoint. If you want to schedule an operation, there's an endpoint operation. So that's what it is happening. Also, since we were developing with Lation, so we had to use the LWM2M resource type model that was configured for this. So it's based on top of that, and it definitely allows you to scale. So that's what the main most important point about the LWM2M resource model. Apart from that, I was mentioning about high-level events as well, like the single and the composite resource events. So the higher-level events, what it allows you to do, it allows you to cluster a bunch of events. So let's suppose you have something related to a device that's related to humidity, that's related to pressure, that's related to acceleration. So you can group them into one, make it a composite, a more complex resource, and then send it to the database. That way you know that these are the physical attributes related to this device. Apart from that, if you have something like the latency or something related to the network, then which is completely independent of the other parameters, then you can basically go ahead and schedule everything into a single resource type. So that's what the database allows you to do. And I was talking about the communication interface. Well, the communication interface is basically two-way. It's bidirectional. So we have the data flow from the IoT cluster. The IoT cluster communicates to the Lation server, basically through the LWM2M protocol. Then you have the Lation server connecting to the Django backend. Django is basically the server, and the server is then connected to a database. The user can access the database through the front end. So the data flow is happening two ways, as I already mentioned. So let me explain to you the most important part, which is the data types. Because apparently, that is what allows you to expand it to a multiple cluster of monitoring systems. Not only related to pump monitoring, but can be expanded to different types of monitoring devices. We wanted to revolutionize the train systems, not only like in EU, but in India, or in different continents as well. So that's what makes it different. The flexibility that Lation API allows you to schedule a single resource type and a complex resource type allows you to cluster different types of data types together. So we see in programming languages as well, you are able to create your custom events. And so basically creating a custom event, let's suppose in the future a new device comes up or a new custom event gets derived. So for that, you'll have to derive a new data type, a complex resource type for the same. And hence, we use the data types structure here, which is basically resource/single and resource/composite. OK. Let's move on to the next part. That's the device, the photo on the left. That's the device taken from the train station, the maintenance station in Germany. So it houses basically everything related to the sensors, basically the hardware part that's already there. The endpoint status, yeah, that's a very important part. What happens is sometimes, let's suppose I want to schedule as a consumer or as an admin, I want to schedule some firmware updates. How about if the device is not connected to the Wi-Fi? How about if the device is not functioning, the battery level is very low? So what I'm trying to say here is that the device can sometimes be online, sometimes be offline. So we'll basically have to create a scheduling system. Now, the problem arises that Lation does not allow queuing of data. So apparently, we had to go ahead and configure the database, and that's the reason for this schema as well, the endpoint operation. That's highlighted in blue. The endpoint operation schema that allows you to basically create a queue of all the operations that are going to be scheduled on a particular cluster of devices. So that way, none of the devices are missed out. And then as soon as the Lation server registers, OK, this particular device is now online, it will communicate with the endpoint status, which is the endpoint operation, and schedule everything that is required for the particular cluster of devices. So this was the end-to-end setup that we have. And obviously, there's something also called as over-the-air updates, OTA updates. So those are configured into this as well, the communication interface. So it's a complete bidirectional flow that allows you to set up basically not only communication from the IoT cluster to the database, but also communication from the database or the front end to basically your IoT cluster. So that's a very cool feature that I have in this. So these are some pictures of the front end. The front end is basically a couple of scripts of HTML, CSS, and JavaScript because we had to keep it lightweight. We could possibly think of integrating, a more different system like React or something, React, or switching it even for a mobile application using React Native. But that's fine. Right now, it's only a couple of HTML, CSS, and JavaScript. It's based on top of Admin LTE. That's another framework that allows you to build like cool front-end stuff. So the Flow Nexus, as you can see, it has an admin dashboard, a device dashboard, an event dashboard, and a firmware dashboard. So the admin dashboard basically has, it tells you like the complete overview of the entire cluster of devices. OK, these many devices are online. These many devices have pending communications. These many devices need to register. So that's the complete overview. So as you can see, the graph on the left tells you the number of registered versus the number of unregistered devices. Apart from that, you also have like a total event activity graph that allows you to filter according to the basis of the last operations scheduled or the number of devices, or basically apply different filters according to your needs. So that's what the admin dashboard allows you to do. And here are a couple more pictures. The one on the left is, or basically, yeah, towards your left, yeah. That's the one that's called the event dashboard. The event dashboard allows you to monitor all the event and the event resources table. Remember, in the slides that I showed earlier, there were two schemas. One was event, and the other one was event resources. So it apparently allows you to visualize everything that's there and filter accordingly to whatever is your requirement. And the most important part is the device dashboard, because that allows you to actually set up or select a particular device out of a couple of cluster of devices. And once you have that entire thing set up, you can actually visualize, OK, for this particular device, you can actually visualize in real time. So this not only acts as a database setup, it also acts as a streaming service that allows you to monitor everything in real time. So that's what FlowNexus is. That's how we are trying to revolutionize. This was a part of my internship, an open source internship that I was trying to do in Germany, along with my semester exchange program. So it's a fun project. I hope you all liked it. And thank you. Thanks a lot. That's the QR code. You can scan that and connect with me on LinkedIn. Thank you. I'm open for questions now. Thanks a lot.
You mentioned updating the firmware on the Zephyr devices. Can you talk a little bit about how that works?
Could you repeat the question once again?
Sorry. Yes, you mentioned that the devices running Zephyr can also be updatable. Can you talk a little bit about how that works?
That is basically a component of the OTA updates, the over-the-air updates that I was mentioning about. So apparently what happens is that when you want to schedule a firmware update for the particular system, it's like we upload a binary file, because of all the firmware updates are in forms of binary. So the binary file is uploaded on the Django-based server. As soon as we upload it on the Django server, it creates a complex resource type object called as basically the firmware update object. You can name it anything that you want. It's configurable. You update that in the backend. It is then, basically, I'll show you the slide. This is the slide that I was talking about, backend to the endpoint. So the backend to the endpoint basically allows you to configure for any set of SoCs, like any chipset, you can configure any bin file that you want. On the device, we have, as part of Zephyr, we have a configuration where it allows you to check for, run the SHA-256 sum or something like that. So it's part of Zephyr that's already implemented, so it's a very easy setup to do that.
Hi, I know railways are quite an unfriendly environment, so did you have to do anything specific about hardening the sensor to cope with that? And what do you do if there's a failure of the sensor that loses your local queue on that sensor before it gets transmitted back?
I myself was involved more with the software part. So regarding the hardware part, you can contact me later. I can put you up with those guys who were working with the hardware aspect. But as far as I remember, there's obviously a backup integration of sensors. So it's not only that you have one set of sensors into that, you have a couple of backup sensors. So the backup sensors can always remain connected. And it's basically a sort of an emergency type alert. So it lets you know, OK, this is the unique reference ID associated with this particular sensors. And that's how we schedule the maintenances.
Thank you.
Yeah. Is that?
Well, what, according to you, is currently the major constraint in this system? Limitation?
Limitation in the railway system or in my? In FlowNexus. OK. So.
I know about the railway system in limitations.
OK. Yeah. So. The main limitation as of right now, as for the software that you mean, right? The software, the main limitation, because it's a young project as of now, it's only been under development for around 4 to 5 months, and we are looking for more contributors here. So the limitation is we do not have that many contributors right now. That's the first limitation. The second part is we are looking for integrating a more, streamlining the services more. That's what we are trying to do. So let's suppose if you want to stream the data in real time from the trains to your dashboards, to the admin dashboards. Apparently, right now, it takes around 5 to 6 seconds to schedule everything, but that's the latency. Latency is the second option. That's the thing to summarize. The two things, contributors, and second is latency. That's what we're trying to optimize on. That's it. Awesome, great. Thanks a lot. It was nice having you guys here. Thanks a lot.
I'll call you and help you down then. Thank you, AK. So we get ready for the next, the software, open source software between Africa and the West. And it's really a pleasure. Daniela is here just taking it down because he wants to see that, and I totally can see why. Because when he came back in spring from one of his I learned many visits of PyCon Namibia, if you know him, an average Daniela is about as enthusiastic as 20 dogs seeing your food. It's like, yeah, yeah, yeah. He was enthusiastic for his terms, even way more. So I listened to him for about 5 minutes and was really interested. And I'm happy to say today we have a speaker out of this ecosystem there. So I can learn more about it without needing the short time of Daniela. So thank you for organizing that. Let me just help him to get there. Welcome, Muhewe.
Okay, cool.
So he would also love some heat, he told me. So give him some heat and a welcome. Give him a warm welcome. That's exactly what he needs. So, green is what he wants to see for the next. If you need anything, I will go.
Okay. Okay, let's get started. Today I'll be talking to you about open source software in Africa as well as in the West. My name is Gadetungwe Muhewe. I hope everyone can pronounce my name. Who can pronounce this? The first name? Gadetungwe. That's how we strike when we are working on the documentation. We are non-English speaking people, and sometimes when you are using a documentation, it's not like accommodating other people who don't speak English. We strike it like that. I'm a software engineer. I'm a digital content manager for a company in Japan. I do a remote job, but I'm based in Namibia. I involved in open source software community and their event. I'm one of the co-founders of Python Namibia, Python Africa, and Django Africa, and I help to organize all these events. Yes, I'm from Namibia. Namibia is a small country in Africa, in Southern Africa, next to South Africa, Botswana, Angola, Zambia, and Zimbabwe. Compare Namibia to Netherlands. Namibia is 20 times the size of Netherlands. See the map. Namibia is the world's second least densely populated country. Netherlands is one of the most densely populated. Namibia is full of the deserts, and Netherlands is full of water. Netherlands has a very complicated borders because of its European neighbors. Namibia has a very straight borders, also because of Europeans. Because they were trying to divide the cake among themselves, you know. Today we are talking about Ubuntu. What I thought when I heard about this operating system called Ubuntu. In Africa, if you are from Bantu-speaking community, you'll be able to understand the word Ubuntu. No one need to explain this to you. Omuntu, like a person is a person. What Ubuntu means to me, a person is a person. Whether you are from the West, from Africa, from the East, or South, or North. Ubuntu means I am because you are. In fact, the word Ubuntu is just part of the Zulu phrase, Umuntu ngumuntu ngabantu, which means that a person is a person through other people. Then our parents used to tell us, If your neighbor kids doesn't have food, you need to help them. If someone is working on something, you need to help them to go forward, because you can't succeed without other people. This is the same things happening in an open source community. You have software and you doesn't want to involve other people. I don't think you're going to succeed on that, because you need people to contribute to this software. Open source software is everywhere, the same open source software, but in different places. Like in Africa, we focused on the local problems. But in the West, they focused on the global problems. In Africa, we focused more in the education, healthcare, agriculture, and others. But in the West, people focused on the career growth. High-profile technology projects. For example, here at the summit, there's a lot of tools, robots outside there, that if you go to African events, you barely see some of these things, because we solve day-to-day or everyday problems. If I'm at a company or if I'm walking around and I see that people are striking even to register maybe students, I'll go out there, sit in my room and solve these problems. That's our focus and motivation. Our community is very small. We are at the early stage. We are beginner and we focused more on learning. We have a small event, a local user group compared to the West, where they have a large community. Look at this, like Ubuntu Summit. In Africa, sometimes you can't find an event of 2,000 people. Just a group of maybe 5 people sitting together trying to solve their problems. People, they are more professional here, but we are still beginner. That's our structures. Look at this. If you go to Bagon US, if you go to Jagogon Europe, you'll find a lot of people. But this is a setup of Bagon Namibia. Just a group of people comes together trying to achieve a goal, trying to participate or contribute to the open source community. That's how Bagon Namibia look like. When it comes to a company that support us, we have only few companies participate into our project. Very limited. Sometimes you find the company supporting you this year, and it takes like 5 years to come back and support your event. But they use the same software that people are contributing to. But because they don't understand how did this software came into about. But there are some non-profit organizations like Django Software Foundation, Python Software Foundation that played a major role in Africa. But then on the West, you have a company like Canonical sponsoring your event for the next 10 years. You don't need to go to them. They come to you and say that we are going to sponsor you. But then, how do you expect the African open source community to grow if they don't have funding? How do you expect to have software from African if they don't have funds? Innovation and style. We focused on low cost. We focused on essential needs. The problems that I'm facing today is the one that I'm solving. That's how we deal with our problems. Like a solution for everyday challenges. But in the West, people, they believe more in doing experiment, coming up with advanced tools, They spend a lot of money doing research and all this. You have to be in Doctor Who. You have to wait for 5 years to do what? But for us, it's all about having problems, you solve it, you put it out there to the community, and we move forward. That's how we work. Here at PyCon Namibia 2023, we had someone from Zimbabwe called Ronald. Ronald told us the story of how Python saved thousands of jobs at the Zimbabwean pharmaceutical factory, helping to identify the cause of overheating problems that threatened to cause the shutdown of the plant. And we had Festus Apiata demonstrated how Python in Django made it possible to automate time-consuming administrative operation in his department in the Ministry of Home Affairs in Namibia. That's what I'm saying, that sometimes when you are sitting in the office and you find out that there is these problems, we solve that problem that time. That's how we work in Africa. Skills and educations. Skills often informally acquired. It's like you are in a group, you learn from your friends, and you get other skills throughout the journey. Education is a key community focus. Contributing, we don't really contribute because we don't have that skills. In the West, education is kind of like a former. People do computer science, do research, and many of them, they contribute and they learn this at the early stage. Sometimes you go to the university and then you, after maybe 4 years or 2 or 3 years, you are introduced to like open source project. But for us, after 4 years, again, it's like you are going to another university because you are not at the university, you don't introduce to open source software, or we don't know how to contribute to it. Imagine a person like me, I've been in this community for 9 years, but I haven't contributed to Ubuntu. But I just contribute through like organizing event, giving a talk and all this, but the software itself I haven't, because I don't have that skills. I was never taught that skill at the university. This is how our PyCon look like. We strongly focused on learners, high school learners, and that's Andrea from Canonica talking to high school students. And this is one of the best things that we have done so far, because some of us lost that opportunity of knowing how to contribute at the early stage. But now we realize that it's better to try to get high school students now, giving them these skills, and after 5 or 10 years, at least they are going to contribute to the open source community or software. Africa is huge. So are the differences inside Africa. There are major technological hubs. There are major educational technological hubs like Nigeria, East African countries, South Africa, with a focus for finance, telecommunication, data science, but not the reality for most African. In Namibia is very small. You can't find hubs that is in Nigeria, in Namibia. It's no such thing. As well, like even in Lesotho, Swaziland, and Botswana. But let's compare Namibia to Nigeria. There's only 3 million people who live in Namibia, with a tiny software industry. But in Nigeria, there is 210 million people with a regional technological hub. But Namibia and Nigeria are about the same physical size, but conditions are very different. with 218 million people who live in Nigeria, most of them, they don't work in a tech hubs. They face typical African challenges. Some of them who contributed to open source or who developed software, they don't have even funds to go forward with your software that they have created. Or even sometimes you have a software there sitting in your computer because no one is coming to you contributing to this software. These are some of the challenges that most of these countries face. We are all interested in open source software. What are the implications of this for African contributing to open source? That's just the questions that I'm asking the audience. Do you know any African open source software contributor? Anyone from here? Who? Who? N? Okay. And you don't know this one? So strange. That's good. And from outside Africa, outside South Africa, who do you know? Because we know Mag is from South Africa. From outside a technological hub, who work on African problems, who contribute to your project. Any African who contribute to your project here in Europe? No one, but Africa have 1.3 billion people. 70% of these people are under the age of 30, and these people are talented. Why can't you go to Africa and get some of these people, talk to some of these people? This is what I'm talking about. There are 1.3 billion Africans. What is their impact on open source software? Why don't we see them, even here? What can we do about it? This is a question even when you are attending Ubuntu Summit that you have to ask yourself. Just for example, this is the Ubuntu community. But we are saying that we have 1.3 billion Africans, but you only have one active Ubuntu community in Africa, which is in Nigeria. But Africa has 54 countries. What is happening here? Then something must be wrong within Ubuntu community. Open source software in Africa, we used Ubuntu a lot at university, work, high school, and within the community. It's well adopted. People, they love it, and we value it. But when it comes to contribution, we don't understand. It is not well understood. We don't know how to contribute. It's like you gave us a car, but you didn't give us a key. The skills are missing. Enabling African contribution, what do we need to do? There are different kinds of challenges. I want to talk to you personally. There are things that you can't do, and there are things that you can do. You can't solve infrastructure problems in Africa. You can't close the hardware gap, overcome economic inequality, change educational system. Those are responsibility of the government. We want you to attend African open source software event. Find out what we do, actively seek African participants, and speak to an African and understand their problems and help them to contribute to open source project. These are things that we are looking for, because other things you can't. We don't ask for funds, gift, hardware, resources, although we need support, although we need funds, but that's not what we are asking you for. We want more. We want your time, your attention, your presence at our events, because we need to understand how do you guys contribute to open source projects. You could also extend your hand when you see a new African participant, maybe participating at your event, or maybe you have a documentation there, they send a request, and you can try to extend your hand. Consider mentoring them, follow them on maybe on social media, and also when you're writing your documentation, think about non-native speaker. People, they don't understand. The documentation is written in such a way that you need a dictionary to understand what is happening. Trying to make it very simple for us to understand. There are different challenges, and like we know, we have seen some of these things, like when it comes to the Python community in Africa. This is a Python community in Africa. Look at, previously I showed you the Ubuntu community in Africa, but look at this. Python Software Foundation and Django Software Foundation, they involved in our event. They send people to attend our events. They help us with resources whenever we need them. They also recognize and award people who participated, who involve or contribute to the open source software community. That is where Python is growing fast in Africa. But in Ubuntu community, we involve, but still, there is no connection between the international community and the African community. Because even if I'm sitting here, if I want to start Ubuntu community in Namibia, I don't know who to contact. But sometime Python Software Foundation will be able to send me a message and say that, no, why can't you guys start a Python user group in Namibia? A person is a person, and you can't go far without another person. That's why we're talking about Ubuntu. For us as African, Ubuntu have different meaning. And we don't need our parents to learn this. The moment a person is saying Ubuntu, we understand. It's all about at which context that this person is using this. Do you have any question? I managed to finish in time.
You're a little bit unusual amongst people who work in software in Africa, because you have traveled a lot outside Africa, mainly to Europe, but also to other parts of the world because of your open source work. What is the biggest lesson that you're able to take back home with you from these events about participation?
Every time when I'm attending events, there are two or three things that I'm always looking at. First, I look at the project that I find at the event. And remember yesterday I spoke to one person at the booth with the robots. And I was saying that at PyCon Namibia this year we had like those robots, those small devices like a Raspberry Pi. But if we can take your project and you come to PyCon Namibia or even PyCon Africa and you demonstrate some of these things, you motivate young people to start having interest in some of these software or application that you guys developing. That is one thing that I also learned is that we should try to encourage our people, also those ones who develop their system, to bring it forward to our event so that people can see what we are talking about with their own eyes, instead of saying that, no, I develop a software, but this software is in a bank. Who go to the bank? Yeah, people, they need to see this at the event. I mean, that is one thing that I have learned from the West, is that whatever they are talking about, they always show you that I worked on this, not a theory of, yeah. And also, when it comes to, I don't know, how do people here manage to have sponsor? I think this is something that they should also help us to maybe to look at, because African Striker getting sponsor, like for event, for you to host an event, it's a hassle. You need to beg someone. You need to talk to those people. You need to convince them. But here it's all about long-term investment. A company stay with you for 5 or 10 years. In Africa, there's no such thing.
Hi, Muhawe. Thank you very much for this talk. As a fellow African, I was almost tearing up from it because everything is true. And yeah, thank you. Thank you for saying that.
Okay, thank you.
And one question, I think I already asked you this yesterday, but apart from you, there's no one else from the African communities. What is the biggest challenge? Why is no one else here?
You know, when it comes to coming to Europe, it's not easy, depending on the country. Okay, I know if you are from Southern Africa, it's a bit different, because we have that strong economy. Sometimes when you go to embassy, people, they look at you differently compared to the people from the East and the West. That is one thing. The visa, people, they do apply, but they don't get opportunity. They always fail that visa process. Another thing is sometimes it's a funding. You are attending a conference and people are saying that you need to pay from your own pocket and they are going to refund you. Where will I get $200 if I don't have a job? Then if you are working, then you are lucky. Or if you are coming from the community with money, maybe they can give you money and you pay for it. Then when Canonical pay back, then you refund them. But you have to be trust. That is one of the challenges. And another challenge is that we have people who use Linux. If you talk to them, they will tell you that I use Linux for 20 or 15 years, but they don't know about Ubuntu Summit. It's like, that's why I'm saying that there's like that There's no connection between the I don't know whether now is it Ubuntu and the community. Somewhere, something is missing there. Because people, they don't know about this conference. I think that is something that people who are in charge, they need to involve the community a lot into this for people to understand about the whole conference.
Hi.
Yeah.
Thanks again for your talk. I was looking forward to this.
Yeah.
Because I wanted to know how things are in Africa. Recently, or maybe it was a year ago or so, there was the first UbuCon in Africa. Is that right?
You see, I don't know.
Okay. I got to know about that because that was featured in the Ubuntu sphere.
Yeah.
But what I was wanting to ask is there some place we could find out more about what is happening in Africa in open source? Because one of your appeals was that we would become more aware so that we might maybe attend or help out or whatever. Is there somewhere where we could find out what's happening in advance?
Yeah, what we do normally do, we have a Python, like when it comes to Python community, we do have a Python website where we list different user group. And also the Python Software Foundation itself have like a page that lists down all the events, like all the events happening around the world. Which means sometimes we just go there and see that, okay, Africa, there's PyCon Africa, and it's happening in this date. And that's one thing that I will tell you. And also we have a repo, like on GitHub, where we list down different open source community. Sometimes it's a matter of reaching out to them and see whether they have event in this month or next month or this. Yeah.
Could you give us a search?
I can do that.
Yes, thank you.
I can do that.
So you mentioned education and even high schools. Do you know if open source software is actually being taught in schools in Namibia, for example? Or is it something you have to find as a student?
Yeah, if you go to, okay, let me put it this way. Sometimes we use a software without knowing whether it's open source or not. Imagine at the university where I was, we had 4 labs. 2 of these labs was using Ubuntu. And inside this lab, there's like 40 computers. But for me, it was all about using my Python, developing my software, and going back to my room and done. Then many schools in Namibia, they use open source software, but without understanding whether it is an open source and how to contribute to this. That is why I'm saying sometimes if you have a software, you come to the event, you explain to people, for people to understand what is that software that you are talking about, it's all about. In Namibia, I can put it that way, we have open source software, but we don't have people who can contribute to that. We don't know how to contribute to it. Something that we are using it, even if it is broken, we don't know how to fix it. Yeah. But it's widely used.
Yeah. Okay. Let's give a great round of applause for Muhewe. Thank you so much.
Yeah. Thank you. I need to go back there. Oh.
Can bring your stuff. Well, we're switching up then. The next topic is about energy consumption, yet another world-concerning thought, right? And the tool of the next person is called WattWiser, supposed to make us a bit wiser. And you get a short preview on what things are about. That means half an hour to get wiser? That never has been so easy. So, welcome, Chris.
Hey everyone. It is such a pleasure to be here with you today. Thank you for sitting through my talk. I know you've already seen a lot of incredible stuff today, and I will do my best to keep that up. I am here to talk to you today about a project of mine called WattWiser. But before I give you a lot of details about WattWiser, I want to tell you its story. Why? Because its story begins here, or really here, but last year, at the 2023 Ubuntu Summit in Riga, Latvia. You see, I came to the 2023 Ubuntu Summit, and at the time, I'm a professional software engineer, and I was experiencing incredible cognitive dissonance, because while I was looking out at the world and observing a dramatically worsening climate crisis with extreme weather events and acidified oceans that dissolve shellfish and a lot of bad going on in the world, I looked at my own industry, right? Working with computers and building software, a thing that I love doing, and it felt very disconnected. It was unclear how these two things related to each other, and I could see the waste that was happening in my world. And it wasn't clear to me what the right path forward was in order to integrate these two things that I care a lot about until I came here. And I saw these amazing talks. It was Framework and Fairphone first, who showed this completely different paradigm for building electronics, right? They showed that, no, it's actually possible to build devices that are gonna last you a decade or more, right? Where if something breaks, you replace that piece and not the whole thing. That was something that had always seemed like it would be great to have, but I realized the future is now in that case, right? It's already here. They're already doing this incredible work. And that gave me a lot of hope that someone was already out there solving some of these problems. And then I saw the KDE Eco Initiative's presentation on other problems in our sphere, on the incredible cost of fabricating new hardware that dwarfs the rest of the hardware's lifespan. I mean, we make CPUs at the nanometer scale now, or a few nanometers. It's incredibly difficult to achieve that kind of precision, and it uses incredible resources. And the carbon dioxide emissions associated are correspondingly enormous. And at the same time, we throw away a ridiculous number of devices, and that has all kinds of downstream effects too. So it became clear in those conversations that we have some big problems that we need to grapple with as an industry if we want to figure out sustainability and get the future right. So the key problems that we seem to need to address are finding ways of using our devices for their entire useful lifespan instead of just upgrading on some fixed 3 to 5 year cycle, which is sort of the norm, right? Server cycle in like data centers, they get rotated out every 5 years, and I think some data centers may have moved to 6 recently, which is an improvement. But we need a more radical way of ensuring that hardware that is still very useful and was very expensive to create remains in use And on top of that, we're seeing right now an incredible surge in what it takes to run our computing infrastructure. AI is energetically expensive, and I think we all know that, but it has use, right? It provides utility, and we need to find some sort of balance there in order to figure out how to make that technology actually a sustainable thing for us to engage with. And a lot of that starts with observation, with measurement. How do you quantify it? Because you can't improve anything until you can measure it well. So I thought a lot about these problems in the time after I left the last Ubuntu Summit, and it seemed to me that there was actually something we could do that would work on both of them at once. So, what drives the demand for using energy in the first place? Energy, according to physics classes, is the capacity to do work. And in the classical physics sense, that's kinetic, and that's applying a force to a mass, right, to move it around. But in software land, it's flowing current through a circuit inside of a processor. So in our world, activating parts of the CPU, energizing circuitry, is the thing that consumes energy. And if we can find formulations of our workloads that activate less circuitry, that achieve that same result by doing less work, using less energy, it has enormous benefits beyond the obvious, right? We know that it would drain our battery less. We know that our computer would heat up less. We know that our data centers would be cooler and consume less power. But it actually goes beyond that, because doing less work also extends the backwards compatibility of your software. You're demanding less from the hardware, and so the previous generation of CPU and the one before that actually stand a chance. Optimizing along this axis drives change on both of these major sustainability problems. And so I was thinking about this, and I wanted to engage creative and brilliant minds other than me, because I'm actually not that smart, and I would love to see what people who think in a not linear mathematical way would do with this problem space. So we launched, me and a couple of collaborators, the WattWiser Game Jam. A game jam, if you're not familiar, is like a hackathon, an event where you rush kind of to produce software under some fixed timeline. But instead of making general purpose software, you're creating video games from scratch. And the video game community, especially the indie game community, is full of brilliant, creative minds who both have intense technical knowledge and artistic vision. And I hoped that by bringing this question to that group of people, we would arrive at fascinating and innovative answers. But we had to enable people who participated in the WattWiser Game Jam to actually assess what they were building for energy use, because we were challenging them. How do you make the most fun for the least power, right? How do you balance those factors? And they have to be able to measure that. And so we set out and we thought, okay, it'll be easy. We'll just point them at a software that lets them measure the energy consumption on their device, right? No problem. And those softwares do exist, but we ran into quite a few challenges. Because we were targeting indie game developers, the two platforms that we thought were the most relevant were Windows and Linux, and almost nothing supported both of those. But it gets worse. A lot of the software only supported time windows of something like 1 second or larger in granularity. So you could find out, yeah, great, during that 60 frames, I used this much energy, but like which frame, was there something in there? Was there a spike? And what was I doing during that time? It's impossible to answer questions like that with such coarse data. So we needed more granular data with better platform support. And then we were talking about video games, we were talking about a graphical workload, but most of these tools didn't support GPU data or only supported one vendor. So it was clear that we needed a more holistic approach, and we started building one. And that's the WattWiser project. That's what I'm here to show you today. But as we built it, we realized, hang on, there's actually nothing we're doing that's specific to video games. Our workloads that we run in all domains of software engineering, they're running on CPUs, they're running on GPUs, AI runs on GPUs, graphics runs on GPUs. We can use this for everything. And so we decided that maybe we should target that. Maybe we should be more of a general purpose way of assessing energy consumption. And so what is WattWiser? It's a software stack that can run on a machine, query it for energy data from sensors that are already inside of it. CPUs for the last 15 years have had good energy sensors built into them. And GPUs frequently have good ones also. But this data is like frustratingly difficult to access. So WattWiser gathers that data from a variety of sources. For your CPU data, we rely on a technology called RAPL, the runtime average power level, that Intel and AMD both implement. And that gives us very reliable estimates of what the energy consumption of the CPU is. On Linux, this was a dream. On Linux, if you just look in the sys file system, there are files. And if you cat them, they give you the readings from these energy sensors. It's mwah, it's beautiful. On Windows, there is no facility whatsoever to access this data. So an excellent other open source energy monitoring project that's focused at sort of monitoring a fleet at scale addressed this problem by writing a Windows kernel mode driver that just does this. It just accesses a handful of MSRs in these CPUs and surfaces them in a user space API. And so we were able to do that and help them fix a problem with supporting AMD CPUs in the process. On the GPU side of things, we're very fortunate because, again, on Linux, it just shows up if you have an AMD dedicated GPU. It just shows up in libsensors in the hardware monitoring systems of the kernel. It's beautiful, it's easy, it's wonderful. The real message here is that Linux is great. And NVIDIA, even with the proprietary drivers, provides this library, the NVIDIA management library, that can give you this data richly for easily. On Windows, the picture's a little more complicated. AMD has a different management library that you have to use. And for Intel integrated graphics, because that's actually part physically of the CPU die, you get that data from RAPL also. The jury's still out on Intel dedicated graphics cards, but my friends at the OpenVINO booth assure me that they're trying it, so I'm waiting to hear that maybe tonight. And we can also read your battery. So what do we do with all of this data, and how do we make it useful to you? Well, we aggregate it into this deeply proprietary format that no other tool supports. It's called comma-separated values. And it's deeply cryptic, as I'm sure you can see here. We have a few fields. Every sample that we read has a start and end timestamp to the nanosecond scale. And then there's a column for every sensor that we found, which provides the unit of that sensor. Sometimes we can find sensors that directly measure energy, and those are measured in joules. Other times we find power sensors that we'll just integrate ourselves to determine the area under the curve and give you joules in an interface. But we chose this format because it's really, really easy for you to use the tools that you already know how to use to do your own analysis. We're not interested in being the only way that you monitor power or that you introspect this data. So we do provide an interface for introspecting this data because I don't actually know many tools that ingest CSV data live and visualize it. I'm sure there are some, but we wanted to be able to give you a sort of a high quality way to look at this that's domain specific. And so we built the WattWiser GUI. So here you can see a graph where the y-axis is wattage, so that's the rate at which energy is being consumed. And the x-axis is time with more recent data on the right. We get a line for every sensor that we detect. And in the table at the bottom, you can get the names of the sensors as well as the cumulative energy consumption we've seen since we started measuring. And so this facility allows you to see in real time what the machine you're monitoring is spending its energy on. And because the data sources that we have can be quite granular, we can see the CPU and the GPU workloads separately and their energy consumption separately. You can actually have a lot of fun just launching different applications and seeing, hey, how do they tax my system and where does the energy go when I run this? But that's just sort of surface level monitoring, and it's nice to be able to see this. But if you actually want to improve things, you want to optimize, you need something a little better. So we also offer a benchmarking facility where you can point WattWiser at an executable and you can say, hey, what's the energy impact of running this process end to end? So when we try and assess that, the very first thing we do is actually nothing. For 2 whole seconds, we just do nothing, and we monitor the energy consumption of the system during that time. We establish a baseline. Then we launch your process, and we continue monitoring until it exits. And then we take a second system baseline afterwards so that we can know how consistent our system baseline is both before and after your workload. And then we present you with a lot of information about what we saw during your workload and which sensors registered how much energy change. And we'll factor the system baseline energy consumption out of the data. We give you the ability to see both. But so in this particular case, I've had WattWiser measure the energy consumption of its own CI script. But the first time I ran it, we had a cold compiler cache. Everything had to be built from scratch. All the tools had to run. And so it uses, I believe, 1,100 joules total. But the second time, because we have a hot cache, it only uses 14. And you can see that in this graph below where we're seeing both data sets from both runs compared together where their start times are aligned to each other. So this big boxy wave here is the energy consumption of the CI actual workload. And then down, just hugging the x-axis, there's this little sawtooth thing going on. And that's the workload where it's just discovering that the cache is already hot and it doesn't have to do anything. And so this tool is designed to enable you to optimize your workloads along this axis. And there's a lot, it's easy to do. We have like binary releases already. Now you'll note that there's a sudo on this screen. And one of my goals in coming here was to get the help from the smart people I know are at this conference to remove that. RAPL's energy data is so granular that it was discovered to be a cryptographic side channel. You can exfiltrate secret keys that the CPU is manipulating by reading the energy sensors. And the Linux ecosystem solution to that problem was to make it require root to read the RAPL energy data, which is fair enough. I mean, you don't just give root out for free, we hope. But I would love to find a much more ergonomic and equally secure way to manage access to these sensors. So if you're in the systems programming and security space and you want to talk to me about the cool distribution features that we can take advantage of to do some least privilege here, please, please, please do that. But anyway, you just run the WattWiser sensors, regrettably, right now as root, and they'll spit out the CSV data that you saw earlier, and then you can, send that to whatever analysis you want, but one option is to pipe it into WattWiser proper, the GUI, where you'll see the interface that we've just described. Or you can just run WattWiser against an existing CSV file if you want to explore it in the UI. So I invite you, please, to try this out on your own machine. Sustainable software represents a real opportunity right now. There's growing concern for the fate of our planet and for sustainability in general. And that is felt both in the zeitgeist, but also in very real business considerations. Governments are adopting standards that require sourcing eco-friendly and sustainable solutions, things that are validated to be eco-friendly and sustainable, and you have to demonstrate why you couldn't. You have a burden of proof for why you didn't source the software that has evidence that it is eco-friendly and sustainable. That represents a real opportunity for businesses. But also, you've already seen the other benefits that we have. We're going to reduce energy consumption. We're going to enable devices to last longer. And those things really matter. So I challenge you to try it out because I would love to know whether it does work on all of your devices. We've tested it in a lot of places, but there's way more diversity of hardware available to you than there is to me. We could also really use support adding sensor data for devices you care about that we currently don't know how to interrogate, because there's quite a few of those as well. We would love to get rid of that ugly sudo thing, and I bet there's a convenient combination of systemd features and like a one-time sudo operation that would smooth the whole thing over. I just don't know the incantation. And there's a lot we could still do. There's a lot that we could do to integrate this directly alongside profiling and tracing software that already exists, so that you could see your energy data and your call stack in the same UI. You could say, wow, there's an energy hotspot here that is just massive. What was I doing, right? And the answer would just be right there. And that's like on the table. You could already achieve that if you were willing to do a little scripting work to collate the timestamps of our samples and the timestamps in your profile, because they're both using the same high-resolution clock anyway. So with that, thank you very much for listening to me. You can find resources about WattWiser, these links here. This QR code will take you to this slide deck so that it's easy to follow the hyperlinks. You can also contact me directly. My email is on the slide. And my collaborator in the WattWise Game Jam, Andrew Thorpe, who designed the cool logo you've seen, can be found at that GitHub link. And the other open source energy monitoring solution, Scaphandra, that solved the Windows RAPL data is linked there, as well as the RAPL driver. So thank you very much. Are there any questions?
I recently bought a hybrid pickup truck, and I joined the Reddit group for that pickup truck, and I noticed that people with the same truck were posting screenshots of their efficiency on the dashboard. It would tell you like how many electrical miles you drove and how much your miles per gallon was. And it struck me as interesting that people, they want to compete for efficiency, and I think part of that is due to wanting to do, everyone wants to do their part to try to make things better. In terms of your project, it seems like higher order things could emerge from knowing more about how energy is used in a computer. Do you see gamification or kind of tribal emergent things coming out of being able to measure energy at that level and being able to report it?
I could see an amazing future where software projects compete along this axis. I mean, just imagine for a second that we could stand here and say, we have the data to say that Ubuntu Linux is the most sustainable, energy efficient distribution across these ranges of hardware, and we can prove it, right? That's a big thing to be able to say, and we have the tooling to assess that now. I have not done a comprehensive study in that area, so we can't say that. But I think competing for efficiency is both something that we can do and something that I would love to see, because it has wonderful side effects. It makes the world a better place, and it brings people together. It gives us something to work toward, and we can achieve incredible things when we have that sort of shared vision.
Hey, great talk, thank you very much.
I was glad you mentioned other observability kind of metrics towards the end. I was thinking on the way through, an interesting direction might be to have something like a Prometheus exporter on the grounds that your exporter can be written in anything you like. Ultimately, I've seen them written in Bash and Python and Go and Rust. But that is something that you could easily confine within a systemd unit with just the privileges it needs. But also, you then for free would get all the benefits of something like Grafana and that direct correlation, right? Grafana specializes in kind of displaying time series data. And is that like a direction that you've considered, or something that just seems like something that if you had it running on the machine all the time and it could just be scraped by the thing that wanted to understand what was going on, that might be a nicer way of presenting it.
Yeah, I think that there are interesting synergies with existing monitoring stacks, and we could export something to, say, Prometheus, but at the time scale that we're working with, where we're sampling every 10 milliseconds by default right now, and I would like to actually get that lower, because I think we can make some intelligent decisions and drive that down even lower. Involving the network introduces a lot of unpredictability, and we have to start choosing, okay, who or what or when is going to maybe get blocked by interacting with the network, or what are we going to do when the network side is slowing us down? Are we going to drop samples or whatnot? Whereas this particular approach was pretty focused on the idea that you're on your development machine and you're optimizing the project that you've been working on in order to assess it. But I guess, yes, I think we can do that. And I would like to try, and I would like to see what that's like. Because you're right, Grafana already has great capabilities for visualizing this data. And it should actually be pretty easy to mesh them together.
Great, thank you very much.
Hey, Chris, thanks so much for the talk. It was both very, very clear and also quite inspiring. And I loved how you framed it at the beginning in terms of the cognitive dissonance between caring about something in the world and then also feeling part of this industry that in many ways is part of the problem, and wanting to do something about it where you have some agency to do that. Which leads me to the question. So you have this idea, it looks fantastic. You're essentially one guy with this brilliant tool looking for a way to push that out. What could come next in terms of community engagement, whether that's people here making software, people making hardware? How do you get this out to kind of find that broader reach that it clearly needs to have an impact?
Well, one thing that we've already done is we've released this project into the public domain, because our goal here is for this capability to be used. So we would love for anyone to see exactly how it works, even take this implementation if they want to, and apply it within their domains. But more broadly, we would love to see software projects come alongside us and say, you know what, it would actually be really awesome to be able to quantify our own workloads. I've been talking to some of the wonderful projects represented here today about doing that very thing, about saying, okay, can we actually measure the energy impact of our really common use cases? And what does that look like? And what does it look like when we optimize that over time? And how cool is it to be able to show, you know, we actually are the most efficient way to do this thing, you know, when we do a fair comparison against these competitors. So I would like to see projects adopt this, and I would like to see growth in the capabilities of the tool. I would love to work on this stuff even more. This is my hobby project, but if any companies wanted to actually engage with this really directly, I am freelance, and I would be happy to help them on that journey.
Awesome, thanks.
Thank you very much. If somebody doesn't really care about performance or the reliability of their software, they're made to care because the market punishes them for not caring. But at the moment, we might care about energy use, but nobody will make us care if we don't.
Yet.
It has to be a little bit systematic. How can we make it we're not the government.
Right.
But on the other hand, we might have some influence maybe at an operating system level or some other level. How can we push it up so that there is not, we're not just relying on people's goodwill, but there is real external pressure?
Well, I think I really appreciate the question, but I do think it sort of translates into how do we change the law, right? And that's a question that we ask quite often about a lot of things. And it's domain specific. But I do think that there's a few things to keep in mind that part of changing the law is changing the culture. Part of it is making sure that the people who make those legal decisions know what's important to their constituencies. And so thinking about this stuff and talking about it and sharing that in a forum where it'll be heard is a big part of that. And I live in the United States, and so it's difficult for me to offer a global perspective on changing the law, because I frankly don't know how it works in many of your home countries. But at least in where I live, a lot of laws are actually drafted by ordinary people and then submitted to their representatives and debated and revised and passed. And so politics is not a spectator sport, much as news seems to portray it otherwise a lot of times. So we have the agency to propose that future and ask that it come to pass. And so I think we can drive that change in our own homes and at our local scales.
Thanks very much for the presentation. I'm curious about the granularity. You said that it's very, very fine granularity from a timing point of view, but it seemed to aggregate CPU as one thing. Is there sort of per core information? How does that get in? How much detail can you get with the current sensors?
So it is hardware specific what we get, and Intel and AMD are subtly different in how they present that information. The graphs that I showed today were from my 2016 Intel i7, so it's a 7th generation core. We're on what, 14? So things have changed quite a bit. It only has one processor socket. It only has 2 physical cores, and 2 of them are hyperthreads, so you see 4. But in my model, what we get is deaggregated into core activity, energy consumption for memory purposes, keeping the bits fresh in that storage medium, and then something that Intel calls uncore, but loosely translates to everything else on the die that isn't those 2 things, including the integrated GPU. On other models, I have seen much richer data coming from these sensors. So for server class CPUs, you actually get like a lot more individual data streams that you can look at. And I had a great conversation earlier today, or no, sorry, it was yesterday, with some folks from AMD about how there's actually even more granular data that exists within the processor about this, and that we might be able to actually access. So I guess to your question, it does depend on what the hardware is. And I think there is still even more granularity that we can unlock in dialogue with these vendors to actually know how it all works.
Thank you.
Thank you.
Thank you also for the talk. And I found it very interesting. As a software developer, I think it can be very fun to try to optimize things. And now thinking of this new dimension of energy consumption. And I imagine that throughout the development of this tool, you must have measured the consumption of many applications. And also, you mentioned the WattWiser games. Do you have any interesting results that you got measuring many applications or from the WattWiser games that you mentioned?
So,
totally fine to continue that, but it's break time. If you need a break, break. See you at 4:30, or stay here and continue with Chris as long as you're happy to. You have about 25 minutes if you wait for the next session,
Okay.
or you take a break. So just want to mention, but yeah.
So yeah, I did have a frenzy of measurement when we first developed this. One of my earliest observations was I sometimes play some video games with my friends, and graphics settings have a just unreal impact on energy. It's not necessarily the game. The game makes a lot of style choices that affect graphical energy consumption, but the difference between ultra and high and medium and low is quite striking. You know, you can take my desktop computer, which is also about 8 years old, I think, and it'll idle at 20 or 30 watts of energy consumption, but you can make it use 250 if you push the graphics envelope all the way up. And that's not even taxing the CPU all the way. That's just a large, like quite stressful GPU workload and a moderate CPU one. So it can go worse. And you know, I do not have the latest, greatest, I've kind of lost track of graphics cards a little bit, but imagine the really good one right now, whatever that is. I suspect that it is quite expensive if you tax it all the way. And so I think there's an interesting question we need to ask ourselves here around, you know, how we choose to spend our energy and what's worth its price. And I wrestle with that. You know, if I want to play a game with my friends, it's like, well, I have a whole rainbow of options of expense before me, and where do I want to fall in there? I also found that like messaging applications, you know, simple ones, right, where you just send and receive messages with the communities you care about, the energy differences between them are unreal, folks. I invite you to measure for yourself, so I won't name any names, but chat it's just striking. It's striking, the differences that the technologies have. Yeah, is that?
Yeah, thank you. That's very interesting.
Thank you.
Thank you. Managing to go over and people want to stay with you is a great achievement. Thank you so much. See you in 20 minutes for signing, workload management, also a barrage of lightning talks, really a lot of stuff going on back then. Hello, diminishing crowd. I love you for being here. You as his friend, just go out and bring some more people. He'll take a bit for the Q&A. Just make some ad, it's fine. For you already here, welcome to the topic of digital signing and the journey that these folks had. If you say digital signing is easy, you do not admit the truth. So it's always great to learn something about it. And we not only have Nico here behind the stage waiting for you for the second phase, we also have Salman, who is remote, and we'll start the presentation off as essentially a stream in a stream, because we're streaming the stream, so this gets really meta. So have fun signing all the data and give them applause, no matter if they're thousands of miles away or just behind the curtain. Thank you.
Thanks, Finn. So, hi everyone, good afternoon. Welcome to the session on NDS from Raspberry Pi to x86. We are going to talk about how we migrated the NDS from Raspberry Pi to x86. So yeah, let's get started. So before starting, I would like to introduce our team. I am Salman Faris from Screenly Customer Success Team. I'm not an AI, I'm a real person, okay? I'm just joining remotely. And joining along with me, our open source developer and software engineer, Nico, who is the key maintainer of the NDS project. Okay. So what is digital signage? So that's the first question, right? So basically, digital signage is an electronic screen that display information, advertisement, and multimedia content to a target audience. Digital signages are everywhere. So if you already visited the booth, you can see like all the booths have a screen that shows like what the booth is about, right? That's also digital signage. And you might see these in the railway station to list all the train departure and arrival details, flight timings, restaurant menus, etc. So unlike traditional signboards, which is based on a paper print or static board, this one is dynamic, obviously, because it's digital, right? And you can change the content anywhere from the world. So that's basically digital signage. Signage with the power of digital. Yeah. So you might already be familiar with these images a few months back, right? There's a bigger kind of trouble happened. So digital signage is also like facing many cyber attacks and need a good maintenance. As you can see, most of the companies are not using the right tools for that. They might be using a generic operating system to run the digital signage content. As a customer, we want to run digital signage solution in a stable and just works. We just need to work and make it a stable. Yeah. So that's why we are discussing about NDS today. So NDS can turn any Raspberry Pi into a powerful digital signage system that show your content in minutes. Previously, it was only limited to Raspberry Pi, but recently we ported the Raspberry Pi software into the x86. So today we are going to share that story actually. What are the challenges we face and how we did that eventually. Yeah. So before get started, I would like to give introduction about NDS. So this is the NDS actually. NDS have a mainly two part. And one is the dashboard. You can see this is a web page, right? In the dashboard, we can actually add assets. Assets means the contents. We can add like images, videos, web page, etc. And we can also schedule the task. Like in the data signage space, we might need to show an image in a particular date and particular time. So we can schedule the content from here, etc. Now, another part is like we have the Raspberry Pi or the x86 device that actually connected to your monitor or your TV, which that will be stream the content to the TV. Depends on what schedule actually you added on the dashboard. So that's basically two part. Okay. And yeah, as I mentioned, you can use images, videos, and web assets actually to stream to show the contents. Yeah. And why NDS? Because NDS is the most popular digital signage product on GitHub. with our like 2.5K stars. And you can see like it runs on Raspberry Pi 2, 3, and 4. Right now, we also tested on x86, so that's also almost completed, and it's running actually. And now you got an idea about what is digital signage and what is Andes, and this is fully open source. And yeah, and I would like to also share about Andes architecture. So basically, the Andes have a two kind of interface. One is the dashboard, where the admin can add assets and where they can schedule and etc. And another part is actually the monitor controlling part, where the users or the customers can see the content that obviously via a monitor or a TV. Okay, I know you might be interested more about the internals, right? So when you look into the internals, these are the modules inside the Andes software. You can see we have the main part is as Andes server, and this server is actually managing the front end and back end. And we obviously have a Nginx, Andes Nginx, which manage all the reverse proxy to manage the routes. And we have the Celery, and this Celery basically manage asynchronous job queue, like turn off the device, reboot the device, etc. Sometimes we need to do that, right? And we use the SQLite for as a persistent DB to store all the content and assets. And we have the Redis as a in-memory DB and state management. And we have a module called Andes Viewer, which actually manages the display control and asset looping. So this is about the Andes architecture. This is an overview. Anyway, we'll go into deeper look. Okay. So this is the most interesting part of this slide. Like recently, we migrated Andes to the x86 because previously it's only supported on Raspberry Pi. And we recognize that many people have old and unused computer that can be repurposed instead of discarded. Okay. So by enabling Andes to run on this device, we are helping users breathe a new life to their hardware. And this is the cost-effective solution while contributing to sustainability by reducing electronic waste, obviously. Because you don't need to throw your computer. You can use it as a digital signage in your office, in your home, in your library. And this is fully open source and free also. So to talk about more about the migration process and the challenge we face, I invite Nico, the main developer of the Andes project, to the stage. Welcome, Nico, and over to you.
Hi, so let's dive into details. So one of the challenges that we faced recently is most parts of the code are hard-coded to work with Raspberry Pi, so and most of them are all over the place. And yeah, here. So we have to modify like various parts of the code, like shell scripts, Ansible scripts for automating installs on Raspberry Pi devices running Raspberry Pi OS, which is basically Debian in the core. So, and we also have to modify Python files, which is what like 80% Andes consists of. And also, the core of our digital signage solution is currently a web browser. So we need to like build precompiled binaries for Qt for x86 devices, more specifically like 64-bit x86 devices. And we also have a plan to ship it as Balena OS-based images, which I will be discussing later on. And with these pre-release images, we cater users who doesn't want to play around with the command line too much, so they can just download the images from our GitHub page, flash the SSD or hard drive, put it back in the x86 device, and then boot up their device. And it should be ready in like a couple of minutes or so. So as I mentioned previously, we use Qt for asset display. So generally, Qt is a tool for creating user interfaces. And you write in C++. And you can also use the Python bindings for them. So in our use case, we use Qt for the web view, which is basically a browser wrapped around Chromium. So one of the big questions is why not just use Chromium? Why use Qt? So the reason behind that is that we want to have a way to remotely control what assets are to be displayed, like from our server component, which is written in Python as well. So there's that. And then now that I mentioned, we are Qt's display is controlled from the web server. So previously we used Flask for our web server, and we recently migrated to Django. So there's a reason behind that. The first one being we want our dependency all in one place, and about the database, it's easier to not just touch the bare minimum SQL code, especially for Python developers out there beginning to learn Python. So they can just modify the class, run a command that generates the migration files, and Django will do the work for them. And so what are the challenges that we face when migrating from Flask to Django? First of all, there are multiple SQL statements scattered all over our code base. So it took a lot of work. And currently we have live fleets running in Balena Cloud, which I will be discussing later on. And it's a lot of work to migrate everything, because we don't want to risk fleet users losing all of their data. And also we have to split our migration process into multiple phases. The first one being we have to change the dependencies requirements first, migrate the views. That way we don't have to worry the data being lost. And then there's the second part, which is the database migration itself. So I mentioned that we use Balena for over-the-air updates. So Antias can be installed in two ways. One of which is you can flash your microSD card with or install Debian or Raspberry Pi OS in your machine. And the second one is you can, as I mentioned previously, you can download our images from the releases page in our GitHub repository, and then just download which one is compatible with your device. So if you're going to run your digital signage on Raspberry Pi 4, we have our Pi 4 image for that, and so on. So let's dive deeper. So here's how we do over-the-air updates via Balena. So let's say the user has set up their digital signage solution. So if the developers or other open source contributors push their code, a continuous integration process will be triggered. And then when that happens, Docker images will be built for each of the platforms that we currently support, specifically Pi devices and x86 devices. So when the image are finished building, it will be deployed to Balena Cloud, and those updates will be pushed to the devices that are online. So yeah, and I want to dive deeper in the process of how we ship Wayland images as well. So we as a maintainer, trigger a CI workflow for like building images. So the code will be checked out in GitHub Actions, and then images will be generated. Then it will be configured afterwards. And then when that happens, like depending on what tag or what version label we put in there, a new release will be created. So it's just like one push of a button, and bam, a new release will be created. So here's the data flow version of what I've discussed previously. So currently we have like releases from Pi 1 to Pi 4, and then once the releases are ready, it will be forwarded to releases. And in the future, maybe sooner, we will be supporting fleets for x86 devices. So there's that. And here's, I'd like to demo our solution. So this is what we showed previously. So here's the video for adding image assets. So you just have to click the button for adding assets. A file manager will show up. Then you can also add like default assets. Currently, we have the clock app and weather app in stock. So we can use that to display weather info or time info. And lastly, you can also add videos. It can be like any format supported. So it can be in MP4 in AVI. So there's that. So yeah, and we also have a roadmap that we follow. So yeah, we recently migrated to Django. So yeah, and we will be supporting x86 devices in Wayland OS soon. And after that, maybe you can package anti-SS snaps. And yeah, hopefully we can also support like multiple devices running not just on Debian or Raspberry Pi OS. We are also aiming to support devices running Ubuntu, for instance. And after that, we'll be adding like support, like WebUI support for if you want to migrate from anti-SS Screenly. We will be implementing like migration of assets from anti-SS Screenly in a click of a button. And then there's we'll be doing like a web interface overhaul to make it look like modern. Maybe we can also do some retooling, use React, for instance. So yeah, that's it for our talk. Yeah, questions are appreciated. All right, thank you so much. Yeah, and don't forget to start us on GitHub, like feel free to fork our repo. And yeah, we also have forums, a forum for anti-SS, so yeah.
Yeah, so is this mic on? Yeah. I was just going to help Nico a bit with the Q&A here. All right.
Thanks, Peter.
Thank you. Really interesting, and also really interesting the way you described these choices of technology stacks that you ran into, the way, you know, Qt and Chromium, Flask and Django. I wonder if you could say a little bit more about that, not about those particular choices, but about the fact that we always are making these choices in software projects like yours, and how much of our time is spent making those choices, and then executing them and hoping that we've made the right one?
I can start with answering the design and the questioning or the analysis part of that, I guess. And for us, it was really the main reason for kind of moving more towards a standardized stack really stemmed from making it easier for new contributors to come into the project. And the less custom code we had to write, the easier it will be for new maintainers to come in and join the project. So that was kind of the thought process around standardizing tooling, particularly on the database stuff, adopting an ORM, making it easier. That was really the main objective for why we decided on moving towards the stack, right? In terms of how much it took to implement, I think that's a Nico question. You spent this year, a big chunk of this year.
Like a couple of months, I guess, like making the right decisions. And since this is an open source project, we want like to reduce the barrier of entry to like developers. Because I've been pushing forward for a developer-friendly setup. So yeah.
But you spent what, 2-3 months this year? Just
2-3 months.
Throwing out like custom code and just adopting like boilerplate upstream code, really. So I think, does that answer the question, or anything with Zumama?
Thank you very much.
Cheers. Thank you. We have another question over here.
Yes, I have one question. I was wondering if the front end and the back end, in how far they are coupled to each other. Because I can also imagine that the front end and the back end, separate from each other, could also be useful.
Let's clarify on the definition of front end and back end here, because front end can be in two things. It can either be the actual what's running on the screen or the management interface. Which part of that?
I mean the screens. So
the screens, okay.
The front end of the management, I understand that.
Yeah, exactly. I just wanted to clarify that was the direction, they are completely detached. Do you want to speak a bit about that, Nico?
So for the front end, which if you're referring to the display, so they're like almost completely decoupled. So we have this web server component, which is like decoupled from the service that directly controls the screen on what to display next. So if it's time like to display image A or video A, that component will just receive a signal from a web server, and then that like web view layer will like tell the display, be it TV or monitor, like, hey, display this one.
So there is a D-bus interface between the viewer and the actual server side of it that instructs what the display should show in, and they're completely with different stacks. But does that answer the question?
Yeah, very much. Yeah, thank you.
Perfect. Do we have any more questions? One more question.
So I was wondering, in the diagram you have many parts and one display screen, right? So I was wondering, is it on the roadmap an idea in the future to support having one system with multiple display screens where you can manage like what is on the screen separately, independently, without it being the same content?
So that's kind of like, that's our commercial offering, to have like central management for like a large number of screens. Having said that, we have had, there is an API for this. So we've had people in the past who have built orchestration layers on top of the API for each device to orchestrate multiple screens. So it is definitely possible. We're not stopping anyone from doing it. It's just, it's kind of goes against the directions of the company to have, just to kind of separate this a little bit, but it's definitely, technically speaking, possible.
So, but if you're referring to like using like multiple, like for example, 2 monitors for Antis, it's a thing that we will be supporting in the future as well. But currently, it supports only a single screen. Yeah.
Any more questions? All right.
Thank you.
Thank you, guys.
Thank you so much.
Here's a present.
All right. Thanks.
Thank you. Okay, so you see dispersing all directions into the audience behind the stage. Thank you so much.
One to the right, one to the right. This won't work. No, back out. One more. This has no end. Well, it has only an end, I guess. Yeah, so the next topic is about eBPF for data collection, which is an awesome topic, because eBPF is one of those things which is quite close to the saying of, if technology is advanced enough, it appears as magic. And if you have seen someone experienced with eBPF wield it, it's like, what the hell is going on? How could why did I never get that from my kernel? And that's really a good thing. So Jose is around here to talk to you about how to get started and how to make use of it. Maybe not yet the magic, because he's rather nice, and I think he gets you started from the start and not from the magic. But at the end, maybe you have your little wand and can wield it against your kernel. So welcome, Jose.
Honestly, I have a lot of things to say, so I will start directly. The talk for today, we are going to talk about unlocking system insights using eBPF. So let's start. Let me introduce myself first. I'm Jose. I'm a senior software engineer working at Microsoft in the Azure Core Linux team, and I'm one of the maintainers of Inspector Gadget. So this is the agenda. I try to divide it into two parts. The first part, I want to introduce eBPF, what it is, why it was created, and what are the kind of the issues it is trying to address, and also how it is doing that. Then I will show you some of the tools already available in Ubuntu so that you can start experimenting with that. And in the second part, I will introduce Inspector Gadget, how you can run your own gadget using Inspector Gadget, and finally, how to share the work you have done using with the community. So let's start. Introduction to eBPF. How many of you have heard about eBPF? Great, okay. And how many of you have actually used it? Okay, so that's just for me to know how deep I need to go in the explanation. Let's start with the definition. This is the definition, don't get scared. eBPF is a technology that enables us to extend the kernel capabilities by executing custom programs without modifying the source code or loading modules. So let's try to pick some pieces from there, the keywords. So the goal is clear. We are trying to extend the kernel capabilities. The green one. I hope it is green because I'm daltonic. So yeah, the green one. Extend the kernel capabilities. But we don't want to use the two well-known mechanisms that are available right now that are modifying directly the source code or using kernel modules. So let's see why we don't want to use those mechanisms. So modifying the source code, I don't know how many of you have tried to get your patches merged into the kernel. It is difficult. And the point is that if the scope that we are trying to, our scope is to get insights from the system, apart that it is difficult to get your patch merged upstream, it will take a long time. When your patch get merged into the upstream kernel, it will take months before you can see it into the Ubuntu distribution. So that's an option we don't want because we want to get insights right now. Then the second option is using kernel modules. The kernel modules are great. You can load it at runtime, so you don't need to restart your system. You can start monitoring whatever you want. Actually, you can run any kind of programs. You can access any kind of the kernel inters. But remember, if you do something wrong in your module, the kernel could crash, so your whole system is gone. So it is a lot of flexibility, but also a lot of risk. And the second problem with the kernel modules is that it could become obsolete with just few changes inside the kernel. So if the field you are accessing in a given structure into the kernel from your kernel module is moved because a new field was added, or maybe was moved in an inner structure, your kernel module will not work anymore with that new kernel. Because, of course, you are accessing something that is not anymore there. So this is a problem also with the kernel modules, and this is the reason why we don't want to use these two options. And that's where eBPF comes to the rescue. So how it is addressing all these problems? So eBPF programs can be loaded at runtime as kernel modules, but the difference is that there is a verification process before being loaded into the kernel. So this verifier will be in charge, will ensure that we are not accessing improper memory from our program. We are not having infinite loops, so the kernel will not get blocked, waiting the program to finish, and the same for the complexity. So, because of course, the kernel will jump into your program and will wait until it finishes to continue the normal execution. So we don't want that program gets stuck or takes too long, because we will block the whole system. The other way it is addressing the issues we saw before is making the programs run in a sandboxed environment. From kernel modules, you can access whatever kernel internal, but in eBPF programs, you have very specific things you can do. You select the kind of program you want to run, and with that kind of program, there is few things that you can do there. Only the things that are allowed to do is the ones that you will be able to do. So we have very well-defined boundaries so that you don't make your system crash. This is the reason why eBPF is considered safe, because this is not because you can't do dangerous things or malicious things. It's just because it will not make your system crash. So be careful when people say eBPF is safe. Okay, it's safe because it will not make your system, your kernel crash. But of course, you can start, I don't know, dropping all the packets, the network packets, or blocking system calls. So you can do malicious things, but it will not crash. That's the point of the safe. People talk about eBPF. And the last one is about portability. So if you build your eBPF program using core, which is the standard right nowadays, they will continue working even if something changed inside the structure you are accessing. If the field you are accessing within the structure is moved because a new field was added, or maybe it was moved in an inner structure, before loading your program into the kernel, the loader will be able to try to find, using the BTF information, which is available in most of distribution, I will say all of them. Using that information, it will be able to relocate exactly where the field that you want to access is within that structure. So even if the field is moved, you will be able to continue using your eBPF program in a different kernel. Of course, if the field is moved to another structure, it will not work, but you understand me. Okay, now, how it does all this? There are two key concepts here. We have our eBPF program, and we have the hook. So we have in the graph, we have the process we are monitoring that is executing a given system call, and that's the hook that we have defined. The moment the kernel passes through that point, our program will be executed. We will collect the information we want to collect, and then the kernel will continue with the normal routine it was doing. That is the logic, the general way it is executed. But once we get the information from the system, so for instance, the system call was the open system call, so we will see a process opening a file. We will store that information, but what we can do with that information? We use maps to send that information to user space. Actually, we don't send it. We just put it into the map, and the user space application will be able to get the information from there because it's happening asynchronously. That's what it is. I said it is not sending it. Okay, so use cases for eBPF. We have tracing, is the examples I have mentioned so far. So we can attach to a hook, take the information of what is happening, binaries being executed, or files being opened, sockets being connected, etc. We have networking, where we have the possibility for these eBPF programs to drop, modify, and forward network packets. So with this definition, of course, what you can think? Create a firewall, load balancer. There are CNI Kubernetes that were developed using eBPF. So with networking, it's easy to think in an example. And security, for security, we have that from the eBPF programs, we are able to decide if a given operation will be allowed or denied. There are also other examples of eBPF programs that just trace the system, but they are looking for malicious patterns to detect them and then notify that something weird or something malicious could be happening in the system. So they are tracing, but tracing in the context of security. To give you another example. I put here a list of most of the projects. Projects are being added into the landscape of eBPF, so you can check that. And from now on, we will focus only on tracing for the sake of this, for this presentation. Now, example, how you can start using it in Ubuntu. This is BCC, I hope it is, yeah. BCC for me is awesome. I consider it this perfect starting point because you have a lot of programs that are very simple and very specific tracing task. So you can see that it is actually, they have tools to monitor all the kernel subsystems. So I don't know, for instance, they have in the system calls, the one I mentioned before, they have OpenSnoop, so they are monitoring all the files that are being executed, the files that are being opened in the system. For exec, also all the binaries that are being executed, and if we move to the networking part, you can see TCP top. They are collecting statistics for TCP, so what are the TCP sockets that are more active in the system? So the ones sending or receiving more bytes. So you have the classification and you get statistics. I think this is the perfect starting point, so you can go there, see what it is doing, and maybe start modifying things to move from that example to your specific use case. It is super simple to use. You can use apt-get install, and there you have. So this is the example of opening files. So you have the PIT, in this part, the PIT, the command, the file descriptor, if the open syscall was succeeded or not, and what error, and the path of the file that's being opened. This is a very simple example, as I said, perfect starting point. Now, if you want to experiment a little bit more, there is BPF trace. BPF trace is defining what we said at the very beginning, the hook and the program. You have it in one single line from the CLI. So the hook here in the first example is syscall, the syscall, sys enter open. Enter means that at the beginning, when it is started entering in the open system call, because you can also monitor the exit part to see the return value. So every time any process in the system is calling open syscall, your program will be called. And what is the program? Just a print showing the command and the file name. There are other two examples there. Let me show you the output. This is how it looks. So again, easy to install, apt-get, and just running one of the examples they have upstream. Here you just have the command and the file of the name of the file. Okay, second part, Inspector Gadget, how it comes to this picture. This is the definition for Inspector Gadget. It is a set of tools and a framework for data collection and system inspection on Kubernetes cluster and Linux hosts, of course, using eBPF. So we have two, it is both a set of tools and a framework. A set of tools because historically Inspector Gadget was created to port BCC tools, the ones very simple that I mentioned before, into Kubernetes environment. So BCC tools were running for, you saw that the columns was PIT, command, and the file. But if you are running that in Kubernetes, you want to have also the Kubernetes metadata. So I don't want to see just the PID and the command name. I want to see where is the container that it is running, what is the container where it is running, what is the pod, the namespace, and the node where that event happened. So that was the reason we have a set of tools, because we ported them into Kubernetes, but then we start getting some feedback from the community. The community saying, okay, but I have this other use case. I would like to create a new tool doing this and this other. And we said, like, okay, we have already a framework that is able to take eBPF programs and put it in Kubernetes environment. Why not to make this framework available for everybody? So that's why we now are exposing the framework, and people can write their own program and use the framework to run it on Kubernetes or for containers. So the last part, this is the point, Kubernetes and Linux hosts. So you can use Inspector Gadget to monitor processes running directly in the host, processes running inside containers, and processes running inside containers that were created by Kubernetes. The standard containers are the ones created by Docker, directly by Docker, Containerd, or Podman. Instead, the other ones, of course, part of Kubernetes. By the way, we are a CNCF sandbox project, so you are, yes. So the features, let me go through the features that Inspector Gadgets provide. So it can build, package eBPF programs, and we do it into OCI image, and we call them gadgets. So that's the way we define it, like the program is contained into our OCI image, and it is easy for people to create their own and use the framework to run it. Inspector Gadget automatically enrich the data, so that's what I was saying. So we are mapping what is happening into the kernel to high-level resources, so we are able to see, to associate an event we capture into the kernel with the resource, the Kubernetes resource or the container resource that is associated to that event. And then we also are able to collect and export open telemetry metrics. So you can run it as a debugging session when you open the CLI and run and see what is happening in that specific moment, or let it run in the background and exporting the data to be able to get it with Prometheus. There is also another option, is using WASM modules to post-processing. Let me give you an example. We have a gadget that is tracing DNS requests and responses. And for that gadget, the program, the eBPF program, is simple. It is just verifying that it's a DNS request. But then, if you want to show what is the name that is being resolved for that DNS request, you need to go into the packet and get the information. Or maybe if you want to get also the IPs in the response, you need to go into the packet, iterate into the bytes, get the IPs that are present into the response. That kind of parsing is quite difficult to do it in eBPF. And of course, as I said, the complexity of the program cannot, it will be very huge and maybe will not pass the verification process. So what we do is that we offer people to do this parsing and this post-processing into the WASM module. So if the gadget will be composed by a program, an eBPF program, and also a WASM module that will do the post-processing. In this example, it will be parsing the packet to get the network packet to get the information of the DNS request. This is the option you have if you want to do more complex programs. And the last part, the last feature, is that we support many modules, many modes of operation. So, as I said, you can run it in the CLI. You can use client server. In Kubernetes, this is a client server because you have kubectl plugin and the server running in Kubernetes. Or you can use it also for Linux hosts. So you have the server running in an Ubuntu system, and then you can have the client running in Windows or in Mac, and you are monitoring the Linux one. And you can also use the Golang API to directly integration into your application. So let's try to write our Hello World gadget. Very some code for developers here. So before writing it, let's define something. If we are writing our eBPF program, we need to somehow let Inspector Gadget know how that program will generate data, how Inspector Gadget will get the data from the map that that program is generating. So we defined data source, this concept of data source, and it just defines how the program is generating data. The first option is a tracer. So if you have a tracer, it means that the program, you define a tracer in your program, it means that the program will stream events, like all the files being opened that I did the example, or all the DNS requests that are being performed, so you are streaming events. So Inspector Gadget will know that, okay, I will need to go to the map and read all the events that that the program is generating. The second option is a map iterator. Maybe you don't want to generate those many events. You want to collect statistics for, I don't know, the number of files being open, or maybe the bytes that a socket is writing, it's sending, or receiving. So you collect the statistics, put it into a hash map. So for each process, that process have written X bytes, X bytes, X bytes, and you ask Inspector Gadget to get that information every X seconds. So you are getting a statistic, and you can see, like, for instance, top, something like top. So you have the top for all the TCP connections, the one more active till the less. And the last option is snapshotters. It is just when you want to get a snapshot of a specific kernel subsystem. So you get all the processes running right now, or all the sockets that are being opened right now. So this is the way you define inside your eBPF program to let Inspector Gadget know how your program is working. This example will be using trace. We will repeat the example of opening files. And this is how it looks. I hope it is. Yes, I think so. So we have the top, of course, we have the includes. VM Linux is where the kernel internals are defined, eBPF helpers for all the helpers for eBPF, and some helpers for Inspector Gadget. Now, this part, important. This is the event we will generate. So the event has the PID, the command, and the file that is being opened. Okay? Now we define the data source. This is the part that associates the eBPF program with Inspector Gadget. The data source is a tracer, and it is a map. The tracer is called open, a map that is called events, and the event that we will put into the map. So we are telling Inspector Gadget, we are defining this new tracer called open, and please read the events map that I will start putting structure there, information there. And the last part is the program itself. As I said, for the program, we have the hook and the program. So the hook this time, again, the tracer, sys open, the sys called open, and the program itself is pretty simple. So we first allocate the space for the event that we will send. We collect the information, and here is where we use the BPF helpers that are very specific, because this is a trace point program, so we can get the current PID, the current command, and we get also the file name from the arguments of the trace point. And then we send it. So this is how it looks. Wait, first we need to build it. So first we build it. Look that you don't need to have any dependency on your system. When you build it with Inspector Gadget, it will use a container that has all the dependencies, so you just run it, and you are tagging it with the My Gadget, build it, and optionally, depending on where you are running it, maybe in another system, so optionally you can push it or not. And this is how the output looks. So we have, again, PID, command, and file name. You will say, OK, this is what we have with BCC, but here you have the control over the program. You can start from this, and start adding all the things you need for your specific use case. And I said that you can run this in Kubernetes and also for core standalone container. So let's see how we can make this container aware. That's the point. So we want to add a container enrichment and like the capabilities of filtering by container, because we just don't want to see processes, but also the information of the container. So this is the changes we need to do. We will add a new field, that is the mount namespace, because the mount namespace is unique for each container. So that's the way we will identify this event, and we will associate the event with the container. So we are also sending to Inspector Gadget the mount namespace of the event. And this is the way we will filter by container. So again, Inspector Gadget will take care of everything. You just need to add these 4 lines, which is getting the mount namespace for that event and verifying that, is this something that I need? Okay. But let me show you how it will look from the CLI. Here you are just telling, should I discard this mount namespace? That function will use the Inspector Gadget code framework to be able to distinguish if it has to filter for a container, for that container or not. Let me show you how it looks. And now, after adding that field, the mount namespace, we get automatically a new column, the container name. So the first one doesn't have container name. It's because it is happening inside in the host directly. But the other processes are happening inside containers, so you have also the information of that container. If it was running in Kubernetes, you have the node, the namespace, the pod, and the container name, all the metadata of the event, just because it is happening inside a container. And here, the filtering that I was saying. So we are specifying the pod. We just want to know the files being open in one specific pod. You could do also the same for labels or a namespace or what you want, whatever you want. And here is the whole output. So it will have, if you use JSON output, you will have all the information of that container. This is the same event, but in JSON output. Then Kubernetes part is not is empty here because it was a standard container, not a Kubernetes container. But in that case, you will have all the information of Kubernetes. Okay, I think I can quote Uncle Ben. So with a great power comes great responsibility. And the point is that we are allowing people to run eBPF programs in their system, but we want to give also to the system admins the capability to just allow running the gadgets that they consider safe, that they consider that can be running that system. Because I don't know if, because I mean, you want to allow running only your gadgets, not whatever gadgets. You have a server client system. In the server, you want to allow only those kind of gadgets. So here, you can, I don't know if you before saw this flag in the previous examples. It is because I was not specifically disabled the verification of the image. Because it is useful just for debugging. But the correct way to do that is that you have to sign your gadget, and then Inspector Gadget will always try to verify that. So this is the way it works. If you try to run a gadget that is not being signed, it will always complain and say, okay, you need to sign your gadget, and you have to pass the key to verify your gadgets. This is the way you verify you are running what you want to run, and also you can restrict the repos, the repos where you can download the gadgets to run. And finally, if you want to share what you have created, you modify the open gadget that creates something much more complex for your specific use case. We create a new kind in Artifact Hub. So There is a space where people can exchange all the use cases, all the gadgets they have created, and we have put the gadgets we created there, and you can share between you the use cases you use and you create. And that's all. Thank you very much. There is not yet apt-get install IG. I hope we are here in Ubuntu Summit. I hope to find someone that can want to join the community and can help us to add it there. So that's all. Questions, I think.
Thank you, Jose. We can take one question. Where do I look at the time?
I don't know if you have time. Yes.
Let me see. Explain everything. No. Seth, yeah, make it secure, please.
Thank you. This looks very cool. The container names aren't a feature of the Linux kernel. What container runtime systems do you support to retrieve container names?
The container, can you repeat, please? I'm not sure I understand. The container.
So your output included all these container names
Yes.
that showed like it comes from a Kubernetes pod or it comes from a Docker
Yes,
or
okay.
something. These names don't exist in the kernel.
Yes, okay. How we do the association?
Yes.
Using the mount namespace. So we get the mount namespace. We get the mount namespace in the kernel, this information. Using the mount namespace, we talk with the container runtime. Using the container runtime will give you the PID of that container. Using the PID, you get the mount namespace, and there is how you match what is happening in the kernel with the container information.
There are so many container runtimes. How many of them do you support?
Docker, Containerd, Podman, and in Kubernetes, the CRI-O.
Okay, and if you use unshare directly from the command line?
Unshare, that's something that's super interesting, because you will create a new mount namespace inside the container. That's something we don't support. We have an issue for that. That's a very nice question.
Cool, thank you.
You're welcome.
Okay, once more. Thank you, Jose.
Thanks.
I wish I could clap, but the mic is on and it destroys everything. Thank you so much. Yeah, so for the last non-Lightning Talk speaker, we welcome Mark Jackals. Last year we had a coworker of him talking about the open source rendering they use. But guess what? To make a movie, you need more than one machine. No surprise, right? So there's kind of a massive thing behind of this, and give some massive welcome applause for the massive workload that he's scheduling. Hello. Hello, Mark.
Thank you. Yeah, good afternoon, everyone. Again, I'm Mark Jackals. I'm a Senior Director of Production Software at DreamWorks Animation. And here today to talk about how DreamWorks uses or orchestrates massive workloads in our feature film production. But first, I want to get in some definitions to make sure we're all on the same page as far as terminology. We have a batch queuing system. That's, I think you guys are probably familiar with that. That's a workload scheduling system that allows you to schedule work to be done on a pool of compute resources. A pool of compute resources and a batch queuing system is what we in the FX and animation industry call a render farm. For those, I think, may have heard that before. It's basically just where all the movie making happens. A unit of work that runs through our render farm is we refer to as a job, and that's the piece that gets scheduled out to run on some compute. And then a render is an image that a job generates. Now, not all the jobs that go through a render farm are rendering images, but the bulk of it is, so we just call it a render farm, and everyone speaks of it that way. And then finally, our artists don't submit individual jobs. They submit a submission, which usually represents some portion of the film, like a shot, and they will have in their tool be able to submit that. That gets broken down into a bunch of jobs that then get scheduled out on the render farm. So with that, I do want to, I'll just remind everyone what DreamWorks does. I have our trailer for our latest film, which is The Wild Robot, and as you watch, I just ask, take a look while you're watching the imagery there. Just remember, everything in there is actually generated with a graphics application or simulation, and keep that in mind.
A number of Universal Dynamics robots were lost in a typhoon. Chance of recovery is unlikely.
You need to learn how things work on this island.
Hello! Goslings in print on the first thing they see.
You're his mother now. His chances aren't super good.
I will protect him. He's got to leave this island by fall.
It is more dangerous for him than anyone else. But he has a chance. If where his wings end, his heart can pay the balance.
Sometimes, to survive, we must become more than we were programmed to be.
You are ordered to return home.
I am already home, and I am a wild robot.
Yeah. Well, we're actually super proud of this movie. It looks amazing, and it's the combination of realism, and then we put the stylistic over it to make it look that awesome. So if you haven't seen it, I highly recommend it. So given what I said before, it's all simulations and graphics, we have a lot of processing to do to generate these imagery. So here's some numbers for a single film like The Wild Robot. An 85-minute film is roughly 128,000 frames, computer-generated rendered frames. But over the life of a film, each frame is rendered many, many times as it goes through the process. So in total, that's about 40 million jobs that run through our render farm just to make one film. And if we're looking at core hours, that's like 140 million core hours, or if we're looking at hyper-threaded cores, which we have hyper-threading enabled, that's more like 240 million virtual core hours spent in the process of making one of these films. If we're looking at wall clock time, that's about 10 million hours of wall clock time, just jobs, someone watching going through the farm. All that is contributed by 500 plus artists across 20 some odd different departments that are all involved in the making of this film over the year and a half or so that it takes to make one of these. So that's a lot. Hopefully that sounds like a lot. It sounds like a lot to me. But we don't make one film at a time. We actually have 4 to 6 films in production, plus special projects and shorts at any one point in time. So that ends up when we're in full capacity, we're pushing more than 4 million jobs a week through our render farm. And these aren't just all more uniform jobs. They're very different, anywhere from 1 or 2 cores per job to 96 or more cores per job. And the memory footprint is also equally varies greatly, a gig or 2 per job, all the way up to 100 or more gigs per job to render the scenes that something like what we just saw. So to do that, we have a render farm. It's roughly 50,000 cores in capacity during the day, and then at night it bumps up to 90,000 cores as all the workstations come online and join the pool. That all ends up being between 1,000 compute hosts and 1,800 compute hosts during the course, between night and day. So hopefully that sounds like maybe that qualifies as a massive workload that we have to orchestrate. And how do we do that? Well, that's where the HT Condor comes in. So quickly, what is HT Condor? It's a workload management job queue. It was written in the University of Wisconsin in Madison. It was a part of a research project that then became a product on its own. In 2006, the Center for High Throughput Computing, not high performance computing, was created to oversee Condor and keep moving it forward. It's a full-featured batch queuing system, very scalable, and actually has the capability to federate multiple clusters together, so it gives you a lot of capability depending on how you're structured. And it's heavily used by research institutions, universities, and CERN here actually has one of the biggest Condor installations of them all. So it's, that's kind of the space it lives in. We're actually the only feature or only animation VFX studio using it, so that makes us kind of unique in that situation. So why do we like Condor? Just real quick, open source is very important to us. It's such a critical piece of infrastructure, and we want to be in control of our own destiny there. So having the open source it gives us a lot of ability to tune it the way we need it. It's a very scalable architecture, so the scheduling services can scale independently, so you can scale it up and down the schedulers as your demand ebbs and flows. It's highly configurable, which is really critical to us, given some of the diversity of our workloads that you mentioned before. The small jobs with one core can fill up the farm and starve out the big jobs that need like 96 cores, or vice versa. If the 96 core jobs take over, then you don't have any room to get the small jobs through. Condor configurability lets us dial those numbers around and tune it, the scheduling, so that we can make pathways through the render farm for a variety of job requirements. It's another important thing for us is the fair share. That's since we have 4 to 6 films in production, each one gets an allocation, so we need to be able to make sure every show is getting their appropriate amount of the render farm. But then we don't want to wall them off from each other, because we want to, if the one show is not using it all, then we want the other show to be able to use as much as it can. So Condor really supports that with the hierarchical share structure that lets a show use as much as is available, and then it'll rebalance as another show ramps up their usage. So it really suits our purposes well there. It has an elastic compute pool, so that means as like I mentioned, the desktops come in the nighttime, and then they go out in the daytime. So that kind of capability, that's all automated. We don't have to deal with that. And other cases where we need to pull resources out or add additional resources from other locations because of immediate demand, Condor really supports that well. And then another critical piece is dynamic host partitioning. So that's, think of a host. We have, some of our hosts are quite large, 300 plus cores and half a terabyte of RAM. We don't put one job on that host, right? That job will actually run at the same time multiple jobs, and Condor actually kind of fits them in there. Think of Tetris, right? You have different size and shape jobs, and Condor's trying to fill in all the space so the host is fully utilized. And part of that is supported by the dynamic host partitioning. So a job can land, take up 24 cores and a couple gigs of RAM, and Condor will see how much is left and fill in that space. And then finally, not finally, there's many more features in Condor, but the last one that's really important to us that I'll call out here is a dependency graph orchestration. So I mentioned submissions earlier. An artist will hit a submission that actually isn't just a flat number of jobs. There's actually a dependency graph there. And taking a quick look at that, here's an example. Like one job will be rendering the character, another job will be rendering the backgrounds, and another job will be rendering volumes or clouds or whatever that are happening. And then a composite job actually assembles all those different pieces into a single image, or a single image for each frame, and then all the frames actually then get processed by a chute that those get encoded into an actually movie clip that the artist can watch. So that looks something like this. Is a very simplified example, but you'll see the troll is the character, and then the environment and the background atmosphere environment get rendered separately and then get assembled in a compositing pass. And that's really important for our filmmaking process. And this is actually a very simplified example. Our defense egress actually look a lot more like this. So and Condor also supports this very well as far as how all these jobs interact and our dependencies are released properly. Just on the background, our usage of Condor, we've been using it since 2011. It's contributed to some of these films here and many more. And we have a pretty developed ecosystem around it. So obviously the baseline, the foundation of it is HT Condor Job Scheduler. And then we leverage open source as heavily as possible in this. We have an eventually consistent fault-tolerant data architecture, so as the data moves through our system, it eventually gets consistent with each other, and then and we have to be careful. We have to be able to account for network problems and things coming up and down because it's a pretty big infrastructure, and our system handles that pretty well. It's cloud ready, so it's web service based and tools that can accommodate moving to running in a public cloud or a private cloud, and then we are very careful to separate the operational and analytics data so that our analytics processing doesn't impact the operation of our tool stack. And then the last thing I'll call out is our job resource prediction system. This is actually fairly unique, and we haven't found many others doing this, particularly in our industry. And what that is we're using ML models and actually statistical analysis to assess, as the jobs come into the queue, we can make a prediction about how much RAM and how much runtime each of these jobs will take. And then we use those as attributes to inform the scheduler where to best place these jobs. So if during this process we can assess if a job is going to need 40 gigs or 20 gigs, and the scheduler can actually use that in that Tetris scheduling mechanism to fit jobs together to make sure we don't oversubscribe a host. On a render farm, going into swap is actually a very bad thing for the render job. So it's very important that we make sure that the hosts all stay within the jobs stay within their memory and keep the hosts from getting into trouble. And then the runtimes can be used if this Condor knows that these hosts, like the desktops, are going to fall off the farm at 8 a.m. and it's 7 a.m., it's going to not schedule jobs that say they would need 2 hours to run on those, so they don't have to get kicked off the machine. So this alone has actually been really instrumental in helping us make the maximum utilization of our render farm. Keeping, we actually have some stats on that later. If you want a quick system overview, this is, you don't have to write all that down. This is kind of the architecture. We're using a variety of databases. We're using Grafana and InfluxDB, Kafka, Kubernetes to schedule services. I actually have a list after that, but this is kind of how it's architected right now. The light blue is the Condor processes, and then we have a data cache that helps us not have to hit Condor to get all the status on where the job is at, where the workload's at. We have a system called EOS, which actually stands for the Eye of Sauron. That's our real-time observation system. And a service layer that lets us manage the workloads. Again, just calling out the open technology that we're leveraging. HT Condor is open. We're using Postgres and Greenplum databases. We have Influx and Kubernetes and Grafana, all these key technologies that Redis and Kafka to support our system, and that's really been a huge boon to us to actually be able to leverage open technology like this. And then, of course, a big open one, Moonray, which we talked about last year, and is now open source, so we can add that to our list of open technology that we're using. Just a quick look at some of the tooling we've developed, dashboards and whatnot. This is our real-time view of what's happening on the farm. So this is monitoring all the processes of Condor itself and lets us see the job scheduling rate, the latency of the data, throughput, if we're hitting spikes and job errors or any kind of stats that would kind of give the overall health of how the jobs on the farm are progressing. It has additional details on like license count usage, so we can actually see if we're hitting license peaks or license limits and jobs are failing or not getting scheduled because we need more licenses. That is all happens on these dashboards. This is the it's basically Kafka into InfluxDB into Grafana. And this has been a huge help for us as well. And the people are creating new dashboards all the time in this platform, so it's really useful. Moving on to we have a farm manager. This is actually the application that the artists and the resource administrators use to manage the farm. We have a page that shows all the submissions and the progress, and it's very bespoke implementation for our animation business and animators. So showing progress of submissions and where what each show is using at the moment in their resources, and so the artists will use this all the time to see where their job is at. We have built into that variety of flagging, so these are all submissions that have been flagged as having a problem. So jobs that are exceeding memory or running out of bounds or some other thing that needs investigation. When you're dealing with massive workloads, you need some way to bubble up to the top the thing that needs the most attention, and this tool has really been helpful for that. Looking at data analysis, so the other big aspect of this is looking over the life of a show. So whereas the farm manager is what's happening right now, a show needs to see, okay, what's their trend? How are they consuming the resource? Are they going to exceed the limit for the life of the show, or are they progressing at a rate that they should? Because if they're not, that means either there's work that isn't being done yet, or if they're exceeding it, perhaps there's inefficient assets. If a particular shot, has a teapot that has 1 million vertices instead of 100, that all gets reflected in render consumption, and sometimes you don't see it because there's so much going on. So the tools like this can help them monitor the trends and say, well, that shot is consuming way faster than it should, given what we know about the shot, and then they can investigate and optimize. So we have a variety of dashboards like this that are built. The tool we're building these dashboards in, it's not open source, but you can use Power BI if you want to do something like this too. But it's all based on all the data coming out of our Greenplum database, and this has been really key to a show managing the resources. So, with 6 shows in production, it's really important that every show kind of manage their resources carefully. Otherwise, if we exceed the capacity of the studio, then someone's not going to get their work back. Similarly, this actually shows the entire render farm and the breakdown by show and department for those shows. And this report actually gets used heavily by the executives and studio leadership to, so they can go complain to a show that they're exceeding. They're being a farm pig and using too much. Yeah, there's a little bit of shaming that happens. They're like, hey, what are you guys doing? So with that, actually, wrapping up a bit, our system, as described, we can get a queue depth that's like a pending queue. These are jobs that have been submitted that are waiting to get scheduled. Over 100,000. We've actually gotten close to 200,000, but things start to creak a lot when you get that many jobs in the queue. that happens like before holidays, everyone's going on break and they want to get their renders all queued up. So sometimes they'll get a pretty substantial queue depth. And the farm runs 24/7, so if there's stuff to do, it just keeps cranking through it. We do have people that check on it to make sure it's behaving itself. Equally important, we've sustained utilization numbers. So getting numbers of 95% or more utilization, that means all the cores are utilized on the farm, so there's no more room to get work in there. 95 plus is really hard to get to. We don't, in the industry, it's pretty common to see 75, 80% utilization, just given the size and shape of the jobs and trying to get them scheduled. So we're pretty proud that we're able to get that kind of utilization. Our system has been spread across multiple geographical locations. We had a studio in India for a while, and we had one in Northern California and Southern California, which are probably really close to each other from everyone here's perspective, but they're actually kind of far. So we've had those spread out, and that's actually worked really well. We were able to share work between them and monitor the systems effectively. We've done cloud bursting a number of times, and the cloud bursting is, we expect to exceed the capacity of our render farm, so we'll dial up a bunch of resources on a public cloud and have them join our pool and actually be able to schedule work to there. So we've done that a number of times, mostly in a validation test case. We haven't done, we've pushed it to a couple thousand nodes, but as an experiment, we've try not to do that too much because it's expensive. Public clouds is not cheap. And then our current activity, we're spending a lot of time looking at container environments, which we haven't had to do that because our environment is actually pretty, we were able to control it. But now, as OSs are moving more quickly and you need to update more frequently because of security concerns and all that, we're finding that a container might be useful in being able to isolate a show because they're in the last 6 weeks and they don't want you to upgrade the OS because it might change the look of their film, and there's a lot of sensitivity around that. So if we can containerize the jobs, we think it should provide better isolation. So a show in the last few weeks of it, we can leave them alone. We can move other people, move the newer shows forward, and avoid some of those hassles. And with that, I think the last one is just more information on Condor. I have a QR code if anyone's curious to find out more about Condor. I keep calling it Condor because it was called Condor for 15 years, and then some Condor company said, hey, you can't use my name, and so now it's HD Condor, so I keep forgetting to call it HD Condor. But it is HD Condor. That's the website, and that's the QR code. And if you guys are looking for a scheduler that's pretty configurable, feel free to check it out. And I think with that, that's it. Yep. And if there's any questions?
Hi. I wanted to ask if, how much are you able or planning to contribute back, right? Like, Moonray is a huge thing that you do, but from the list of things that you are using, I'm sure there's things that others could make use of.
Yeah, I mean, it's definitely become more of a priority for DreamWorks, so we're looking at ways to, even preparing this presentation, I'm like, hey, there's some things in here we could probably give to the Condor folks. So we have, in the years of using Condor, we've definitely contributed back to them and saying, we need the scheduler, would be better for work like this, and they agreed. So we've actually contributed our adjustments there. But it is an increasingly important topic to us. DreamWorks is one of the primary members of the Academy Software Foundation, which some of you may remember from the Friday presentation, and we try to contribute through that channel as much as possible. So, yeah, thank you for anything else? No. All right.
Thank you. Very, very impressive stuff. I have a question about the observability stack you are using, and you mentioned actually the licensing, that you have some threshold about the licensing. Can you open a little bit more about this?
Well, I mean, a lot of the software running on the farm is licensed, and so it's either per job license or it's per host license. So we have to manage those, and then we monitor their consumption because we want to know if our license is limiting the work too much, then we might need to buy more licenses. But it's mostly just managing the software packages that require a license.
Okay. Thanks.
Yeah.
Thank you, Mark. Sorry to upset at least 3 people. You can be caught in the hallway, right? After?
Yeah.
Okay, please remember that. It's great. But we have not 5, not 6. We have 7 lightning talks lined up, so there's no waiting. Thank you, Mark. Yeah. And with that, we increase the frequency of speaker change. The first is he, Yungbin, are you around already? Almost. So yeah, 7 talks, and it seems 7 people every second joining. That's quite great. So let me make sure I can, oh, there you are. Okay, so we're ready to change. Yungbin, have your 5 minutes. While you go up front, here are your slides. Enjoy.
Hello, so thank you. I'm Yongbin from the Korean Local and Local Council. So it's actually originally 30 minutes talk, but let me do it in 5 minutes anyway. So it's about my kiosk project for the Ubuntu Korea. So why I have started to build the project was that 2 years ago when I was organizing Ubuntu Asia in Seoul, the check-in process was a bit manual. So I wanted to streamline the process and also prevent some missing check-in. So that's why I started the project. And I actually wanted to use the Ubuntu Frame because at that time, in the Ubuntu Summit in Prague, I've been participating in many Ubuntu Frame Ubuntu Frame sessions. So I actually wanted to try that for my project. So first thing I've done for the project was just buying a cheap label printer that seems to be working with Linux, and it didn't work because I got a Raspberry Pi and the printer only supported a driver for the x86 like this. So I had to manually control my library printer with some build commands like this. Then I continue to work with some UI for my kiosk. I use Flutter with some Yaru Dart to have some Ubuntu styles in it. And and I also tested on my desktop. Like you can actually run Ubuntu Frame on your desktop like this, and then test your application inside like this. Working with the Snapcraft was a bit difficult for me because it was also first time to work with it, but also it's a bit different from the working with some desktop application. You can actually take advantage of some Snapcraft extensions, so that was a bit difficult for me. And building, I have tried out some remote build, which you can use Launchpad for building your snaps. And I've also tried out some GitHub actions, but I just end up using the Circle CI, which got the native ARM runner, because it actually made me much easier to build snap for my Raspberry Pi, like this, for example, config. And the next thing I've done was just setting my application in my Raspberry Pi, installing some Ubuntu Frame, and also my Snap package built and connect the interfaces. Then you set up my Snap. Then I have also set up the on-screen keyboard, which was quite easy to use. I just need to install the Ubuntu Frame OSK package. Then it just automatically pops when I just put focus on the text field. And I also added some Wi-Fi setup UI because using the NM package, because on the venue, setting up the network connection for the kiosk is quite difficult using my laptop to remotely set up things. So I just put these things inside the UI. And yeah, I also had some time to figure out why my setup isn't actually working on my Pi. It's like, if I try to run it, it just shows gray screen. And it was actually mostly some interfaces issue. So the Snappy Debug tool was quite handy for that, to find the missing connections. Yeah, so that's all for my project. Now let's have a look at some demo. Yeah, okay.
컴퓨터에서만 잘 되면 이렇게 돼요. 와 진짜 배포기신. 아 저 캐티 포탈만 뚫었으면 문제 없었는데 그게 안 돼가지고. 괜찮아요. 주문 안 올린 거. 아 그래도 진짜 고생하신데요. 너무 같이 가져가세요. 너무 같이 가져가세요.
Yeah, so that's it for my talk. Thank you. I actually need to skip some slides.
Thank you.
Yeah,
perfect. Here you go. All right. Enjoy.
Hello, everybody. My name is Ken Gilmer. I'm going to talk about Regolith Desktop, basically just give kind of a status update on the project. I'll get to my slide. There we go. So yeah, that's the URL if you want to check it out. I can kind of see people, just a raise of hands if people know about Regolith or not. It just, I can talk about, okay, about half, okay. So first, thanks for inviting me and to this beautiful city to talk in front of all these beautiful people. I love it here. I've never been to Denmark, to The Hague. And earlier in the talk, I was going around in the parks and riding bikes and taking pictures, so I put some pictures in the slides. They have nothing to do with what I'm talking about, but I just couldn't help putting some photos in. So Regolith is, in essence, a desktop environment. It's based on i3 and Sway. We have two different sessions, depending on what you like to do, but we try to make them kind of behave in the same way. I'm not going to really say what's on the slides. You can read them, and then there's a link too, if you want to see exactly what they are. But what I think maybe is more interesting than just like what it is in Carl Richel's Cosmic session yesterday, he talked about our primary motivator for customers, for building the Cosmic Desktop being customers using i3 and Sway to do their work. And I think that kind of says something about the popularity of this style of working. And for those that may not be familiar with the details of tiling or a specific composite or a window manager, in my opinion, it's not really about like what you see on the screen or what kind of styles you might associate with tiling. It's more about an interaction style that kind of allows you to take the window management semantics that you kind of normally do and put them kind of into your subconscious, so that when you're using your computer to get work done, you're not thinking about clicking around and seeing icons and buttons and moving windows around. You're just thinking about what's in the application and getting your work done. So it exists because when I started doing this myself, building my own stuff, I noticed a lot of people had a hard time compiling programs, versioning modules, just a lot of the minutia of software development. And I learned Debian packaging so that I could get something stable for myself. And once I kind of got it for myself, I decided why not share it with others. And so it kind of steamrolled from there. Specifically, the day job I have, I was given a choice between Ubuntu, Windows, or Mac, and I wanted Ubuntu, of course, but I wasn't really happy with the default experience for my development tasks, and so I wanted to be able to just install something very quickly on my work computer and not have to worry about it and tinker with it after that. And so that's kind of how I began Regolith. Another problem is that, as all of you know, the desktop and the whole Linux world is always changing. There's always new APIs, components, libraries, new ways of doing things. And just to make programs continue to function, you constantly have to maintain them and change them and tweak them and update them. And unless you're if you're on your own, then you kind of have to do that all on your own. You have to learn all those things, but if you're able to just consume packages, then you let someone else do the work for you. I'm not going to, I don't even really know why I put this slide in here, but essentially there's programs, there's IPC, programs launch programs, this program launches, and that's how it basically works. It's very easy to introspect how the environment is brought up. We use systemd, and then once you're within SWARE i3, it loads other components like the bar and so forth, very standard setup. We have a little bit of customization in terms of our launcher is called Ilya. It's based in Vala. And we use a backend for configuration X resources for X11 and TrallD, which is basically a port of X resources that we integrate directly into Sway. So we have a minor unofficial fork of Sway called Sway Regolith. So what we're doing next is we're getting all of our packages into Debian. In doing that, we need to kind of clean them up, and so we're working on that. We're also simplifying the build system, the layout, package repository, and so forth. And as always, reducing complexity, making it simpler, and hopefully getting Regolith available for more people in more distros and more environments soon. I hope you like the pictures, and thank you for having me.
Valkey on Ubuntu. This will be my talk. I'm going to talk about what is Valkey, but at the same time to share the collaborative efforts that we've done together with the Valkey upstream. While I'm a product manager at Canonical for this particular initiative, I think I'm a connector. And I wanted to define what is connector, along with 3 other types of people as described by Malcolm Gladwell in the book The Tipping Point. The book explores the factors that makes idea gain widespread popularity. Gladwell did identify 3 key roles on spreading, an idea or an information. And these 3 key roles are connector, maven, and a salesperson. And of course, we're in a community, we don't sell things here, so we're an advocate. Well, a connector is someone who has an extensive social network in different fields, bridging the gaps of, otherwise unconnected groups. In this case, for us, it's Ubuntu, Valkey, or maybe the Debian community. While the Maven are the people who are knowledge gatherers. These are the people who knows, and processes deep understanding on maybe Ubuntu packaging, archive, building, technical aspects of Valkey, such as, how to improve performance through asynchronous I/O, threading, and different things that makes it an intelligent core for utilization as a key value store. But another type of person, or person to make a nice idea go into popularity, is a visionary. A visionary imagine what could be done in a bold way, in an innovative way. And in this case, ideas could evolve like putting Valkey in Ubuntu, which I think is very aligned to the Ubuntu's mission, which is to provide the software, to provide free software to the widest audience possible. And I'm very glad we had a press release about it a few weeks ago and an announcement. And Valkey is now in Ubuntu. It is in 24.10. We are very, very happy about that. And it was also backported in 24.04, something that is not usual. So kudos to our Ubuntu server team for all the help. This is possible due to the incredible help of mavens, connectors, advocates, and visionary, not just in the Ubuntu community, but actually the Valkey upstream and our technical steering committee there. But Michelle, I understand Valkey is now in Ubuntu. However, what is actually Valkey? So let's say that, let's give a scenario and you want to launch your new e-commerce site. Customers will need to browse products, search for items, place orders. Administrator of that e-commerce site needs to do product inventory, user accounts, promotions, and all. And of course, you needed a database that stores, manages data, and you can access those information. Your database is highly available, and it has fault tolerance. Aside from this e-commerce use case, Valkey can be also used in different ways or form. For database caching, real-time analytics, and also for session management. Valkey is open source, BSD3 license, has a design which is single-threaded, but can also be multi-threaded for improvements in its I/O optimizations, and also backed by maintainers with deep Redis expertise. In fact, Valkey 8 was released just last month. The performance improvement of Valkey is actually 230% in throughput and 70% reduced latency. On the efficiency side, it has reduced its memory overhead by 20%. It is in comparison to the last open source version of Redis before it moves to SSPL. There's a lot of other feature improvement for Valkey, for observability, reliability, replication, and all other features. We at Ubuntu can't also wait to put Valkey 8.0 for the future Ubuntu releases. Valkey is here to stay. So I would like to encourage you to get started. Try and use Valkey. The QR code is our recent announcement. And use your favorite sudo apt-get. And of course, again, I would like to thank the community for all the support and effort and putting one of the very key database in Ubuntu. So my last takeaway is, are you a connector, maven, advocate, or visionary? Your contribution is always appreciated. Thank you.
Hi, I'm Helena. I'm with Intel, and I'm here to talk about OpenVINO. So OpenVINO is a software development toolkit to make AI models run faster. It allows software developers to, for example, create applications similar to ChatGPT that you can run on your local PC or on a server that your company owns without sending any data anywhere. You can add your private data. It works with all kinds of AI models, language models, image models, etc. You have a model, you convert it to OpenVINO, and you can deploy it across a wide variety of devices. We call this write once, deploy anywhere, which means you don't even have to change any of your code to switch between CPU or Intel GPU deployment. And we automatically optimize for the target device. We're truly open source, Apache 2.0. You can find this on GitHub. So how do we make models run faster? Well, I could actually use a whole hour to talk about this, but I give just two simple examples. One of them is many models have things that are really only useful for training, and we can just remove them. That's a very simple optimization. A more advanced optimization is model compression or quantization. Many models have 32 floating point weights. We can compress them to 8 or even 4-bit integers without losing too much accuracy. And that, of course, very much improves performance and memory load and model size, etc. We are a C++ library. We have Python, C, and JavaScript APIs, which are all fully supported. And we also have integrations into popular frameworks. If you already have existing code, for example, for Hugging Face transformers, then you can add OpenVINO with only 2 lines of code and automatically get all our performance optimizations. If you want to get started with generative AI, we also have an easy, lightweight GenAI library that makes it really easy to get started. I already mentioned Write Once, Deploy Anywhere, but I feel like it bears repeating. And we have a long-term support release, released every year with 2 years of support. And I know you may now all roll your eyes because I know this is nothing like the 12 years that Ubuntu offers. But this is a field where much software just breaks every 2 months. So having 2 years is really pretty good. So how does this relate to Ubuntu? Well, of course, OpenVINO runs on Ubuntu. It's open source software, you can build it, it actually runs everywhere. But we support Ubuntu, and we have supported Ubuntu since our first release in 2018. And Ubuntu is actually the only Linux distro that we have supported all the time. All the distros come and go, Ubuntu was always there. We have binary archive releases, so you don't have to build from source, and not only for our full releases, but also our pre-releases and our nightly releases. Ubuntu is included in our validation, so if something changed on the Ubuntu level, for example, a new threading library, then we would catch that, and we would see, hey, performance has changed, and we could fix that. And we make it easy to install GPU drivers and dependencies, of course. So how easy? Well, installing GPU drivers really is just apt install, and that's it. And this is all you need to do deep learning inference on Intel GPUs, either integrated or discrete GPU. And since Ubuntu 24.04, you also don't need any custom kernels or anything. So I said GenAI is an easy library, and this is just to show you how easy that is. It really is just a few lines of code to do inference on a large language model. And this video shows that in practice. So I load the model, I create a pipeline, a simple line to add a streamer, and this is running on my ARC 770 Intel GPU. It's a discrete GPU, and it's pretty cheap. It costs about 400 euros. And you can see this is pretty fast. This is just fast enough to run inference on your local computer. So, if you're now interested, go to docs.openvino.ai.install or find us on GitHub. We have many installation methods. Please reach out if you have any questions. Here's my email address. These slides are also on the Ubuntu Summit page. I would really like to hear any feedback, and I hope to hear from you all. Thank you.
Hello, my name is Adriana Frick. I'm here representing Canonical, and today I'm saying, do you know Ubuntu? Now, that's me. You may have seen us at our booth. That is my colleague, Maurizio Buscanelli. You may have also seen me earlier at some other presentations. This might all sound a little familiar. I was at Scale, and I was also at Ubuntu Summit a little while ago. But I may have a little bit of a different appearance. So if you didn't recognize me, that's not surprising. I mention this because sometimes appearances can be complicated. So can career paths. So can the question, do you know Ubuntu? It appears simple, but let's break it down step by step. Ubuntu. Everybody here know that word? All right. Oracular Oriole, yeah? Or maybe we're thinking about an LTS. Or maybe we're thinking about our history. Or maybe we're thinking about our future. Maybe we're thinking about cloud and server or core or IoT. Or maybe we're thinking about multipass. Maybe we're thinking about Ubuntu running on different operating systems. Suddenly, that's not such a simple question, right? So let's take it back one more step. Let's talk about to know. Well, suddenly that's not such a simple question. In teaching, we have a thing called Bloom's taxonomy. Some of you might know it. I see a few people in the audience I would suspect would know it. This is a way that teachers, instructional designers, and trainers identify the depth to which someone needs to know a thing, from rote memorization to creating new concepts. So that doesn't seem to have helped narrow things down. Let's try again. What about you? Well, are you approaching Ubuntu as a system administrator or a cloud architect? Maybe you're a home lab hobbyist. Shout out to my people. Maybe you're a business user, right? So there are different types of you. Suddenly, that wasn't such a simple question. And we only have one word left. To do. There we go. That's going to help us quite a bit. Because task performance demonstrates a measurable skill. When you do the thing, I can measure that you have done the thing. This is where hands-on performance testing comes in. Let's see if we can use this to simplify our sentence a little bit from here. So do. This is the exam that we currently have available. We're currently calling it Q.1. This is Linux-based. It's vendor neutral, and it's largely terminal-based. We do have other exams that are on this same platform. So if you're wondering, well, if it's terminal-based, why am I in a desktop? And you'll notice that it looks like a desktop. This is actually in your browser. There is a browser window that will give you the lab questions. That's another way to refer to hands-on exercises. We do have some multiple choice questions because, as Bloom's taxonomy showed me, if I'm checking your rote memorization, you don't really need to worry about whether we've spun up a VM. But for hands-on, real-life exercises, adding users, troubleshooting storage, managing different file systems, for that you really do need something that's hands-on and real. Now, no. How do we simplify no? The way that we're doing it is we have identified hundreds of occupational tasks. In this case, our target occupation was an entry-level system administrator. We take from multiple sources, job listings, tables of contents, shout out to Nathan, different course syllabi, a variety of locations, and then we take those to subject matter experts who review and rank the importance of those tasks. Multiple rounds of internal, public, and industry testing have helped us isolate and narrow down what really, really matters. Okay, we got do and we got no, but, oh, that's the word I forgot. You. We need you. By the way, shout out to Canonical Comms team. I stole this from their posts this week. This is from the social media posts. So where do you come in? There's no I in team. There is an I in industry consensus. But there are two U's, and it ends with us. Do you like that joke? So for industry consensus, Mauricio and I can't figure it out on our own, right? We do not exist in a vacuum. So for that, we would love for you to get involved. You can sign up for a free exam, you can join us for beta testing, and you can show up for subject matter expertise. Thank you all for your time.
Hi everyone, I'm Yatin and I represent Bolt's R&D and we develop open source hardware solutions for 3D printers. Okay, so basically the idea is I'm taking you back to the future of open source 3D printing because the reason is that if you know about 3D printers, you might know about RAMs. And in RAMs actually, it was initially open source, but it then became closed source. People derived from it and never actually contributed back. So we took an initiative to make it all open source again. So this is one of our 3D printers hardware, which is SmartPrint Core H7X. And what it does is that it gives you exactly the same features that is in the latest hardware. It's just open source and released under GPL v3 licenses. And it is very robust, it is very energy efficient, and it is powered by STM32 H723 and all that stuff. And then we also made SmartPrint Core Extravaganza, which is basically named after a pizza actually initially. But what it does is that it basically gives you features of adding 5 more stepper drivers to your existing 3D printers. And So initially, if you use, if you want to expand your printers with 5 more stepper drivers, so it would cost you around, double the price, because the thing is that you'll have to buy 2 main boards that will cost you $80 or $60 each. But with Extravaganza, what you can do is that you can get it at a fraction of price by only $15 of cost of production, and it is also released under GPL v3 licenses, and so it is all available for you to commercialize also, and even build upon it, and include it in your additional designs, or maybe in your CNC machines also. Then actually the thing happened that one major leap was taken into the 3D printing industry, which was modular standards, modular stepper driver standards actually. So the thing is, with Pololu standards, if you know about stepper drivers, they actually have this bug actually, physical hardware bug, which if you oriented them into the 180 degrees, or in the wrong orientation, because they're likely the same, so it will just blow up. So a solution was a modular stepper driver standard. So we released this board, which was this will use, we call it NYSM2 Open Stepper Module Standard, which actually stands for Not Your Standard M2, because it actually uses the M.2 key B format, and it actually routes out the stepper driver signals to basically route 4 amperes, up to 4 amperes of power through the modules. And it is also open source, and it is released under GPL v3 licenses. And and we are also inviting manufacturers and contributors, developers all over the world to utilize this standard, so that opens the 3D printing hardware, which used to be open source a while back, and then it became closed source. It is slowly becoming closed source, can be all open source all over again. So apart from these projects, we also have plans to add additional hardware, which is already in the market, but which is closed source. So one of them is SP3C, which is basically a companion computer for 3D printers, something like Raspberry Pi Shields. But it is more and more open, because we'll be basing that upon BeagleBone and all the other open source boards. And we also have, just a second. Okay, so SmartPrint Core's 10 stepper driver version actually, because in higher-end 3D printers like the Voron, if you ever seen one Voron, these are very high-end 3D printers. They require at least 10 to 12 drivers, and that was a need by the community. So we have also planned to contribute that by Q2 of 2025. And then we also have SmartPrint Core U2040X. So Raspberry Pi 2040, it would be clearly visible that it is based upon RP2040. And so like that is all. And thank you. And you are invited to a booth. And to the community, we have built a Discord server also, and to the manufacturers also. Thank you.
Hello everyone, good afternoon. My name is Jesus Soto. I work for Canonical in the desktop team. And today I'm going to talk about open source DJing and bringing hardware compatibility to the Linux platform. So first of all, what is DJing? Well, DJing is just playing one song after another. Some of you might not consider it an art, but we must acknowledge that the industry moves billions of dollars a year, and you can see festivals full of, with a lineup full of DJs, so there's something going on there. The DJ setups that you would normally see is the first one, a couple of players and a mixer. This is what you would normally see at the club or in the club or at the festival. Another setup could be an all-in-one. It's a single device that you can just plug your USB and start playing. And the third one, there is a controller. The controller depends on a computer that must be running some software. So the way these controllers work is basically the software generates a couple of audio signals, send it through USB protocol to the controller, and then the controller produces the corresponding outputs to the headphones, to the speakers, and any other signals required. There is a standard for USB audio, but not all of the manufacturers follow it, so that's when the need for drivers starts becoming a reality. And then we have a chicken and an egg problem. Companies won't provide drivers for the DJs because no one DJs on Linux, but you can't DJ on Linux because hardware doesn't work. So how exactly do we break this cycle? I've seen 3 cases so far. The first one is that you have to contribute upstream to the kernel. It's a simple contribution. It's just a data structure in the audio quirks file, but not every DJ is going to be compiling and building the kernel on their own. The second case is a magic message. It's just a MIDI message for the controller to start working, and it follows the protocol, the standard, but the only way to get this message is through reverse engineering, or maybe with the help of the manufacturer. And the third case is just it works out of the box. A year ago, I gave a lightning talk on this subject with the Canonical engineering team, and Cedric Good happened to be in the audience. He used to work for Hercules, which is a hardware manufacturer company for DJs. He helped me get in contact with them, and they sent me a unit. The task was simple, to make it work on Ubuntu and document the process. Luckily, Hercules controllers are compatible out of the box with Linux. They follow the USB audio standard, so it was kind of easy and straightforward in the audio part. And the way to make these controllers work is through Mix. Mix is the most feature-rich and advanced DJ software open source, and it's also compatible with Windows and Mac, so it's a nice start. It also provides a really great learning wizard in which you can just select a controller in the software and move the knob, the fader, or anything, and it will learn automatically how to control it. If you want to do something more complex, like timestamps or having something in memory, you can create a script with JavaScript and just attach it to the mapping. For LEDs, it's kind of simple when it's a button. The message it produces when it is clicked is the same message that you have to send to the controller to turn on and off the LEDs. But the things get a little bit more complicated when there's a standalone LEDs or when you have a performance pad that can have multiple colors or effects. In that case, you need help from the manufacturer or to reverse engineer it. The possibilities are endless. You can load a low latency kernel like Ubuntu Studio does, or you can use a Raspberry Pi and create an all-in-one. With open source, the possibilities are endless, so it's a nice thing to have them working in this ecosystem. I don't have time for a demo because it's a lightning talk, but luckily the organizing committee gave me a spot during the closing party, so I will be performing a DJ set of the 20 years of dance music. So see you there. Going forward, what do we need? More mappings, more controllers to be working on Ubuntu, cool features for upstream mix so that we can have a better ecosystem, docs for open sourcing because we don't want to reverse engineer everything, and support from the hardware manufacturers, and in general, more professional software compatible with Linux so that this brings more pressure to the manufacturers to actually release drivers. And in general, I think this can also help with audio cards, with consoles, with a lot of other things, not necessarily just DJing. Thank you so much.
I can just yell. So with that, give one final applause for all 7 of them. They've been awesome, and it was like a group exercise in public speech anxiety training. You wouldn't imagine how many, they have worn out the floor back there. So we're happy to close out the lightning talks with a big applause for all of them. Thank you. And you might look at the schedule and think, now it's over? No, there is more. There is more, and gonna look for that. this was you. So you're applauding yourself because this was almost all you. So thank you. Good things have to come to an end. This is what we're about now. And let's go full circle. Let's go back where we started, Mark opening with the philosophy behind Ubuntu, with I am what I am because of, because of who we all are, not just the cough that you get after the day. So this is a moment to recognize all the individuals playing into this. It's really a tremendous amount of so many people. So let me thank and ask all of the Ubuntu Summit committee that organized it. Are some of you around? If not organizing, stand up, please. Stand up, and thank you. And do me a favor, keep standing. Keep standing for me. We do that. By the way, the picture proves you need about 12 engineers to create a cardboard stand-up to work. So, yeah, it's really not working out as the way we thought with these. The next group that I really want to applaud is the awesome EA support. Are they somewhere? Oh, thank you. If you ever wanted to know how a weird day looks like, just stay there for 5 minutes and see the requests that come in. When I was first learning computer science, my professor said, computer science people are problem solvers. You are computer science people. You solve problems. Thank you so much. Then, absolutely worthwhile, all the canonical support, which is mysteriously behind the scenes working to make everything work. They are the people with earpieces, and they just make things happen. If you think there's not been going on much, because behind the scenes. So, thank you for posing really well for my photo. I will misuse that another day. Are a few of them here? If not, oh yeah, thank you. Also, their dirty secret, if you ever have been in line for coffee or something, they had their very own coffee place, like 10 people or however many you are, want their own coffee place. So yeah, that's how you roll. Then, from behind the stage, you start to line up. Thank you so much. The canonical, you said canonical event support? Yeah, they don't have a good name, but this is what we used. Canonical event support. Really. So, is there some light control still? Can we for a second get really bright lights? So these people live in the dark all day. They are deprived of vitamins. So just blast them for a few seconds and then we're good. I might have rushed this person, sorry. Or not. Okay. At some point you'll get some light and maybe you are let out for a few hours throughout the week when we have no presentations. Thank you. There's another group, which is all the presenters. Sorry, Frodo, I accidentally had a picture of you. But all the presenters that have been here throughout all of the weekend, please, without you, where would be the content? Where would be the fun? You have been doing awesomely well. I saw so many of you today behind the stage. I saw several in the booth. You'll be great. So please, stand up if you have been a speaker here. If you can. You see, we feel it. We feel it. Awesome. Again, stay standing if you can. I see some people forgetting the rules. Stay standing. Then, stuff at the booth. The booths wouldn't be anything without, it's just a poster without the people. And you've seen in the video all the engagement and the work. So, if you have been working in a booth, please stand up. You have deserved it just as much. I see some of them hiding already again, so they love the dark. And then, very much not least, but last in this listing, you, if you have been attending this event, this is why this exists. Without you, it would be a hollow shell. So, if you have been attending this event, please stand up. This is for you. So if you have not been standing up, you either have not been paying attention, or you have an injury, and we feel sad for you. That is the story of the Ubuntu Summit 2024. Thank you all so much. Don't forget, there'll be a big party at the church, at the Grote Kerk, which just, some people at the sprint said, the hardest thing you can do in project is naming. I heard this last week, I heard this on the weekend. Come on, take inspiration from Den Haag. This is just big church. It does not have to be complex, really. And if you struggle to find there, remember from a morning session, which, to be honest, not even 50% been here. This is my pirate map for you. This is how you get there. See you in a bit. Take this, whatever navigation system you want. The paper is still with me somewhere. Thank you all.